proceeding with our technical sessions. We are entering in the first technical session of today, which is based on Introduction to IoT Research and Challenges. Ladies and gentlemen, we are having a great opportunity to listen to the words by a great knowledgeable speaker. I am talking about Professor Muralidhar Kulkarni. He is Professor and Head, Department of ECE, NITK, Surathkal, Mangalore. Professor Muralidhar Kulkarni received his PhD in Electronics and Communication Engineering for JMI Central University, New Delhi, MTech in Satellite Communication and Remote Sensing from IIT Kharagpur, BE from University Vishwesvaraya College of Engineering, Bangalore. He is Professor in Department of ECE, NITK, Surathkal. He worked in the capacity of Members of Board of Governors, Professor in Charge. He also worked as officer on special duty at Indian Institute of Information Technology, Dharwad, on deputation. He also worked as Associate Professor, Department of Electronics and Communication Engineering, Head of IT Department, Head Computer Center at DTU, Delhi. Prior to this, he was Assistant Professor, Department of Electronics Engineering, University Vishwesvaraya College of Engineering, Bangalore. Before switching to the academics, he worked as Aeronautical Engineering Hall, Bangalore, and Scientist 3 Instrumentation Division, Central Power Research Institute, Bangalore. He is Senior Member IEEE, Fellow IETE, Life Member ISTE, and Life Member CSI. His research interests are digital communication and networks, OFDM, WSN, SDN, congestion control, 5G networks, IoT, optical communications and networks, microwave and antenna system. He completed a number of sponsored research and currently working on ISRO Respond project, programmable photonic microwave signal generation using on-chip spectral chipper for satellite communication, and has been recommended for funding support of 22,51,203 rupees. Under his supervision, 8 PhDs are awarded, 2 PhDs submitted waiting for reports, and 3 ongoing. He published 35 papers in international and national journals, 61 in international and national conferences, and 9 book chapters. Books and books chapter. He has delivered many invited lectures in India and abroad and chaired many scientific international conferences and symposiums. It will be my honor to invite Professor Muralidhar Kulkarni for his visionary words in this field. Over to you, sir.
Good morning, sir. Dr. Vikas Gupta.
Namaskar. Nice
Namaskar.
seeing all of you. Namaskar. Namaskar to everyone.
And sorry for waiting because
thanks for a good introduction taken from the. Yeah, we are supposed to start something like 10 o'clock. We are 36 minutes late. Actually, it should not matter, I guess. Yeah.
Okay, sir.
Yeah.
Thanks a lot.
Yeah.
So
shall we start with the technical session in that case?
Yeah. Yes, sir. Bilkul. Sandeep.
Yeah.
Sandeep, sir.
I'll start sharing my screen. Yeah.
Yeah. Sir, you can share your screen.
Yes, we did it. Yeah.
Share my screen. Okay. Is the screen visible?
Yes, sir. Yes, sir, it is visible.
And you are able to hear me as well?
Yes, sir. Perfectly.
Yeah. Should I stop the video because it's going to take a lot of bandwidth? Because most of us, are used to online classes now. We generally ask the students to keep their videos off because, the quality of communication, would be better, when people switch off their videos. So shall I put off the video of myself first and ask the rest of them also to switch off their videos?
Yes,
sure,
okay.
Yes, sure, sir.
Yeah.
Sure.
Okay. So my video is not going off. I don't know why. Okay, Dr. Vikas Gupta. Okay. Mhm. You are able to see the full screen?
Yes,
Hello?
sir. Yes.
You are able to see the full screen? Okay. So today's lecture is the first lecture on this FDP, on Internet of Things. I thought, I'll cover a few fundamentals. Already the speakers during the session, inauguration session have already given, a very good introduction on Internet of Things. I would slightly go deeper into it, nothing more than that. Okay, the director of the institute and the chief guest of the function, have really introduced Internet of Things, in a very nice way. I would also start with my first lecture, first slide. Okay, I have designed my lecture of these 2 hours, under these headings. This will be the I'll just talk of evolution of the internet. Okay, how the internet has evolved into what is now Internet of Things. Then I'll think of what is IoT. Then go to a little bit of history, and we'll also look at how IoT works. And we look at the current status and future prospect of IoT. Then how the data which we collect from several sources. Okay, how that data can be converted to wisdom is the major thing called knowledge management. So one slide on knowledge management will also be dealt with. We also look at the prospective and business perspective. So this is the major thing which all of us are working for. How to make money out of whatever you do. Okay, that is the business perspective. Okay, and what is the IoT value chain. So one slide on each of these. Then we look at various IoT technologies. I think all of us are aware of RFID. Okay, wireless sensor networks. Okay, MANETs and COT. Okay, I'll
Excuse
tell
me,
you
sir.
what these
Sorry to
are
interrupt you,
as we
sir,
go.
please. Sir,
Yeah.
we are not able to see the full PPT view of your video. So if it is possible, you
Is it?
can switch it to the slideshow view.
Okay, okay. Now is it visible?
Sir, you can press F5, I think, so that full window will
Yeah,
be there
I
for you.
have done. Yeah, I have done that, but still, it's not coming up. I've been trying, but I don't know why it's not going to full screen. Let me slightly increase
Sir, you can go
the
to this from
size.
current slide. I think from here it will be.
Yeah, now it is visible, full slide, full
No,
screen.
sir, not full screen is not visible now also.
Oh God, what is the problem? I'll share the the PDF file of this. I think that should be showing me the full slide. Let me share the other one. Okay. Sorry for this. I'll take just 1 minute. Is the screen visible now?
Yes, sir, it is visible.
Is it full screen by the way?
Yes, sir.
Hope you are seeing the full screen now.
Yes, sir. Thank you very much, sir.
Okay. Sorry for this. So I was just trying to tell you that in what way I'm going to go through the lecture today. So we'll talk of evolution of the internet. Then we'll look at what is IoT. Look at some history and how IoT works. The current status and future prospects. How data can be converted to wisdom. We call it as knowledge management. Then we look at the business perspective and the value chain. We also look at RFID, the wireless sensor networks, MANETs, and cloud of things, cloud of things, COT. And then we also look at the R&D. This is what would be most interesting to all ENC engineers or ENC faculty who are participating probably in today's lecture. We also look at the future of IoT and how the 5G technology which is going to come next year in India, how IoT is going to change, how 5G will be. Okay, that also we'll look at probably 1 or 2 slides. and what is the potential of IoT, then, a few applications of IoT, then what are the research challenges, of IoT also will be looked at. Of course, there are always some criticisms and controversies. I think already professors have talked about the privacy aspects and okay, the security aspects. They will be the major issues of IoT, and I'll show you some references, from where, I have taken most of this information is from the internet, and how internet has evolved into IoT is the main stay of this lecture. Okay, so let us start with how internet has evolved into IoT. I think all of us know how internet growth and evolution has been very phenomenal, and it's still an ongoing process. Okay, we looked at 1G, 2G, 2.5G, 3G, 3.5, 4G, LTE, 5G, 6G, and so on and so forth. So it's going to be an ongoing process. Similarly, IoT also will be an ongoing process. In fact, in just 25 years, it has grown to link, billions of people, through computers and mobile devices. This is already we are experiencing right now. In fact, the internet is being used to connect, the various objects, such as cars, sensors, controllers, TVs, machinery, transport containers, electrical appliances, at your home and office, as well as an industry. In fact, all of these devices or objects, have really created the Internet of Things. To be frank, IoT is also called as Internet of Everything. In fact, everything can be connected to the Internet. That's why, nowadays, IoT will be referred to as Internet of Everything, no more IoT. It is also called the Web of Things. Okay, and if the same IoT is used in industry, it will be called an industrial internet or industrial IoT. Then we also have heard of, mission-to-mission communications, M2M, mission-to-mission communication. That means, we need to network all the physical objects which we can see or feel. Okay, the physical objects will be networked together, which will contain, electronics embedded within their architecture in order to communicate and sense, interactions among each other or with respect to the external environment. So in the upcoming years, IoT-based technology is going to offer, advanced level of services which you have never thought of previously, and practically change the way people lead their daily lives. In fact, you have seen several advancements which have happened in the area of medicine, power. I think Professor was talking about smart grid. So medicine, all of us are very much familiar, wearing smart watches, wearable devices. Okay, the hospitals have turned into, IoT already. And we have also talked about smart homes. Okay, in fact, even the gene therapies are going to have a lot of, things which will be connected to the internet. So in agriculture also, we have seen most of us, work in wireless sensor networks, how, agriculture is going to see a big change the way we do agriculture, again, because of sensor networks or wireless sensor networks or, IoT in general. And I think this government has really thought about smart cities, and already smart cities have been announced, and we are going to see smart cities. May not be, possible within 5 years. Maybe the next 5 years, you will see things happening. At least in Mangalore city where I live, I see, smart city happening. In fact, the roads have been widened, and people have pathways, to do cycling, and people are able to walk on without any problems. Okay, we have already seen, smart grid connections within at least our campus. We have a big project, running in NITK Surathkal. We have a smart grid project which we got from MHRD to the tune of something like 3.5 crores. We have been able to establish, some kind of a smart grid within our campus. We also have a smart water management system. A lot of water used to get wasted within the campus. In fact, particularly in the hostel areas, students used to leave their taps, open and, just go off. So a lot of water was getting wasted, a lot of leakages in the pipelines. All of that has been controlled by designing some kind of a IoT system, okay, which will monitor the way water is flowing through the water pipes throughout the campus. Okay, so that has been one of the projects, which our BTech students took up. And in a span of something like 2 years, we have been able to save a lot of water. We used to send our students back home during summers because we don't have water. Now that is no more the situation. We're able to retain them even during summers. Okay, so that's how, smart cities, smart campuses, smart agriculture, smart home. Okay, everything has to be smart nowadays. Okay, people also have to be smart. I think as the earlier speaker has already talked about, how the physical objects, how many objects are connected to the internet. As of now, around 10 billion things are already connected without our knowledge. In the near future, this number is expected to rise to a whopping 50 billion, or even in the next 5 years, people are looking at 100 billion devices, which will be connected with 5G and 6G in place. Okay. Uh, so we should talk about IoT, and we will be talking about, all of us will be talking about IoT. In fact, all the departments, the mechanical department, whichever department you go, people will be talking about IoT. It will truly become an interdisciplinary area. In fact, all disciplines would be required to do what is called as IoT today. Uh, in fact, there are major 4 components in IoT. As earlier, Professor has talked about low power embedded systems. Okay, so all these objects, when they have to get connected, okay, they need to have sensors. Okay, and sensors should be embedded. Okay, with very less battery power consumption and very high performance. And these two are not possible together. When you reduce the battery consumption, performance will take a hit. So they are basically inverse factors, but that play a very significant role when you design electronic systems. So we as electronics and communication engineers play a very vital role in designing low power embedded systems, but which have to perform high performance. Okay, is the requirement. So these are complementary factors, very, very difficult to achieve, but still we have been able to achieve in a smaller way. Okay, so he talked about the 3 layers. Okay, where we have the physical objects, okay, with embedded systems, nodes as we call them. Okay, IoT node. Okay, from nodes, we have sensors, which collect data, and this data collected through IoT devices is so massive because around 50 billions of them, if they have so much data to keep actually throwing data, actually they actually throw data. So it's really massive data. That's why we talk of big data nowadays, and this data has to be stored on a reliable storage server. Okay, our server should be really reliable, and this is where cloud computing comes into picture. Okay, so the data has to be processed. In fact, it has to be learned. So AI and ML techniques will come very handy now, because you have big data. It has to be processed very smartly, very efficiently, very fast. We have to giving more room for us to discover where things like electrical faults or errors which occur in a smart grid, they must be immediately informed, so that they can be controlled automatically. So that is the requirement of future, and to a certain extent we have already achieved this. So this availability of big data, we know that IoT relies heavily on sensors, particularly in real time. As these electronic devices spread throughout every field, their usage is going to trigger a massive flux of big data. So big data analytics is really big, really massive, and hence as Professor Sharma has told you, computer science people will have to do a lot of processing in a very smart way to cater this. You have to analyze this big data very efficiently. This is the requirement. So cloud computing, big data are really big, and all the jobs are going to be in this area in the near future, along with VLSI, where the embedded systems or the IoT nodes have to keep shrinking. We'll come to that very soon. Most important, the communication engineers are also important when you set up IoT devices in this fashion. So in order to communicate, the internet connectivity, you know that it is a must. Without internet, IoT is not just impossible. It's a must, where each physical object have to be represented by what is called as an IP address. All of us know about IP addresses. Okay. However, there are only limited number of addresses available according to the IP naming, which you already know. We have heard of IPv4 standard and IPv6 standard. Even with the 128-bit addressing of IPv6, the number of addresses will become far less compared to the number of physical objects which are going to be connected in an IoT system. So due to the growing number of devices, this naming system may not be feasible anymore. That's what I feel. Okay, therefore, we as researchers should look for an alternative naming system to represent each physical object. So that is where networking people come into picture. How to go away from IP naming, go to a different naming system altogether. So that is a big challenge. So there are two ways of building an IoT system. We need a separate internetwork, including only physical objects. Okay, that's what is being done right now. We have to form a separate internetwork, okay, or internet as we call them, including only physical objects. Make the internet even more expansive. Okay, it is not yet ready still for going to 50 billion or 100 billion devices, but this requires very hardcore technologies like rigorous cloud computing, which we are talking about, rapid big data storage, which is going to be really expensive. It is still not so in the near future. IoT will going to become broader and more complex in terms of its scope. It will change the world in terms of all of us have heard about anytime, any place, anything in connectivity. Okay, when you want to connect, particularly among the various physical objects, including people and things. Okay, anytime it should be available, any place and anything you should be able to connect. So there is a lot we as communication engineers will have to do in the near future, and we have to a certain extent been successful when we actually developed RFIDs. We know that in fact IoT enablers. In fact, RFID was the first enabler of IoT. So in fact RFIDs use radio waves in order to electronically track the tags which are attached to each physical object. I think all of us know about the toll gates today. We don't have to wait at all at a toll gate. So just put a RFID tag, okay, on top of your, stick that sticker, okay, you are done. So that tag, is automatically read. In fact, you don't require anybody on the toll booth at all. Earlier, you used to have, strong men stopping cars, particularly of politicians and bigwigs who don't want to pay, toll. Okay, so now nothing like that. So you will not be allowed, everybody will have to have the tag, and you can pay it instantly and go away. I don't see any rush in toll gates today because of this IoT enabler called RFID. So I also told you sensors become another enabler. So sensors are the devices that are able to detect changes in the environment, for example, motion detectors, etc., etc. So anything any environmental condition, including the parameters, the health parameters of a human being. We need to. So sensor technology is very, very big. In fact, Indian Institute of Science is working very nicely in a very big way on sensor technology. We are able to develop, several kinds of sensors. You name anything, okay, that can be sensed today. Okay, the third enabler is the nanotechnology, as the name itself suggests. These are extremely small devices, with dimensions less than, a few hundred nanometers, a few tens of nanometers today. Okay, so again, VLSI engineers, electronics engineers will have to play a big part in developing this technology. So nanotechnology and electronics go hand in hand. So the physics people, electronics people, in fact, several disciplines have to come together to make this possible. Okay, and as I told you earlier, internet has to be really expanded, and this internet has to become really smart. So requirement of smart networks, okay, is another IoT enabler. Okay, so if you look at the characteristics of IoT, okay, we need highly massively scalable and very efficient architecture for my IoT. And I told you IP based addressing may no longer be suitable in the upcoming future. You have to look at a different naming system, because we are adding physical objects day in and day out. So this abundance of physical objects that do not use IoT IP addresses, so IoT should be made possible even without IP addresses. Okay, and the IoT nodes have to consume as less power as possible. The best way to do it is when you are not using, when you are not using, these IoT nodes, okay, they can be automatically programmed to sleep. So this is one way of, reducing, power. So there are various ways of, reducing, power consumption of these IoT nodes. So a device, that is connected to another device right now may not be connected in another instant of time. That means, the delay involved in connecting things should be as small as possible. Okay, that is another, characteristics which people are looking at. And intermittent connectivity, okay, is what is required for IoT. You may not be connected all the time. So what I mean to say is, fortunately, IoT devices, can keep collecting data. It need not be sent immediately, okay, unless, it is very, very important data. So IoT devices aren't always, connected. So in order to save bandwidth, as I was talking about right in the beginning, to put off our videos, okay, and battery consumption, device will have to be powered off, periodically when not in use. Otherwise, the connections might turn unreliable and thus prove to be highly inefficient. So as a quick note, IoT incorporates trillions of sensors, billions of smart systems, and millions of applications. In one word, if I can talk about IoT as an introduction, okay, IoT incorporates trillions or even more, more number of sensors, billions of smart systems, and millions of applications. As I told you, there are several application domains of IoT. Okay, you have several popular domains. Okay, as Professor Sharma was talking about, mechanical engineers, particularly in manufacturing and industry businesses. In fact, this will constitute at least 40%. So manufacturing and industrial IoT is going to take 40% of the IoT domain, which will be in place in the near future. Healthcare is around 30%, and the security aspects will be around 8%, and retail sectors will be around 8%. So what I mean to say is, 4 different popular domains are being thought of in IoT. The first one is the manufacturing and industrial IoT, then the healthcare IoT, then the security IoT, and then the retail IoT. It doesn't stop there. There are several other applications. So we did talk about smart grids and how to save energy, okay, how to save water. We're talking about smart cities, talking about smart homes, okay. Healthcare, should really become extremely smart, okay. Disasters are very common nowadays, particularly earthquakes, hurricanes. All these have to be detected in time, and so that many lives can be saved. We also have a problem of radiation due to IoT devices. When millions and trillions of IoT devices are in place, they might, because internet will be using RF signals. Okay, there could be some hazardous problem, health effects also on human beings. So this could be a negative point of IoT. So we should be able to detect the smartphones, as I told you about water flow monitoring, etc., etc. So in a small way, I have finished the evolution of internet and how we have come up to smart wearables, traffic monitoring, water flow monitorings, all these several application areas we have covered right in the third slide itself. Going to the next slide. Are you able to see the next slide? I'm sorry. Hello.
Yes, sir.
All of you are there, or I'm simply speaking and speaking? I'm sorry. Just
Yes,
trying
sir,
to give.
Yes, sir.
Yes, sir, we are there. We are listening.
Okay, thank you. It looks like it's a one-way communication. So
No, sir,
let us make it
We are thoughtfully
okay,
listening,
okay.
sir. It's great.
Okay, thank you
Great
so
knowledge you are
much.
sharing.
Thank you so
Sir,
much.
sir, we all are present here. Just because you said.
Okay.
Yeah.
Yeah, I'm just looking at the slide. I don't look at people who are around.
Yes, sir.
So I think my video is not going off at all. I don't know what is happening. My audio still is visible. I wanted to put it half. How to mute this stop video I'm saying, but it doesn't go. Okay, this is the problem of internet even today. Okay, not able to. Okay, I'm back to the slide. Is that fine? I think my video is not going. You can.
Sir, it is fine.
All the time.
Sir, it is fine.
It is fine, no?
Yes, sir,
Okay,
perfectly
okay.
visible.
Okay, so I'm going to the fourth slide now. The big introduction is already over. I'll get back to the slides now. I'm sorry. So the IoT, reaches out into the real world of physical objects, creating, cyber physical systems. I think all of us are hearing about cyber physical systems. Okay, I think there is a big unit, in DST today, Cyber Physical System Group. Fortunately, being handled by my own classmate. Okay, if you want funding, for IoT, just go to DST. You will get, crores of funding. Okay, so IoT reaches out into the real world of physical objects, which we call it as a cyber physical system. So by the year 2022, as I was just now telling you, 100 to 200 billion things will be connected to the internet, facilitating human to human, human to thing, and thing to thing, which is also called M2M, mission to mission or thing to thing communication. In fact, it can collect, data and automatically transmit, the data to servers, okay, which are basically in the cloud now, where useful data analysis, can be performed. So the end game is to get, deeper insights and real-time feedback that can help you make faster and better decisions have to be made. So there is a big potential which will have a huge impact on manufacturing. Just now I was telling about it, healthcare and public utilities and other areas. So whatever I spoke, just like that, are being pushed into each point on my slides. I'm sorry for repeating. So there will be several repetitions during my lecture. You have to pardon me on that. So the IoT facilitates, deployment of many new applications and services, and there will be no end to the applications which will be added and the services, which IoT will be able to offer. In fact, it has to change. It has the potential to change the world, just as the internet did several years ago, maybe even more. Okay, so time is ripe to look at how we can leverage and benefit from it. So we can optimistically look forward to an IoT-assisted world that is connected in a very smart way, much better way, and it will also be sustainable. That's very, very important. So whatever we build, okay, this IoT assisted world must be sustainable as well. No doubt it should be smart. No doubt it should keep giving you better and better services, newer applications, but it must be sustainable. That is where the problem is. That is where the problem is. That is where the problem is. I'm not able to write on this. What happened? Where are the other tools? Oh God. No, that's why I was using, the PPT mode where I could, mark out things. Anyway, you are not able to see full full slide otherwise. So what is IoT? Coming to the next point. So the definition of things in IoT vision is very, very wide, and many people, talk, differently about IoT. So IoT vision, enhances connectivity from anytime, any place for anyone into anytime, any place and for anything. So we have to go from anytime, any place for anyone into anytime, any place for everything. So for anything, not anyone, for anything. We are also part of, we have become things now. We have become things now. So people have defined, IoT in different ways. So Gartner, says IoT is the network of physical objects that contain, embedded technology to communicate and sense or interact with their internal states or the external environment. This was a very early definition. And Wikipedia, tries to collect data from everywhere and puts it, like this. IoT refers to uniquely identifiable objects with their own IP addresses. That's what it actually means. And their virtual representation in an internet-like structure. A very generic definition. So finally, IEEE Internet of Things Journal came out with the real definition of IoT. In fact, an IoT system is a network of networks. So you remember earlier, internet was talked of as network of networks. In fact, IoT system also is a network of networks, where typically a massive number of objects, things, sensors, or devices are connected through communications and information infrastructure, that is the network infrastructure, to provide value-added services like intelligent data, data processing, management for different applications, we have looked at different applications like smart cities, smart health, smart grid, smart home. Everything has to be smart, including ourselves. Okay, the human being has will become less smart, when all these things come into picture. Smart transportation, smart shopping. Okay, so this looks, a very good definition of IoT. So IoT is everything of this. IoT is everything of this. Okay, so anytime connection, anything connection, anytime connection, and any place connection. So on the move, whether you are outdoor or indoor, whether you are during daytime or nighttime, whether you are talking between PCs or human to human, if you're not using a PC, human to thing, or using generic equipment, thing to thing, okay, any place, you could be on the PC, okay, or you could be indoors away from PC or outdoors, or you may be on the move using your mobile. So from any time, any place connectivity for anyone, we will now have connectivity for everything. So that's why we say Internet of everything. So IoT is no more IoT, it is Internet of everything, Internet of everything. Okay. So which are these things in IoT? So things in the IoT, are basically human beings, all of us, or, other things, which are available in nature. Okay, there could be missions also. So all physical entities will be things in the IoT. Okay, so all our 5 senses, will be part of the things itself. Your mobile phone, your vehicle, anything you see, okay, you can feel is basically, a thing. So their identity and state, or the state of their surroundings can be related to the internet connected IT infrastructure. So almost anything to which you can attach a sensor, even a cow in a field, a container on a cargo vessel, the air conditioning unit in your office or at home, a lamp post on the street, okay, could also have sensors, or IoT nodes, already for VANETs, vehicular ad hoc networks, VANETs. So it can become, a node in the Internet of Things. All these things can become a node in the Internet of Things. Okay, so sensors basically, gather or disseminate data. So the sensors could be. I think somebody is also talking to their friends. That's good. I think one should be talking to each other whenever you do something. That's absolutely fine. So which are the various types of sensors? It could be a location sensor. It could be an altitude sensor. It could be a velocity sensor. It could be temperature sensor, illumination sensor, motion sensor, power sensor, humidity sensor, blood sugar sensor. Okay, air quality, soil moisture. Oh God, I can keep continuing this. Many more of those can be sensors here. So anything can be, okay, anything which you see or feel can be a thing, and all of them you should be able to sense. Okay, so when you go to the history of IoT, from Internet of People to Internet of Things, you can see earlier the people were very small in number. Now that all physical objects are connected, so the things are going to increase in a very big way. So in 1990s, we had hundreds of millions devices and human beings connected, and in early 2000s, billions. And when you go to 2020s, it will be tens of billions. We talked about 50 billion. It could be even 100 billions. Okay, by the time 2020s end, you will have tens of billions. Okay, things being connected. So it all started not very long ago, only in 1997. Okay, the Internet of Things is the 7th in the series of ITU Internet reports, originally launched in 1997 under the title Challenges to the Network. So it came as a challenge, and one Mr. Kevin Ashton, okay, in MIT, he founded, okay, Auto ID Center. Okay, so Kevin Ashton is the kind of father of IoT, if you can call him. Okay, and in 2003, he formed a EPC global system, again, Kevin Ashton and his colleagues. And in 2005, 4 important technologies of the Internet of Things was proposed in the first conference. In fact, in 2008, the first international conference of Internet of Things happened. I happened to be part of this Zurich conference. So the IoT 2008 was the first international conference of Internet of Things, which was held at Zurich. Okay, so Internet of Things is not very old, just 2008. In fact, I joined NITK Surathkal in 2008. I used to work for DCE, Delhi College of Engineering, prior to 2008. Okay, so Internet came, when I came to NITK Surathkal. So IoT is as late as, me joining NITK Surathkal. Okay, So continuing with history of IoT, as I told you, the concept of IoT was proposed in 1999 through the Auto ID Center, which came into picture in 2003 exactly. So as I told you, RFID was the IoT enabler, which was seen as a prerequisite for IoT at that point of time. So RFID is no more a prerequisite. It can be anything, any sensor, need not be an RFID tag. So if all objects and people in daily life were equipped with identifiers, they could be very well managed. So besides using RFID, the tagging of things may be achieved through such technologies. I think all of us know about NFC, near field communications. We are very familiar with barcodes, QR codes. Every time you buy a pan, okay, in a pawn shop, okay, fellow keeps, a QR code. Just, you can pay through your Google Pay or whatever pay you have, phone pay. So QR codes have become, order of the day. Okay. I never give cash to anybody, for buying milk or anything for that matter. Just, keep using your Google Pay through your mobile phone or QR code. In fact, people send QR code on your WhatsApp, and through WhatsApp, you can easily pay wherever you are. So that is already possible today. So we all know about Bluetooth technology and digital watermarking. So from 2010 onwards, things became really useful. We had Wi-Fi with the wireless access points. We had wearable watches which can monitor almost all parameters of your health. Of course, sugar monitoring has come only recently. Apple is working on it. So there will be a sensor to monitor your sugar level as well. Although, we are able to measure your heartbeat rate, and even the BP can be measured already. So Apple has come out with the latest watch, which will be able to measure your sugar levels as well. So TVs will be connected, the refrigerators, anything within the house, anything within your office, anything on the road, anything in your car, all of them will become part of IoT very soon. Okay, so if you just look at how IoT history came, earlier, we had a network where, the PCs were being connected either in a local area network or a metropolitan area network or a wide area network. Then the internet came into picture where we had WWW, World Wide Web. And then, we were able to connect our mobile to the internet. Okay. So mobile networks, became very important. Okay, after the internet. Then, mobile plus peoples plus PCs. So even people were able to contact, through their mobiles or otherwise through Internet of Things on your wearable devices, you are able to connect. Okay, so mobiles plus people plus PCs next came, and now it is the Internet of Things. You name anything, whether your house and all the things in your house. Okay, nearby your house, if any burgling is happening in your house, you can find out, even if you are in the US, you can monitor your house in your Bhopal house, if it is being chori kar rahe, to immediately aapko pata chal jayega. So police can be informed instantly and they can be nabbed. Okay, so the mobiles are already connected, the cars are being already connected, refrigerators are connected, people are connected, TVs are connected. You're all interconnected objects now. So people also have become things. So technology advances are expanding the boundaries of the internet. No boundary for internet at all today. So the device processing power, storage capacity are increasing, while the technology is making devices smaller and smaller. So devices are increasingly fitted with sensors and actuators. I think all of us have heard of MEMS. Okay, so we'll have sensors as well as actuators in place very soon. Okay, so what is the influence and what is the structure of IoT? As I telling you, we should have people. There should be a process. There should be data, things, and IoT will be connecting. In the 2005 report itself, they said all objects will have sensors and they will be able to communicate in an intelligent manner. So people will become more capable. More complex tasks can be established in lesser time. It will result in more accurate decision making. So mobile devices and things become more valuable. And in fact, there are 4 dimensions of IoT. There are 4 dimensions of IoT. One is tagging things. To identify items, we need to tag. So tagging things is very important. So for feeling things, you should have sensors and possibly, wireless sensor networks. And we should also have, things which can think. It is not just necessary to feel things or tag things. We should be able to have things which can think as well. So embedded systems should become intelligent. They should be able to think as well. And nanotechnology means, things have to shrink. So shrinking things, thinking things, feeling things, and tagging things are the major influence, which IoT is going to bring in our lives. Okay. So continuing, tagging things. Okay. So real-time item traceability and addressability by RFIDs. So feeling things, as I told you, sensors will act as primary devices to collect data from the environment. Shrinking things, I told you, miniaturization of devices. Nanotechnology has provoked, the ability of smaller things to interact and connect with the things or smart devices. So thinking things, embedded intelligence in devices through sensors has formed the network connection to the internet. Okay, so you can think of IoT as a gigantic network consisting of network of devices and computers, connected through a series of intermediate technologies with numerous technologies like RFIDs, okay, wireless networks, okay, cloud of things, okay, COT, as I was telling you, okay, cloud storage, big data analytics, all great technologies will come out of IoT itself. Okay, so how does IoT work? So IoT is, not result of a single novel technology. Professor Sharma was talking about it, in his introductory lecture. He said, all departments are required to make IoT work. So it cannot be a single novel technology. Instead, several complementary technical developments have to provide capabilities that taken together will help to bridge the gap between virtual and the physical world. That is, cyber physical world, which I was talking of. The capabilities will require all these things. Okay, the things are, okay, communication and cooperation. We should be having addressability, possibility, identification, sensing, actuation, embedded information processing. We should be able to localize. So there should be several user interfaces required. So a lot of engineers, ENC engineers, IT engineers, computer science engineers, mechanical engineers, okay, nanotechnology people, materials people, okay. In fact, all subjects will have to be, all experts have to be there to make IoT work. Okay, so how IoT works is you should be able to identify and track the data of things. So maybe through RFID devices, we should be able to collect and process data to detect the changes in the physical status of things that is done by the sensor. Then we should be able to enhance the power of the network by devolving processing capabilities to different parts of the networks. So you must have smart technologies, okay, smart networking devices which can do this, smart technology keep on increasing, and of course, nanotechnology to make the smaller and smaller things which will have the ability to connect, and also interact. Okay, so as I was talking about business perspective, why people are doing IoT is to make money. So you must be driver of all this connectivity is essentially to add value to the products or services. If you remember, earlier we used to get handset for $100. Okay, if I want to buy a smart device, I have to spend something like $600. If you buy an Apple iPhone, it's going to be something like $600 to $1,000. But if you buy an Android phone, it will be less than $100 as well. Okay, so if I want my device to be smarter, you need to pay more, and hence people can make more money. Okay, so the business additional profit, Cisco has studied around 613 billion. Okay, profit was being additional profit will be made because of IoT. So potential of using internet only 50%. So 14.4 trillions net profit for the coming 2 decades is what Cisco has said. Maybe they will make much more than, because Cisco is the major network service provider to make IoT possible, and they expect to make several billions of dollars in the next decade to come. Okay, so you can see here in 2003 the number of connected devices per person was only 0.08. Okay, the world population was 6.3 billion and 500 million devices were connected. So more connected devices than people. So when people went from 6.3 to 6.8, this connected devices went from 500 million to 12.5 billion. Okay, and that was in 2010. So 1.84, okay, connected devices per person. So in 2015, the population increased to 7.2 billion, but this went from 12.5 to 25, doubled. Okay, And in 2020, we're talking about 21, 22 now. Okay, from 7.2, the population increased only up to 7.6 billion. Whereas you can see here, it has in the 2020s, in the time to come, it has doubled already. Okay, 25 billion to 50 billion. In the late 2020s, it's going to be 100 billion. It's going to be more than 100 billion. That's what I feel. It may even, triple. So that's what we are going to see. So change is the only thing which is permanent. The change is the only thing which is permanent in this world. So we have to keep changing. Okay. So we are talking about, IoT as a network of networks. I did talk about, IPv6, although it has increased the number of internet devices by using, 128-bit as part of the IPv6 protocol. That may not be good enough at all because, several networks have to be connected. There will be a transport network. There will be energy network. Earth itself will be, have to be connected. Home, smart education. I think all of us are doing online classes now. Online evaluation, everything is going online. Online businesses are happening. Smart transport, smart energy. Okay, so all of them will get connected together, and each of these individual networks also have to be connected. All of them have to be connected as well. So with security and analytics and management of these networks become really complex. Okay, so we have to have added security, added data analytics, added management capabilities, management of the network, management of people and things. So this will allow IoT to become even more powerful in helping, okay, people achieve, much more complex tasks than what we can think of. Okay. So I was talking about knowledge management. Okay, if you look at data, it has become very, very less important now. So all these slides, I have taken from the internet. Of course, I didn't put, references in every slide. I put it at the end of the all slides. The more data that is created, the better understanding and wisdom people can obtain. So you can see here, data is at the bottom of this triangle. Okay, then comes information. So information is nothing but, it gives answers to who, what, where, and when. So we will keep asking, how is basically knowledge, how things work, okay, how data can be analyzed, okay, what is the data all about, where is the data available, when is it going to be available, how does it work, what is this data all about. So first, you need to understand also. So you should be able to appreciate, why things are happening like this. How, who, what, where, when, and how, and why is actually the understanding. All of this may not be so important. If at all, we have to have wisdom. Okay, we must be able to evaluate that understanding. So most important is how to turn data into wisdom. So that we call it as knowledge management. So that is nothing but knowledge management. So we have to convert data into wisdom. We have to go from here to here. Okay, we have to go from bottom to the top tip of the triangle. That is what is the wisdom. You should be able to evaluate the understanding of why, how, who, what, where, and when. So then only, knowledge management will be done properly. Okay. So we are talking about, IoT communications and perspective. I told you about local area networks, how they have gone wireless. Okay. And wired links, could be within the house. If it may be possible, even within house, we want to have a TV which talks to you. I give, I can just give the channel name. Okay, immediately. Okay, you can talk to the TV today. Okay, I think most of us have Geo connections at home. So I have an internet TV now. Okay, I have 300 megabits of data. Okay, and everything, has gone already wireless in my house. Same thing could be happening in every house today. Earlier, we are using Ethernet, home plugs, home PNA, home grid, okay, LON works, etc. Now all of them have gone wireless. Okay, so wide area network, all of us know about GPRS, GSM, 3G, 4G, 5G, LTE systems, 6G systems which are going to come. Of course, WiMAX didn't pick up. Okay, it has become less important now. So if you look at, from 2003 to 2020, okay, how less number of humans were there and more number of devices are going to be there in 2020s is explained by this particular graph. Again, this is taken from Cisco. Okay, so humans were somewhere here and internet connections is going. So requirement of internet has become more and more important. Okay, so more internet connections, because number of human beings is far less than the number of devices, which you are thinking of. 7.6 billion and 50 billion. That is the kind of thing. So IoT needs acceleration. So we have to accelerate to develop, IoT systems in this world. Okay, so we need to have better microcontrollers with lesser price and high performance. We have to have advancement in sensors. We must know how to design wireless devices which can connect extremely at a fast data rate with very less delays. Okay, that is what is the requirement. We should be able to develop several applications, and we should have cloud-based software and infrastructure. So IoT can be accelerated by these things which are explained here. So it's all about electronics again. This is also about electronics. This is also about computer science and IT. This is also about computer science and IT. This is definitely our domain, wireless connectivity and pricing. So 1, 2, 3, 4, 5. So all of that is the domain of E&C as well as CS and IT. That's why circuit-based branches will only survive, although mechanical will be part of circuit branches very soon. So our new education policy is talking about interdisciplinary things only. So there should be, the concept of department will go off. Okay, there will be there will be an internet of departments. Okay, where every faculty is part of every department. That's what's going to happen. So disciplines will embed themselves together. Okay, so you'll have a big faculty list. Nobody will say I am electronics or mechanical. Each one of us are belonging to all the departments. As Professor Sharma was talking about why civil engineers are required, mechanical engineers are required. Okay, all of us will be integrated together. Very soon, this department concept, will go off. That's what is my feeling. Okay, so if you look at E&C perspective, okay, what we should do to make IoT very, very efficient. So what are the typical characteristics of IoT nodes? It should have limited processing capability. Remember, we always used to use 8-bit processors with clock rates around 10 megahertz in our earlier days, your microcontrollers, if you remember. Then we switched over to 16-bit, and now 32-bit cores have become very, very important. I think no more we talk about 8085 and 8086. We stopped teaching 8085 and 8086 in our department. When I joined in 2008, there was no microprocessor course at all. We are only teaching ARM processors and embedded systems. Okay, in 2008 itself, we have migrated to ARM processors straight away. So in microprocessor course, okay, we just give a brief introduction about these 8085, 8086, and x86, and soon switch over to microcontrollers, and finally come to ARM processors. We teach ARM. So at tens of megahertz, we are able to device, it has gone to hundreds of megahertz now. So earlier, very small memory capacity was there, 4K or 8K. Now we can go up to 256K or even 1 gigabyte. So we have already talked about how devices have become low power. Normally, they are battery operated. Most of the times, CPU will be in sleep mode, particularly in an IoT node. So these are the requirements for IoT node. I'm not talking about other things. As far as an IoT node, okay, the CPU time, will be saved. It can do many other things, when it is in sleep mode, as far as IoT communication is concerned. So RF unit, often have a current draw of over 10 to 30 milliamperes for IoT node. Okay, so most of it, we are transmitting data and receiving data. Okay, and that also happens intermittently, and hence, we'll be able to achieve low power. So low range, earlier it was of the order of tens of meters. Now we are going hundreds of meters. So line of sight communication has now become possible, and even free space optics is coming into picture, wherein gigabits or terabits of information can be transferred even wirelessly, including free space optics. So we have low bit rate, so maximum over the air rate of around 250 kilobits. 256 kilobits. Sorry, I'm trying to take some help of this. It's not writing. So in practice, in practice, few by bytes per minute or even per hour. Okay, so that is the, in fact, IoT devices need to operate only at low bit rates. It's no more, the 5G data rate and 6G data rates we may require, because too much of data is there. We may require, higher data rates. Otherwise, few by bytes per minute or even per hour could be good enough. Particularly environment, doesn't change immediately, so we need not, transmit data, okay, every few milliseconds or microseconds. Okay. So when you come to system architecture and components, we are talking about, the connected things, where, you have IoT nodes, which are low power, low range, and low rate connectivity. So the connected things, we require low power, low range, and low rate. And if you have a router, that also will also be low data rate only. And the backhaul possibly could be, high data rate. So this should have been not a dotted line. It should have been a full line. Okay. The internet, definitely it has to be high bandwidth. So we should have a powerful management system, and end user systems will have, high data rate connectivity as such. So this is a simple system architecture, and these are the various routers. So these are the things: low power, low range, low rate connected things. We should have a edge router, which will get itself connected to the internet. There will be a big management system, and all end user applications will happen in, several sensors and IoT nodes which are there. So designing it becomes a very important. Reusability and scalability of the system becomes very, very important. Okay. So we are talking about the architecture of IoT. So in IoT, we have different layers. We don't talk of, that ISO layers which we studied, physical layer, data link layer, network layer, okay, application layer, and all. When it comes to IoT, we have what is called as a perception layer. So perception layer, basically perceives the data from the environment, okay, from the various sensors, barcodes, RFID tags, GPS, even, camera, okay, even video data also can be perceived. So perception layer basically perceives data. So when you come to the network layer, it collects data from the perception layer, okay, from the lower layer, and sends the data to the internet. That is the job of the network layer. Okay. In fact, it's a kind of a gateway. Okay. And several interfaces, which will be connected to the sensor network. So this will be the sensor network. So perception layer is basically the wireless sensor network which you're talking of. That is the higher part of the sensor network layer. Okay. So the sensor network and all of that will be connected to the internet. So this is basically the internet. So this internet part, will be again, 3 layers. We have the middleware, the application layer, and the business layer. So the middleware layer, is basically for management, service management, and storage of data. So information processing, and it takes decisions automatically based on whatever results after processing it gets. So those compressed data will be sent to the application layer. So the application layer, compresses the data what is required by the user. Okay. So the final presentation of data and the global management of the application based on the information processed by the middle layer is what is the job of the application layer. So this application layer sends the data in a meaningful way to the actual user, who is the user of the application. So the business layer is all about making money. I was talking about making money based on the service which you get. You have to pay for it, is it not? So making money based on services provided, data received at the application layer is molded into a meaningful service. So the business layer becomes important for business people. Application layer becomes important for CSE engineers. Middleware layer is our part. Network layer is our part, ENC part. Perception layer, all people will be involved here. All other department people, including ENC people, because embedded devices are going to be there. Okay, so just highlighting the architecture. So at the bottom of the layer we have sensors and wireless sensor network, basically sensors, connectivity, and network. So I can call it as WSN. So the WSN will be somewhere here at the bottom layer, which will have sensors, actuators, tags, barcodes, all kinds of sensors. Then when you go to the next layer, it is actually the gateway and the network. So all your Wi-Fi, Ethernet, okay, your 5G network, 6G network. So the gateway control and the actual network. So these bottom 2 layers are our layers, ENC layers. Then we come to management surveys. Okay, this is where both ENC and CS and IT people enter here. But the servers will be managed again by us. So data storage. So device modeling, configuration, management of network, data flow management, security, all those things happen in the management layer. And application layer is purely, the various applications which IoT we are talking about. So it will be environmental, people tracking, healthcare, energy sector, transportation sector, retail sector, supply chain management, surveillance of various things happening. So all that is part of the various applications of IoT network. So this one particular slide tells it all. Okay, that means IoT basically is to manage these 4 important layers. Okay, the wireless sensor network, the gateway and the network, the management service, which has to be provided to the user. It is an interface between, okay, the underlying network and the people who want to use this network, and the various applications which have been developed, okay, for all these various applications. So I was talking about IoT value chain. I said one slide for each one of them. So we know that the IoT value chain goes like this. So this is the Raymond James research I've taken from that. So radios, that is basically consisting of chips that provide connectivity based on various radio protocols. So purely domain of ENC engineers. Sensors, chips that can measure various environmental and electrical variables. That's also part of us now. Okay, microcontrollers, definitely ours. Processors and storage that allow low-cost intelligence on a chip. Okay, then modules, we have to make this as an IoT node. So it has the radios, sensors, and microcontrollers have to be pushed onto a system on chip, as we call. So you combine them as a single radio with sensors, microcontrollers in a single package. So that becomes IoT node or IoT module. So put all the software, okay, to make this module work or IoT node work. So put the software that activates, monitors, and analyzes the device and the network per se. So the application software will present information in usable and analyzable format for the end user. The device integrates modules with application software into a usable form factor. That is the job of the application software. So the airtime, which will be charged, for the user. So use of licensed or unlicensed spectrum for communications. This year, 5G spectrum is going to be sold. Of course, this time it will be without scams. Okay, earlier, a lot of scams used to happen, but this time, this airtime licensing of 5G will happen in a very transparent manner. Okay, so 5G spectrum is going to be auctioned, this year, and next year, IoT will come in a big way, particularly the 5G communications, which is very much required for IoT infrastructure. So then, the service will be how to deploy these devices, the IoT nodes, and all the application software, which has to be put on them. So to deploy the network, manage that network, and support, the entire IoT solution. Okay, that is the IoT value chain. And the future of IoT is, as I told you, 40% of it will be in the industry. So we call it as the industrial internet or industrial IoT. Okay, so we'll have a real-time network planning, shipment visibility. So this is a supply chain. Okay, so we'll have a brilliant hospital. So hospital optimization has to happen. Okay, brilliant hospital, brilliant rail yard, beautiful supply chain management. So all missions and things have to be connected here. We should have intelligent medical devices, and all of that has to be optimized. Okay, so you name any industry, you name any hospital, everything will be brilliant. Brilliant rail yard, brilliant hospital, brilliant power, smart grid, which you're talking of. All grid connections will be smart. Okay, brilliant power and brilliant factory. Okay, optimize, the factory automation. So automation of industry will happen because of IoT itself. So when 50 billion devices become connected, the industrial internet will involve all of this. Okay, we should have proper logistics as well. So logistic optimizations, factory optimization. Okay, all of this will add to a brilliant factory. So that is what is going to happen in the industry internet. In fact, sky is not the limit. We generally say sky is the limit, but I tell you, in IoT, sky is not the limit. It is only the starting point. It is only the beginning when it comes to IoT. So sky is not the limit. It is only the beginning with IoT. Okay, so the potential of IoT, as I told you, even if it's called a 1%, I think I'll go to the next slide. Okay, the industrial internet, it's called the power of 1%. Okay, this slide has been repeated. So the power of 1% is very important. What if potential performance gains by just saving 1%? Okay, if I put the aviation industry, okay, into IoT, if you remember, in US airports, 5G network was came into being in January itself, and our aircrafts were not ready for 5G. So many of our aircrafts, they said we are not going to land in your airports because 5G systems are going to affect our avionics within the aircraft, and we may not be able to land. There could be catastrophe. Okay, so 5G is going to give some trouble as well. You will see it in the near future. But when you talk about industrial internet, even if you save 1% fuel, you will save something like $30 billion over 15 years. And in power sector, okay, if I say 1% fuel saving, $66 billion will be saved over the next 15 years. In healthcare, okay, even if you reduce the inefficiency by 1%, 63 billion can be saved. Okay, so potential performance gain. Okay, when you come to rail infrastructure, particularly the freight transport, 1% reduction in system inefficiency, we can save something like $27 billion. In oil and gas exploration and development, 1% reduction in capital expenditure is going to save you something like $90 billion. Imagine. So this is the power of 1%. So 1% saving is going to save you several billions of dollars in the near future. Okay. So this has been repeated. This was a G estimate, which I repeated once again. We call it as the 1% effect. 1% effect. So we have to unlock the massive potential of IoT. How? Unlock this lock, the massive potential of lock by improved performance, creating innovative services, new revenue stream, and reduce the cost. So that's what we are saying, 1% factor, 1% factor. So this is the technology roadmap in IoT. So in 2000s, we had RFID tags for facilitating routing, inventorying, and loss prevention. And then supply chain management came into picture in 2010. We were able to have all the devices, which were having sensors. Okay, we are able to we do the surveillance of all the devices. Okay, either it is in surveillance sector or security sector, healthcare, transport, food safety, document management. So it actually helped the supply chain. Then came locating people and everyday objects, particularly in a military area, to track terrorists. Again, IoT would be required. Okay, then ubiquitous positioning. Okay, teleoperation and telepresence, ability to monitor and control distant objects without being there. So instead of the World Wide Web, we are going to have what is called as a physical World Web. So it is going to become PWW. It will be no more WWW. It's going to be PWW. So you'll have several software agents and advanced sensor fusion. Everything is going to happen in the times to come. So this decade of 2020 is going to see a big change the way we live. Okay, so coming to applications of IoT, I hope all of you are there.
Yes, sir.
Hello. Oh, I'm
yes,
sorry,
sir,
I'm going on.
We are
and
listening. On. Yes, sir, we are listening thoughtfully.
Yes, sir. We are
Thank you, sir. It's really very informative.
Oh, okay. I hope I am not boring all of you.
No, sir.
No.
Not at all, sir. Not at all.
So I am just giving you data. Data is at the bottom of the triangle which I showed you. Not at all important. Yes, what is important is what you make out of it. So you have to go to the tip of the triangle. So I'm just giving you data.
Yes, sir. From data to wisdom.
Think. Yeah, we have to go towards wisdom. So let us think of wisdom today and nothing else. Okay. So now onwards, I'll talk about some applications, not in a big way. Okay. I'll just give you a few examples. So Asin and Gascon, they have said that there will be at least 54 application domains under 12 categories. So again, this is information from the internet. The applications, which will bring technology very close to the people. That's what, Asin and Gascon have said. Okay. So the 12 categories are these. I think I not put all the categories here. I've taken few of them, like smart cities, Smart environment, smart water metering. I talked about smart water metering, which is happening in our campus here, right here. Okay. And smart grid, I told you, that is also, we have a project. Security and emergencies, very, very important. Retail, I think we are seeing it already. Logistics and industrial control. Smart agriculture, already happening through wireless sensor networks. Smart animal farming, domestic and home automation. This is happening in a big way. And e-health also is happening in a big way. So the ultimate goal of IoT is to automate human life. Okay. So if you look at healthcare, so patient care, is very, very important. Particularly if you're in hospital, we think, we are taken care of better, but actually, hospitals are the worst place. Patients will die earlier. So better to have some patient care at home itself. You will not get, the viruses from other patients within, the place, where you are admitted. Okay. So patient care in home becomes very, very important. We should have, ICU at home itself. ICU in hospital, you are certain to die, okay, within months. If you have ICU at home, you will possibly live and not die at all. So IoT is going to help do this. Okay, so teleassistant for aging and rural citizens. I'm putting myself here also. I'm going to retire in another 2.5 years. So aging and rural citizens, they don't have good health infrastructure. So IoT is going to help in a very big way. Okay, IoT is going to create a renaissance. Okay, in healthcare sector. Okay, patient care, very, very important, particularly in COVID times. IoT has already helped in a small way, but it's going to help in a big way in the times to come. So connected home, we already talked about smart homes, home safety. Any burglary can be easily done. So you can keep your home secure. We can automate all the things. Okay, when you are in office, when you start from your office room to the car, you should be able to switch on your AC of the car just before you lock your room. Okay. So when you're just closing your applications on your PC or on your laptop or on your mobile, before you lock your room, okay, you can keep the AC on for your car. So when you just go near the car, a sensor will detect you, and you have the smart keys already, in our cars. Okay, you just enter, already, the car is AC'd. So when you are driving, okay, at home, you can put your AC on. You can check, whether the refrigerator which you had put it on in the morning, whether it is still on or not. Okay, and whether the lights are off or not, you can keep checking. Okay, you can monitor, people. If your children are at home, you can monitor them whether they are listening to the online classes or not. You can check whether your wife is busy in at kitchen or elsewhere. You can actually monitor everybody in the house, before you reach. Okay, and you can actually see, food being served by your wife. Okay, when you actually reach home. Fantastic. I think connected home will be very, very important. I think many things are already happening. Smart appliances. Okay, smart refrigerator can be there. I'll come to that very soon. Home entertainment systems, already they have gone automatic. So telematics, improvement of safety of transporting systems, fleet management and traffic flow optimization. The other day, I was traveling from Mangalore to a nearby town called Hubli. Okay, I reserved my ticket on my mobile. I paid through my mobile. Okay, I was able to track the bus, which will come and pick me up. I know where the this thing is. I start from my home only after the bus has started and come to the place, where I have to enter the bus. Okay, the moment I am there, the fellow knows that I am there, and I simply enter. So everything has become automatic now. So even the operator, of these buses, he knows where his bus is. Fantastic. Already things are happening. So you can actually optimize. So these things, so fleet management is very much possible. It's not restricted to the bus operators. Even if you are having taxi service, so you have seen a big thing which has happened through Uber. To tell you frankly, you heard of Uber, and there is one more service. What is that called? I forgot. Taxi service. apart from Uber, if somebody can prompt. Which is the other company? A big company in India?
Ola.
Ola, yeah. In fact, Ola was started by our own students. The startup of NITK students has led to Ola. Can you believe this? So your institute students will also be able to have, a startup which will come like something like Ola or Uber. Okay, Ola is basically a startup which is started in NITK Surathkal, our own students. And of course, they sold it to Ola and made big money. And even these doctors, you remember, if you want to have all doctors, there is one more application, I forget again. Again, it was started by our own students. They have sold it. Do you have that application on your mobiles? Okay, the network of doctors, you can book an appointment with your doctor from your mobile using that application. Okay, so all doctors within your city. So this startup also happened at NITK Surathkal. So I'm very proud, that our students have contributed in a big way by means of this kind of an IoT application, which they have developed. Okay, I forget that application. Probably at the end of the lecture, if I remember, I'll tell you. Does anybody know about it? If anybody is from Bangalore, they will be using it Anybody from Bangalore here? Bangalore Institute? They must be using this booking of doctors, appointment, through. I don't think anybody is there from Bangalore. It's fine. So what I mean to say is already things are happening. So safety and security. So periodic monitoring of the architecture, status, emergency warning information, okay, about earthquake happening or, tsunamis happening, okay, all these things which happen on the seashore, okay, all of that can be monitored very nicely. So the ultimate goal of IoT is to automate human life and make, human life more meaningful. Okay, so we talked about a smart grid. I'm continuing with the applications of IoT, which will enable, smooth and efficient delivery of electricity. Okay, so we have automatic metering system already in place. Okay, so green energy integration. In fact, you can have, solar panel on top of your house. You generate electricity from your own solar management system. You charge your car, electric vehicle through that only. You don't have to pay a single paisa to the grid operator. In fact, you can sell your electricity back to the grid operator. So IoT is going to become useful even to us. Just have, okay, smart grid within your house. You don't have to pay electricity bill at all. In fact, you can sell electricity which you generate through your own solar panels on top of your house. Okay, manage all the electrical requirements of the house, including, charging of your electric vehicle as well. So your transport becomes free, your electricity becomes free. Okay, and you should be able to make profit by charging, okay, the electricity undertakings, okay, in your city and make money out of it. So that is the power of IoT. So green energy integration and energy management saves energy, reduces cost and increases reliability as well. So industrial monitoring, we did talk about industrial internet already to increase productivity, efficiency, and safety. So missions also can be surveillance. So maintenance of missions in your industry also can be managed. We can actually track our assets which you have. We can find out, in your this thing, inventory, what all things you have and what needs to be ordered again. So storage monitoring, inventory control, asset tracking, mission surveillance, okay, increasing the efficiency, productivity, safety, everything can be done by monitoring the industry which you have. It could be power industry or whatever industry you have. So agricultural monitoring, I told you very much. We can have optimized usage of water, energy, and pesticide control. So better productivity. Okay, you can monitor spatially and temporally your agriculture fields. You can save your putting, proper fencing, e-fencing for your field, and see that, you save, your crop as well. How much pesticide to use, whether to use the pesticide or not, everything can be controlled, by monitoring your field. So agriculture monitoring becomes a very important application of IoT. So IoT is a big umbrella of wireless sensor network, which we are doing, for the last 10 years. Smart cities, I told you already. Sustainable urban development, eco-friendly infrastructure, water management, land management, skill and energy resource optimization, everything can be done. So I have seen this smart city actually in place in Los Angeles. I had been to University of Southern California in the year 2015. So there, I was interacting with professors there. It was a research interaction. Okay, one professor, who is from India, was having a big project from the water management system and electrical energy management system. Okay, it was I think, $100 million kind of project which he had. And I was asked to attend, the what all work they have done for these two services. Actually the university is actually giving them the technology. So I had at least 10 PhD students, each one of them giving 3 days continuously what all things they have developed for Los Angeles city. So they were actually trying to tell how smart grid within Los Angeles city is going to save optimize the energy there and make more money out of it. Okay, so in fact the universities are involved in building the IoT system, for their cities. I saw it in 2015 itself. In India, it is still to happen. Fortunately at NITK Surathkal, in a very small way we have built, but it was fantastic in the University of Southern California. We went to the water and the land, water and grid management department. They gave presentations there. They actually, displayed their hardware and software, how it was operating. They were so happy with the university professors and research scholars who were working. I think that should happen in our universities as well. It's a long way to go, but we should. Okay, so we did talk about smart home appliances. Okay, where it will be having M2M connectivity. It's going to open up a new era in convenient and efficient home management and quality of life. So I was just looking at smart refrigerator, how your food management system can work. It will allow consumers to check food items stored inside the fridge for information such as location within the fridge. Nowadays you have very big refrigerators, and expiry dates of the items which were stored via the smartphones or its built-in LCD panel. So LCD panel will tell you what all things you have in your fridge, which needs to be inventory of your refrigerator, and tell you the expiry dates also. If something is expiry date, you can just open it and throw it off. So the appliance even recommends dishes that can be cooked using the ingredients it happens to be storing. So that is a kind of a smart refrigerator which all of us are going to have within no time now. So you name an application and you will have it in IoT. So that is what is this is my sentence. You name it and you will have it in IoT. You will have it in IoT. So I did talk about the power of 1% in industrial internet. Okay, so this is an example of smart parking. So create US $41 billion by providing visibility into availability of parking spaces across the city. See how the cars have been parked here. Most efficient way of parking. Not a single, so within one space, 4 cars have been placed. So residents, can identify and reserve the closest available space. Traffic wardens can identify non-compliant usage, and municipalities can introduce demand-based pricing as well. So this is happening in a small way in our malls already. Okay, you will know where the places are there, but I can see people making you go this way, that way. In fact, it should be devoid of any human beings. Okay, you should be able to just leave your car at the entrance. The car will go and sit at a place where there is vacancy, and when you want to pick up, the car will automatically come and be available to you. That is the kind of things which are going to happen in smart parking. Okay, so when you come to efficient waste management system in smart cities, okay, we have to support it as sensing as a service. Sensing as a service, SaaS industry. Okay, you should have infrastructure and access to energy sources and long-range data communications. You can see that here. So the garbage cans with low-cost passive sensors, and you will have wet wastage and dry wastage. Okay, a truck should come and pick it up. The fellow will not come out of the truck. He will come just in front of your house. You should have kept the garbage cans which are automatically pushed into the truck, and the truck also closes itself. You need not come out at all. I saw this in my brother's house in the US. This was already happening in 2015. In India, they will throw garbage all across the city after collecting. That is the kind of system which we have. I think the garbage trucks, okay, should act, very, very smartly, okay, and it should be controlled, via the cloud platform, and things should become really, really efficient. Management is not happening in India. Okay, so smart cities should have, okay, recycling plant, manufacturing plant, health and safety authorities, waste management, everything is part of the smart city. So you should have sensing as a service model for smart cities supported by Internet of Things. So this is a transaction paper on emerging telecommunication technology, which was published in 2014. And in 2015, I saw it happening, okay, in California when I visited. In 2015, this was already existing. This is already existing. So this is a smart grid which I was talking of. Okay, so how air conditioning will have 17%, space heating. So all studies have to be done. How much power is required for water heating, refrigerators, okay, TVs and other electronics, how much it will take, lighting, how much it is required. All data has to be managed very well by the smart grid. So everything should become automatic, and it should happen across the cities and within the city as well. So this is a diagram, okay, of a smart grid system, which we are talking about. Okay, so I was talking about sensors in even the queue, okay, even in the cow. Okay, in the world of IoT, even the cows will be connected and monitored. Sensors are implanted in the ears of cattle. This allows farmers to monitor cows' health and track their movements, where they are. We have to save our cows, holy cows. We should ensure that they are healthier, and they should provide us plenty, full supply of milk. I think India has been in the forefront as far as optimization of milk production and providing milk across the country. Amul has shown the world how, okay, production of milk and taking care of health of cows. Okay, so IoT is already in place in Amul industry. I think we should be very proud of Amul, which we have in Gujarat. Fantastic, fantastic. So cows are already part of IoT in Amul. So we know nothing remains static, especially when it comes to the internet. So initiatives and advances such as Cisco's Planetary Skin, General Electric's Industrial Internet, HP, Hewlett Packard's Central Nervous System for the Earth. It's called as SENSE. See how nicely they even name. HP has named Central Nervous System for the Earth. SENSE, CENSC. Of course, we have a SENSE lab in IISc Bangalore that basically works on sensors. Okay, so that is also called a SENSE lab. So, but HP has a central nervous system for the entire Earth. And Smart Dust have the potential to add millions and even billions of sensors to the internet. So we have a SENSE lab in IISc. If anybody wants to work in sensors field, they can as well contact the SENSE lab. We have very good interaction with IISc Bangalore because we are just 350 kilometers away. We have understanding with them. Of course, what is it called? Collaboration with IISc we do have. So as cows, water pipes, people, and even shoes, trees and animals become connected to IoT, the world has the potential to become a better place. I don't know. It's a question mark for this. Whether it will become better or not, I don't know. But all of us will get connected with whether we like it or not. So with trillions of sensors embedded in the environment, all connected by computing systems, software, and services, it will be possible to hear the heartbeat of the earth, impacting human interaction with the globe as profoundly as the internet has revolutionized communication. So this is what Peter Hartwell of HP Labs has said. How much more IoT can do is only left to your imagination. So that's what he says. Okay, so Internet of Things is the next stage of the information revolution with interconnectivity of almost everything. So we need to have integration with the internet implies that devices will use an IP address as a unique identifier. Objects in IoT will have to use IPv6. I told you it is not enough, okay, to accommodate the extremely large address space required. So a new naming system is a big research area. Objects in the IoT will not only be devices with sensory capabilities, but also provide actuation capabilities. I was talking about MEMS devices. We have optical MEMS as well. Okay. On the other hand, IoT systems could also be responsible for performing actions, not just sensing of things. We must be able to have actuators which will perform actions. So that is what is going to be IoT of the future. Okay. So I did talk about shopping experiences. All of us are experiencing this. When shopping in the market, the goods will start introducing themselves. Okay. When entering the doors, the scanners will identify the tags on our clothing. And when paying for the goods, the microchip of the credit card will communicate with the checkout reader. We don't have to, okay, give your mobile number or give your card, then put your OTP. Nothing is required. Okay, you don't have to do anything. When moving the goods, the reader will tell the staff to put a new one. So all these things are going to happen very soon. I think in some of the malls, some part of the mall already, we see this happening. Okay. So I think every day morning I use IoT without my knowledge. How many steps I have walked today? I know every day how many steps I have taken. When I slept last night, I can find out how many hours I have slept, how many times I was awake over the past 30 days or the past 1 week, the last night, how many hours I slept, how many times I awakened without my knowledge. So time to fall asleep also it will give, when you went to sleep, when you got up, okay, whether you were restless, whether your sleep was good or not, okay, all the things, your sleep pattern is completely available on your watch now. If you have a Fitbit, I have a Fitbit with me, I wear it and sleep in the night so that, my heartbeat rate is also monitored. Everything, is already possible. It's already possible. Okay. So this is also part of IoT itself. Okay. I want to know more about myself. Can Internet of Things help us to know more about ourselves? Where you are going, who you are interacting with, how long you have spoken to friends, what is the affinity of connections, how long it takes to get to work, the tone of your message also matters, the amount you text, is it not? The amount you text, tweet or update. Okay. I remember, how much WhatsApp, I have used on my mobile is possible. Okay. How much exercise you are getting, how much you get distracted. If I'm sitting on my table for say more than an hour as I'm doing today, it will tell me, please go and have a walk. You are sitting for a longer period. So it will keep telling you. So already, I'm being controlled by my Fitbit or by my mobile. So IoT helps you in life logging. In fact, you are logging your life to IoT. So that is how, you are going to become will be controlled by IoT devices in the years to come. Okay. In fact, you can see this thought controlled computing. So this is a beautiful product. Okay. It's called a Mindwave, the flagship product. It's a headset, that can log into your computer using just your thoughts. So your thoughts itself will control how you have to think also, it will tell you. So researchers, recently used the EEG headset to develop a toy car that can be driven forward with thought. You want, the toy car to move in this direction. You don't have to control through a remote. The thought itself will drive it, the way you want. So NeuroSky smart sensors can also track your heart rate and other bodily metrics and can be embedded in the next generation of wearable devices. So wearable devices is a fantastic area to work on. Okay. So if some of you are doing your PhDs, okay, wearable devices is a big thing. Okay. So we make it possible for millions of consumers to capture and quantify critical health and wellness data. Okay. So this is what, the CEO of SoftBank said. He's the funder, for all such devices. If you start a startup on wearable devices, you can get a lot of funding. Okay. So there are, however, a lot of technological challenges of IoT. One significant aspect, is the large number of things, okay, being connected. Each one providing, millions of data bits. So finding ways to reliably store and interpret that message, that massive data through scalable applications will remain a major technological challenge all the time. So as Professor Sharma has already told you, privacy, I don't want my health data to be made public. I don't my place, where I am, okay, particularly in this world. Your employer will come to know how much time you are wasting in your workplace, how much time you are sleeping, how much time you are spending, without doing anything. All based on that, your salary will get decided. So it's going to be a big risky, for people, but it will optimize, for people who are controlling you. So that is a big identity management, privacy management, security and access control, standardization and interoperability, data deluge. All these things become a big technical challenge. I told you about big data. It's a big elephant. Okay, it's not magic. Doesn't matter how much data you have if you can't make sense of it, if you can't have wisdom of it. Is it not? So you all already know that smart sensors also communicate with each other. They will connect to the cloud through gateway or router, and the data generated by sensors, is growing in a big way. Maybe gigabits or terabits of data, particularly if you're having video surveillance. So there will be big data issues, okay, because of big data generated by sensors. And the cloud is basically an enabler or a facilitator. So not essential, but very, very useful in practice. So cloud computing, big data analytics, okay, everything, becomes very, very important. So when you talk of technologies, as far as we are concerned, okay, we will have, RFIDs, better RFID for logistic and supply chain management. We require better and better RFIDs. So we need to work in WSNs, routing issues. So these are the technologies where you can work. Low power devices, lifetime of sensor nodes, how it can be reduced, how to reduce the power constraint, how to make, more secure communications between the sensor nodes. So there could be manets, okay. There could be cloud of things also, COT. So it will overcome lack of software. We don't have to have big software stored in our place. Everything can be in the cloud. So we need not have big memory, not have too much of hardware. Everything can be shifted to the cloud. Even the processing also can be given to cloud. So cloud computing becomes a big research area. That's why, everybody wants to get into CS area. Okay, so we'll have several issues in cloud of things like protocol support, energy efficiency, resource allocation, identity management, IPv6 management, deployment, and probably a new naming system altogether, location of data storage, whether it has to be on cloud, okay, everything, security and privacy, unnecessary communication of data, how it can be avoided. So these are the issues which people are looking at in cloud of things. Okay, so these are the challenges I was telling you in research and development. I'll not go into details. So data deluge is nothing but too much of data because of the too many devices being connected. So resulting in analyzing big data becomes a big problem, and integrating with heterogeneous systems is another big problem, because there are too many applications coming from different application domains. How to integrate them? So it is highly heterogeneous system. How to interact with heterogeneous systems? So we as network engineers will have to do a lot of things to make devices talk to each other, to different networks, and all of them have to be integrated, and we have to maintain security and privacy as well. Okay, we have to give reliable connectivity, okay, connecting between the gateways and the cloud at a smaller rate, affordable price. Okay, that is these are the various R&D challenges which you have to face. Okay, as I told you, there are a lot of criticisms and controversies also. We'll always have pessimists in this world. Not everybody is optimist. Okay, scholars and social observers, particularly these communist fellows, will always get into trouble. They're all pessimists. They will have doubts about anything. Anything new. They will oppose. Okay, remember the farmer strike which you saw in India, how the government had to take it back. It was actually good for them, but people don't accept good things straight away. Okay, so that would have revolutionized our the way the farmers sell their produce. Okay, the middlemen eat a lot of money. Our farmers are still poor in the last 70-75 years. So unless IoT, smart agriculture becomes a reality, our farmers are not going to become rich. So there are very rich farmers, a less number of them. Very big chunk of farmers who are really poor, because these are pessimists who are opposing this IoT in agriculture. So privacy issues are there, security issues, autonomy and control. People think you will be controlled by somebody, your autonomy will be lost. So that is a problem of institutions as well. Okay, social control, political manipulation. You have seen that political manipulation happening. Okay. Whether it is management of IITs or NITs or anything, for everything, there is manipulation which happens in the political system. So environmental impact also will be there. I talked about health hazards, influences on human moral decision making. If devices start taking decisions for you, you will be in difficulty. There are several health hazards which you have to take care of. So these are the controversies which will keep emerging every now and then. We have to keep solving them. Okay. So in summary, I can say Internet of Things, what we have seen so far is only the tip of the iceberg. Okay. It's only the tip of the iceberg. The iceberg is so big, you can see here. So in summary, I say the Internet of Things, what we know right now is just only a tip of a iceberg. Okay. So we need to speed up the adoption of IoT in our country. So all the countries and companies must focus on innovation and invest in deploying the necessary sensors and improve cyber security. This is what we need to do. And we need to educate a new class of digital mechanical engineers. Professor Sharma told very nicely, all engineering colleges, okay, we need different kinds of teaching now. We can't be, restricted to our own areas. So most of us, we say we are experts in our own area. We need to actually, think, broadly. Okay, we need to have digital mechanical engineers. Okay, and we need to educate, a new class of these engineers. So the industrial internet can transform our industries and lives, pushing the boundaries of minds and missions, according to a GE report. So this is what we need to do as far as IoT is concerned. So I know there are several references here. Okay, I think I have at least 32 references, and mostly, I have gone through Google, okay, Wikipedia, and Cisco, GE Visco, and there is one very good thing by Dr. Muslim Abbas. It's a Mimos Barhad Visma. There's a very good paper by him. I think you can refer to that as well. So these 33 publications plus all these is going to help you out. So with this, I end my lecture. If you have any questions, I'm open to questions.
Thank you very much, sir, for sharing your profound knowledge with us. Your session was full of real and valuable information. Now we shall proceed with a question and answer session. The audience is welcome to put forward their queries.
Yes. Hope it was interesting, and I hope I given a good introduction to your FDP.
That's yes, why sir. I said, lecture was very interesting. It was very much interesting, as well as, sir, you have set the tone for whole FDP. In fact, it looks like now every participant has got something for them. Every researcher, those who can work in any of the area, they have something.
Yes, ma'am.
So they can explore in further lectures. Thank you very much, sir.
I think Dr. Bhupendra Verma is saying something. Sir. I would like to listen to him as well. Please, sir. Dr. Bhupendra Verma, sir, you gave a fantastic introduction.
Yeah.
I just expanded it.
Yeah. Thank you so much, sir. Actually, your lecture was very good. That is what I was actually listening. That is why what I told. So there is a scope for all researchers, everybody, those who are participants. Even I learned many things from there. Thank you so much, sir.
Thank you, sir. Thank you, sir. Thank you so much, sir. Thank you so much. So I'm open to questions, madam. I think if somebody has questions,
yeah, if anybody is having any queries, you may please ask.
Yeah. I hope it was not like any other online class, which you are used to now. Students, just put on their devices and then keep doing their own things. This is another problem of online IoT.
Yes, sir.
People leave it to, IoT devices. You don't have to do anything. In fact, I don't want to even think also. That is going to be a bigger problem. Our children have learnt it very nicely now.
Dr. Kulkarni, first of all, yes, I would like to congratulate you for delivering such a useful lecture. I am Dr. Vivek Sharma, Professor in Computer Science at TIT. And I have taken so many notes from your lecture. And IoT is buzzword, and many new things are going on.
Yes, sir.
And you have covered the technological aspects, the challenges, and the way in which this IoT will impact our life. But when you said that there is a thing that is called controlling the human thoughts by intelligent devices. So although the communist people are going to always oppose this development kind of thing.
Yes.
But still there is a danger of controlling the human bodies by these artificial devices. So I think that situation will always be there, and we will really have a challenge to control these devices and get controlled by them. So I mean, can you just elaborate that? You have shown one slide.
Very good. Yeah. Yes, sir. In fact, that is a major problem. Yeah, this is a slide you must be talking of, sir. I'm just sharing it.
Yes, sir.
Yeah, mind wave, is going to become a very big thing. And the way you think, you can control somebody else. It's a very dangerous thing. I am not a communist, but I am against this as well. By using your thought, if you can control somebody, it's going to be really very, very fiery. I fear how others are going to control you. So that is really a big challenge, which we'll have to face, I feel. Okay. And but there are several, so 90% of the things are good. 10% will always be negative, whatever you do. Okay. So you'll have to see, to make new technology to be accepted by people. Okay, it will take time. You remember when mobiles came, they were very expensive, and many of us, were not able to buy those mobiles as such. Now they become so cheap. So the services are going to become so cheap. Even a common man, okay, would be able to have such devices, and that is the major fear. Everybody starts using these intelligent devices, and if the devices start controlling us, that is a big fear. Absolutely, you are very right, sir. I fully agree to what you said. Our wellness, should be better off than going the other way around. that is the yeah.
That's true. That's true.
Our critical health issues. That should not be made public. The privacy is a big issue, sir. Privacy is a big issue in IoT. So that could be the major research area for people to work on. So how to make this communication private, how to make it more secure, how to make the devices which can think to be under our control. Okay. Even by thought, we should be able to control the things rather than things controlling us. The reverse should happen. I don't like, the things controlling us. Okay. I think we should work towards that. We should work towards that. That's all I can say there. I don't have anything else.
Thank you, Dr. Kulkarni. Very nice lecture. Yes. Once again, congratulations.
Yeah, thank you very much, sir.
Thank you so much. Thank you, ma'am.
So we are going to end this session by having a thought that being a faculty in technical education system, we have to educate a new class of digital mechanical engineers.
Thanks a lot, Kulkarni sir. Thanks a lot, Kulkarni sir.
Thank you. Thank you, sir. Thank you, Vikas Gupta ji. I have been talking to you. I had not seen you. So nice to see you. Thank you very much
for
making this possible. Thanks for giving me an opportunity to speak to all of you. Thank you so much.
Thank you.
Sir. Please visit NITK Surathkal when you have time. We'll request you to come. Yeah. For our PhD research scholars, we'll make you examiner so that you can visit us.
Oh, बिल्कुल सर.
Yes sir, ऐसा करेंगे. तब भी आएंगे आप, नहीं तो नहीं आएंगे इसलिए. Thank you sir. Thank you sir. Thank you so much. Thank you so much. Thanks for everything. Thanks for everything.
Thank you sir.
Thank you very much, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Okay, so we are going to...
Thank you, ma'am.
Thank you very much, sir.
Thank you, Viva, ma'am.
Thank you, sir.
You conducted it beautifully. Thank you so much. Thank you. So
we are going to start with our session number 2, The next distinguished to honor us with his presence is Dr. Rakesh Kumar from Central University of Haryana. Dr. Rakesh Kumar received his BTech in Computer Science and Engineering from Punjab Technical University, Jalandhar, India, MTech in Information Technology from Guru Gobind Singh Inprest University, New Delhi, India, and PhD in Computer Engineering from NIT Kurukshetra in 2004, 2008, and 2015, respectively. He started his career from NIT Kurukshetra, where he worked as lecturer. At present, he is working as an associate professor and head in the Department of Computer Science and Engineering at Central University of Haryana. He has 17 years of teaching experience. He has number of international and national conference journal publications to his credit. He is also a reviewer of many international journal and conferences. He has organized many short-term courses and conferences and workshops. He is an active member of many professional bodies. He has guided many PhD and MTech candidates. His key area of interest includes MANET, software testing, data analysis, and cloud computing. I would like to welcome Dr. Rakesh Kumar to add glory in this session and to develop the skill of excellency. Welcome you, sir.
Thank you, ma'am. At first, I would like to congratulate your organization and the coordinator and the whole management for conducting this 5 days program for the benefits of the faculty as well as the students, those who are participant in this. And I would also like to thank you for giving me an opportunity to interact with the participant in this FDP. So
welcome, Rakesh sir.
Yes.
Welcome, Rakesh sir.
Thank you, sir. So I would like to thank you, sir, for giving me an opportunity to interact with the participants in this FDP. And sir, it's really difficult to speak after a good speaker. I am listening to Dr. Kulkarni in the first session. So he nicely talked about many of the things. I think participants have benefited from that. So I would be continuing with that. And I think participants will be benefited from this session also. So let me share the screen. I hope my screen is visible, sir.
Yes, sir, perfectly visible.
Yes, sir, perfectly visible.
Okay. So Dr. Kulkarni has very well said about the IoT and what are its applications. Those are possible with this and how we can adapt these things in our day-to-day life. But in this session, we will be talking about, I think sir has also said about this, how we should not allow the things to control the humans. Rather, we should be controlling the things. Humans should be controlling the things. But for that, there are some security and privacy issues that we will be talking in this session. So, but before that, I would just like to take a few slides of just a few basic introduction, because that will be using in our security aspects also. Then we will be going into the deep in security aspects kind of thing. So there are certain key properties that IoT is having, and IoT itself cannot work individually. Like in computer field, we are talking about the cloud computing, we are talking about the fog computing, edge computing, we are talking about the machine learning. So when we talk about the security aspects, so we will be needing all these things, because there is an old adage, more the number of doors or the gates in your house, the more is your house vulnerable to attacks. Similar is the case in case of computer field also. More the number of gateways, more the number of doors we are allowing in our system or our network, the chances of attacks will also be higher. So we should be talking about all these things in this session. So moving toward with this, how we are evolving toward this network requirements. As we all know, there is an increasing demand of network bandwidth nowadays. Day by day, people are requesting more and more bandwidth and resources. So earlier days, organizations like the software providers, they were selling their softwares in the compact disk. They were selling these softwares like Windows were earlier available in the compact disk. But nowadays, they are offering all. Sorry, again, I think screen was not visible too. I reconnected, and then now I think screen is visible. Let's hope this session will be continued smoothly now onwards. So now we have been talking about the increased bandwidth and latency and some other requirements from the organization and from the users. That is why we are shifting from the local storage to the cloud storage and cloud computing. With that, we will be able to share the resources. So this is applicable with case of IoT devices also, where we have the large number of devices that may result in a significant load on the enterprise network. Now, this is the figure that shows us from 2013 onward to 2018, there is the continuous increase in the traffic. This traffic is shown in exabytes per month. So we can see that internet traffic, mobile data traffic is also increasing. Now, like nowadays, mobile telephony is also offering the internet services with increased throughput and bandwidth. We are able to access these resources through this also. So as a result of that, as the more and more facilities we are getting, the challenges are also increasing with day by day. Now, cloud computing basically enables the sharing of a pool of resources such as server, storage, network, application, and services. So when we talk about the IoT, IoT is not only thing, it is just a combination of few things. Like first is the sensors. Through that, we will be collecting the information. Then we will be analyzing it or storing it. Then for storage, we need basically the cloud storage. And then we will be computing these things at the cloud. So applications are now also are now easy to develop, manage, and access, and easy to create, control, and deploy. That is why we will be shifting towards the cloud storage and cloud computation rather than doing the computation at the user's end. So this is the first definition of the IoT that says the things oriented perspective, where RFID tags were considered as the things. Now, when internet came, basically it connected the people. But when IoT came, it connects the devices or the machines. So here, rather than a person is considered as an entity in this world, with the help of IoT, each individual device can perform some action. It is addressable as well as it is accessible. Like we have many of the applications Dr. Kulkarni has already discussed, like we are talking about the smart home, we are talking about the smart healthcare. So let us take the case like we have multiple sensors either installed in my body that those are measuring my heart rate, my pulse rate, my HB, my other factors. And those factors are automatically being transmitted to my doctor, who is analyzing those things simultaneously, and accordingly he is prescribing me the medicines. So those things are automatically done without any intervention of human. It is not something like that I am noting down all the parameters myself and then I am transmitting it to my doctor. It is done parallelly. Everything is done parallelly. So this is possible with the help of IoT. Here, each and individual device is acting separately. We can talk about one more example. Like suppose, like in the northern part of the country, in summers it is quite hot. So suppose I am leaving from my office for my home, or maybe suppose in the morning I am coming from my home to my office. So as soon as I reach to my home, I would prefer that as soon as my car will come in front of my my home, automatically my garage gate should be opened by seeing it, my car has come. And similarly, I would also like to program the things in such a way, as soon as I start from my office, automatically the AC which is installed at my home should be started at least 15 minutes before I reach the home. As a result of that, cooling will happen at least 15 minutes before, and the room will be cool by the time I will reach my home in the evening. So this is only possible when my car is connected with my mobile phone, as well as to my the AC which is installed at my home. So here I need an AC which is smart. Which is smart means which is addressable as well as accessible, which can perform some action on my behalf. So when it sees that when my car has been started from my office and it is going to take around 15 minutes from my office to home, so it will enable the air conditioner by that time, and by the time I will reach the home, it is automatically the room is cool. So such things can be possible with the help of direct intervention of machine to machine communication. There is no requirement of me in between. If my inputs are required at every stage, then we will not be able to achieve the IoT with full extent. We have many such applications where we would like to do the things in such a way. I can also share another application of similar nature. Suppose I would like to have here, my refrigerator should be smart enough. My refrigerator should be smart enough, which means there are multiple things in my refrigerator. As soon as the cold drinks are finished in my refrigerator, I would like to integrate my refrigerator with my mobile phone. And in mobile phone, I have my app for suppose Amazon. So as soon as the cold drinks are over, so we will be automatically, the orders for cold drink will be placed with the Amazon, so that by linking my mobile phone with this, please shut the door. We will talk later, please. So accordingly, we will order the things automatically onto the Amazon, and the order will be delivered at my home as soon as the cold drinks are over automatically. So no need of human intervention. So this is what is being expected from this Internet of Things, that we will be able to do the things. But in this session, we are more focused on the security and privacy aspect, because as I said, a particular user may be having 6-7 devices. Like suppose I am having a smart watch, I am having a smartphone, I am having a smart vehicle, I am having a smart refrigerator, I am having a smart air conditioner. So all these smart basically means these all devices are connected with the internet. These all devices are connected with the internet. They are addressable as well as the accessible. So with the help of these, my privacy and security will also come at stake with these more and more devices available to the public domain. So let's talk about this. So this is the definition that was proposed in 1999 by Lab Boston. It says कि data and devices continually available through the internet. So हम सारे के सारे data और devices को, it is available continuously in the network. So it estimates data generated from connected IoT devices to be 73.1 zettabyte. So this is continuously increasing day by day. We all know about this. The data requirement is going in. Now this is the data center. This is an image of the data center, which is 11 times of the size of a football field. So you can imagine how big is the data center, and how we will be able to store the data over there, and how we will be doing the computation over there. Now these are some characteristics of IoT infrastructure, which will be helpful to us when we will be understanding the security and privacy aspect. Now, first characteristic, the unique characteristic of IoT is we have the heterogeneous devices. As one of the device may be your refrigerator, another device may be your full-fledged computer or the laptop. Then these devices are resource constrained. Why these are resource constrained? Because it may be possible that I have deployed the sensors in the underwater, or maybe I have deployed the sensors in a remote forest. So they are battery operated. They are not capable enough to do large computation or storage. Then we need some kind of spontaneous interaction also. As soon as the certain condition is met, immediately some action needs to be performed. Like I am having my smart car. Suppose my car finds that there is an accident ahead, so that I need to take some alternate route, or suppose if there is an accident, I need to apply the brakes automatically with reference to my car, and simultaneously the message needs to be sent to the cars, those who are coming behind me, so that they can also apply the brakes accordingly. Then it is the ultra large scale network and large number of events. As we know that even a single person is having the multiple devices connected with it. Then if we have each person is having the 6 to 7 devices, then the size of network you can imagine. Then we have the dynamic network and no infrastructure, because in IoT, all these devices are of dynamic nature, and they will be connected, and the topology will change automatically. And then we say it is a context aware, it is a location aware. We know the location of each each sensors that you have deployed, and it is distributed in nature, because we cannot keep all the devices at a single place, because in case of a volcano or maybe some natural disaster, all the data will be gone. Like we all know, few years back, tsunami struck in Japan. In Japan, we have a very big data center, but still the information was not lost. Why it was not lost? Because we were having the redundant information at multiple data center also. The same information is not placed only at one source. So these are the multiple applications. This we have already discussed. We can deploy the sensors for environmental monitoring, like the air quality monitoring, maybe the river monitoring we can use. We can have the smart home, one of the applications we have discussed. We have also talked about the wearable devices for medicine and healthcare purposes. Then we have talked about the smart cars. We have talked about the smart grid. Smart grid we have not talked, but we can use in these sensors in smart grid also. As soon as the consumption of electricity in a particular area will be increased below the particular threshold value, you can simultaneously switch off the electricity in some other area, and the load can be balanced accordingly. Such things are possible with the help of these IoTs. Then these are some real implementations, like we can have the aircraft engine performance maintenance. Automatically it can be done with the help of sensors. Sensors will send the message to the maintenance team. Now this component requires the attention and we need to maintain it. Similarly, we will be able to monitor the environmental conditions, automated telemedicine, traffic detection, smart grid. A number of applications are there for IoT. Those can be possible. Now, when we talk about this IoT linking with cloud, because whatever the data we are collecting with the help of these IoT, like the sensors or the actuators, ultimately we are going to store this data for any decision that we are going to take in future. So first thing, we need to store the data. Second thing, we need to perform some kind of algorithm on this data so that we will be able to compute something. So for that, cloud computing uses the dynamic provisioning, which allows a single resource to be accessed by multiple applications simultaneously. So this will help us because multiple sensors are going to provide us the information that is going to be stored in the cloud. From multiple locations, we will be able to access it. Because nowadays, gone were the days when we were storing each and everything at a particular location. Now we are going for the distributed kind of thing and decentralized kind of thing. So with the help of cloud, this is possible. So cloud services are measured on timed and controlled to ensure that there is no abuse of the services. Each cloud service needs to be offered immediately, on demand and self-service. Also need to be rapidly elastic and allow the requisite broad network access. So with the help of cloud, this is possible. But nowadays, another term that comes into the picture is the fog computing, because what happens with the help of cloud, everything, the data that is collected, we will be sending it onto the cloud. But at some instance where the network is bandwidth constrained and the delay constrained, I would like to do the computation near to the devices where the data is actually collected. So for that, basically this fog comes into the picture. Like आपने देखा होगा, in the northern part we have the fog. Fog generally remains near to the road, the lower part. It is not at the higher upper side. So similarly, fog computing plays the role over here. In this, the cloud servers, those deal with very complex data, due to which the processing and computation cost is very high. So the data with the cloud cannot be directly transferred to the IoT devices due to their very low computation power and memory. So IoT generated data needs to be processed. So this increases the overhead for the cloud and hence decreases the efficiency of the cloud server. इसलिए हमने क्या किया? We kept a fog computing in between the cloud and the place where the actual data is generated, in between that. And there we are going to perform such kind of computations with the help of this fog computing. So storage, computing and applications to be consumed by the end users has a bigger proximity to the end users and bigger geographical distribution, local resource pooling, latency, and the backbone bandwidth reduction to achieve better quality of service is possible. Edge analytics, stream mining resulting in superior user experience is possible with the help of this fog computing. So akele, if we are talking about the cloud computing or we are talking about the IoT, it is not possible. In some applications, we need to store the data at the cloud. In some application, we would like to store the data near to the location where it is generated, so that we can perform the local computation over there and straight away we can use it. So it extends the cloud model to the edge of the network to address the applications and services, like applications requiring the lower and predictable latency, where latency requirement is very low. So geographically widely distributed applications in processing, faster mobility in mobile applications, large scale distributed control systems requiring the faster processing is done with the help of this. Now, this is the case where we are integrating the IoT and fog computing together. We can see here, we have the cloud at the top layer. It offers computational and memory resources for the efficient implementation of the authentication mechanism. And distributed fog computing environment provides enhanced security protocol. So at the lower bottom side, we have the sensors. There the data is generated in bulk. And then intermediately, we have installed the fog nodes. Those are acting as an intermediate between the cloud and sensors. So those data that will be needing to be accessed from multiple locations, we will be sending it onto the cloud. And some data, we will be keeping it in between these two that can be used for data standardization and reduction that we can apply. We have talked about the multiple applications of IoTs, and the in this figure we can see the supporting paradigms that supports it. The first one, on the left hand side, we have the IoT devices. Those are basically collecting the data with reference to the particular event that has occurred. And after that, we have the smart systems that that may be either smart healthcare or maybe the smart home or either the smart city. And those are connected with this cloud data center. You can see here, this is the cloud data center. So these applications, these smart systems can be either directly connected to this cloud data center, or they may be connected with the help of some other edge network resources or a fog computing kind of thing that are acting in between these two. So accordingly, when we will be talking about the security and privacy, these things needs to be taken into consideration, because if it is a direct communication between these smart systems to the cloud data center, so we need to provide the security at cloud data center as well as the smart healthcare system. And if we are encrypting the data and sending it to the cloud data center, then it is the secure one. But if we have some intermediate nodes in between, like in case of fog computing and edge computing, then we need to apply some security mechanism over here also. Otherwise, any kind of security mechanism will not going to help us. Now, in this slide, we can see that we have the sensitive data and the market significance data. So the more the sensitive data means more potential fraud and monetary loss. Like if we have the data with reference to, like I am in the university system, we have the data with reference to the students, like their address, their mobile number, there may be their father's name. This information may be useful for the fraudster or may not be useful. But suppose I am having the information of all the faculty and staff employees of the university, and suppose it consists of the file containing all the things like my account number, my PAN number, my bank account, my PRAN number, my IFSC code, all the things are available. So this information may be more potential for fraud and monetary loss. So we need to identify the data also, which data will be more vulnerable to threat and which data is not as such vulnerable. This needs to be taken into consideration while talking about this data. Another application that comes into the picture is the cloudlet. That is an application located on the edge of the network, basically edge computing we have talked about. So cloudlet is a small scale cloud data center at the edge of the internet that allows caching of the data and programs codes to permit mobile user to access powerful computing resources with lower latency. At some instances or some applications, we need to compute these things at the edge of the network rather than at the cloud. So for that, we do it with the help of this cloudlet. It is a small data center on the edge. So initial objective of the cloudlet was to provide the mobile application of substitution from the distant cloud, in which the mobile applications can offload the computing intensive task to the nearby cloud VM machines co-located with the same Wi-Fi subnet. So on the network through which we are connected to the cloud, on the same network we have installed this cloudlet. This will be helpful when we will be downloading the data from the cloud, or maybe when we will be uploading the data to the cloud from these devices. Another term that comes into the picture is the cloud of things. That says our IoT becoming so pervasive, it is available at all places because we are able to integrate it with the cloud computing. This is basically the cloud of things. When we integrate the cloud with the IoT, it basically forms the cloud of things, which is something kind of new terminology. But cloud itself has no significance. IoT itself has no significance until and unless we are able to have the data through cloud provided to the user, or maybe to the devices of IoT. Those are connected with the internet, and those data is available at any place with the help of cloud. In this diagram, it will show you, like, this is at the one place where we have installed our sensors, because either it is your refrigerator, or it is your smart home, or it is your smart watch, or it is your smart laptop. Anything it is basically going to generate some data. Those data will be required ultimately by the user, but user is not available at the same place. So user is at some different location. So we are going to upload that data onto the cloud. Now what happens in cloud, you are using the pay-per-use kind of model. So we will be able to store all the data over there. But when we will be going to access this data from the end user, it is not like that. We just download the whole data. We will be having a certain kind of query. Like, suppose I have collected the data from my vehicle. Now I am having the query. Now, what was the actual average for my vehicle for the last 15 days? How much fuel efficient was it? Or through which speed I drove my car for the last 15 days? Or suppose if I'm talking about the smart home, what was the electricity consumption for my refrigerator? So such queries can be raised by the user, and those can be answered from the data that is stored on the cloud. We will just apply some algorithms over there, and we can generate the data with the help of this. Only this, when we have certain specific user queries can be handled, only then it will be useful for the user. In this diagram, we can see that the various research areas, those are intersecting with each other. Like, one, we have the IoT domain, another one is the cloud computing domain, and third one is the mobile computing domain. All these areas have some intersecting portion in this, and the center portion that cuts all the three circles, it says it is the mobile IoT cloud computing. Those are used by the researchers nowadays. Now, going into the more deep about these architectures, we have studied about the TCP/IP architecture, in which we have the multiple layers. Similarly, for the IoT, when we talk about this IoT network, we have some different protocols. Those will be used here. Like, we have the 6LoWPAN, we have the RPL, that is the routing protocol for low power lossy networks, where the losses are very, very high when we connect the network, because there are a lot of packet loss. Similarly, we have the COAP protocol, that is the constrained application protocol. So they all basically work for here for the personal area network. They are meant for. IoT is also a kind of personal area network, but nowadays those networks are accessible with the help of WAN also. So we need the integration of this TCP/IP along with this 6LoWPAN. When we are generating the data, there we need these protocols, and when it is connected with the WAN, we are accessing it from the remote locations, then we can connect it with the TCP or UDP. But this 6LoWPAN, it is one of the important protocol that is used by this IoT devices. This is the internet end-to-end integration. You can see, please come later. So we have the physical layer, we have the MAC layer. Here, another layer that comes into the picture here, that is the adaptation layer. There, this 6LoWPAN comes into the picture when we talk about these protocols. And at the top layer, where we have the application layer, then there is this constrained application protocol that will be application specific, that will be comes into picture over here. So this is similar to the TCP/IP model that we have studied. Physical layer and MAC layer is somewhat similar, But here, more of the devices are connected with the wireless network kind of thing. So when we talk about the IoT, only limited devices are connected with the wired things. Rest all are connected with the wireless. That is why this IoT basically have some core domain from the wireless sensor networks. So this IoT has 4 essential components, out of which the first one is the wireless sensor network. Another one is the RFID. Those are basically the tags or the cards through which each and individual device is identified. Then we have the machine-to-machine communication. This is the important aspect of your IoT. We would like to communicate the machine without any intervention of humans. This is what is expected from IoT. Like we have an application of automatic watering of plants. Like we have an application of automatic watering of plants. Now what happens in this case is, I have suppose installed some sensors in my field. As soon as the humidity level in the plants will go below a particular threshold value, it should enable an alarm or sense the thing and send the signal to the tap, so that the tap will be enabled automatically and watering will start in the plants. We can make it to some another level with some advancement. Like we can integrate our smartphone in this, and we can predict the weather for the next 2 days. Suppose, although the humidity level in my plants has gone below a particular threshold value, but it is predicted by the weather department that during the next 2 days we are going to have a good rainfall, so it is not advised to give the water to the plants. So we have integrated the weather also into this, weather prediction also into consideration. If again after 1 day it will check whether there is a rain or not. If it is rains, then it is not required to give the water to the plant. Otherwise we will start doing it automatically, doing the watering to the plants. So such kind of analysis is required when we have this automatic kind of things with the help of these IoT devices. So this is possible. Like we have shared one application like automatic watering of plants. We can have some n number of applications over there. So we can think of in small projects. Now think of the other case here. Like we have the automatic watering of plants, but suppose there is some malicious user sitting in the internet, and I thought like you are checking the weather prediction and maliciously he has sent the wrong message into your system. Like there is a chances of rain for the next 2 days, although there is no such predictions by the weather department. So that is why security and privacy comes into the picture over here. So if you do not provide any security, your whole home will be at risk. And the fourth component that is part of your IoT is the supervisory control and data acquisition. That is the fourth component. So we need to control the data that is collected by these devices, and accordingly, so that we will be able to take the actions. These are some key elements. Those will be used by the cloud computing paradigm, because as I said, any data that we are going to collect, it is not going to be kept at the local storage. Everything is put onto the cloud, because with the help of that, we can access our devices remotely. Like suppose in our building, in our office, I would like to enable a kind of system in the classroom. As soon as the first student enter in my classroom, automatically the electricity will be enabled or the tube lights will on. If it is the summer season, automatically the fans will also be switched on. If it is the summer as well as it is the humid season, the AC should also be automatically on. And as soon as the last student will go out of the classroom, automatically the fans, electricity and air conditioning should be switched off. So those kind of applications can be developed with the help of these IoTs, and there is no human intervention at all. This is possible. We have many other applications. The people, those who are listening, maybe some of the research scholars are also listening for this lecture. So they can implement such small applications at their organization. It will be helpful for you. Then we have some essential characteristics, because when we are talking about a limited organization like our organization, then we can store this data onto a local server or local place. But when we are talking about the decentralized kind of network, like our vehicle, my home, then we can load such data onto the internet directly. So this is possible with this. So we have the IoTs and cloud data communication that is possible with this. We have the IoT layer at the top because all the applications, those are working with this. Like we have talked about the weather prediction, it is possible only with the help of application layer. So we have at the top layer some IoT layers. Then at the middle, we have some clouds, and at the lower layer, we have the sensors or actuators. Those are connecting this and sending it to the IoT devices. Now, these communication may be connected either with the help of your LAN, or maybe it is connected with the help of your Wi-Fi in your local network, or maybe it is the mobile network kind of 3G, 4G, 5G, Wi-Fi, WiMAX, any network may be connected through this. You can connect this. But when we talk about the cloud of things technology or the IoT, these are the important technologies, those comes into the picture. First one is the ZigBee. Second one is the 6LoWPAN. This we have already discussed. It is used for the RPL, that is the routing protocol for low power and lossy network, where the less power is required and lossy network is there. Then Bluetooth low energy, we have the constrained application protocol that is based on the REST architecture. REST is basically the representational state transfer kind of network that is suitable for these technology. We have the datagram transport layer security protocol also that is possible. We have the message queuing telemetry transport, advanced messaging queue protocol. These are some advanced protocols. Those are used in these fields. Now, what is the concern that happens with the privacy here? Who has access to the data? Now you have stored all the data onto the cloud or to a common location. Now, who are the person, those who are authorized to access those data? Then where is it stored? If it is stored onto the cloud, now cloud is basically the third-party services that we are taking. So how the security will be enabled over there? This is another challenge over here. It is something like that. There are two people who are using this information, but they are storing the information at my cloud. Now cloud is totally being taken in by me. Now you need a particular kind of mechanism where even the cloud service provider will not be able to access the data. Although this data is stored at my cloud, but I am not able to understand what is there stored. So this is also possible. And we also expect the computation should happen at the cloud. So this is possible nowadays with the help of some encryption, decryption kind of mechanism or the homomorphic algorithms. You will be able to storing the data onto the cloud in some encrypted form so that even the cloud service provider will not be able to use it. But some algorithms or some models can be applied over there so that the computation can be performed onto the data without even the knowledge of the cloud service provider. So how many copies exist in the cloud? How to be sure that it was deleted when requested? It will be possible that the same copy is kept over there. So is there any laws or privacy policies respected by the data actors? So all such things are available nowadays, and all laws are in practice. These are available. So heterogeneous network, this we have already discussed. This caused by a variety of devices, operating system, like sometime we are connected with our smartphone. These are using the Android operating system. Sometime my refrigerator is connected to the internet, which is the smart refrigerator. That may be using the different operating system. And sometime my laptop is connected to the internet. It is using the different operating system. So performance of communications, computations, and storage aspects also vary. My smartphone is having different level of computation and communication. Similarly, refrigerator is of different level because it is using a microcontroller. Its processing capability is very low. Its data storage capability is also very low. But when we talk about the laptop, it is a full-fledged computing device or storage device. Reliability is also needed for mission critical applications, like we have talked about the human this medicine kind of application. Like suppose a pacemaker is installed in one of the person's body, and that pacemaker is generating the signals. Those are being sent to its doctor. But suppose if somebody is able to hack into the network and he's able to change some of the parameters of the pacemaker, automatically sometime the heartbeat is suppose normal, sometime it is low. When it is low, the pacemaker is working. When it is normal, the pacemaker will automatically cut off. But suppose if some hacker is there, he will be able to enter some network and able to change some of the parameters. It may be even dangerous for a person who is using the pacemaker. So such the things. So reliability is required. Big data can cause the problems for transportation, storage, and access and processing. Obviously, nowadays we are collecting too much of data for some business specific decisions for the future. Like Google is collecting a lot of data. We all know about this. Like you have just seen the places, my activity, you can go into the Google, your recent places which you have traveled through, everything is being stored by the Google. And on the basis of that, they are offering many of the advertisement to us. Like suppose you just search any of the, suppose you would like to buy a car with the help of OLX. And suppose the same account with the same Gmail account, you are having your Facebook. So you will be finding some applications similar to that onto your Facebook account also. So Google is saving a lot of our information. So when we have a lot of data, definitely the storage is a challenge, and as well as the monitoring is also a challenge when you are storing this data. Because more the data, more challenge there will be to store it properly or confidentially. So this is the CIA tried. When we talk about the security, there are 3-4 things that needs to be taken into consideration. First one is the C stands for the confidentiality, I stands for the integrity, and A stands for the availability. There is a fourth one also that says the non-repudiation. But when we talk about this applications, those are with reference to the IoT, we are limited to these 3 only. Confidentiality says preserving the unauthorized restrictions on the information access and disclosure. If one information is sent from A device to B device, nobody in between the link between the A and B is be able to understand what has been sent. Similarly, it is the integrity, like guarding against the improper information modification. Although an intermediate person who is sitting in between the A and B person, he is not able to understand what is being communicated, but if he is able to modify that message by generating some kind of error into the message, ultimately this message is also of no use for the B party. Maybe suppose I have sent a message like I will deliver a talk tomorrow at 9 AM to my student, but somebody has changed the message from 9 AM to 10 AM. So the message, those will be received by my student. I will be delivering the lecture tomorrow at 10 AM. So student will be coming at 10 AM. I was there at 9 AM. There is a complete chaos. So integrity of the message is also required, but I have sent from the A location, the same should be received by the B location. And also with reference to the confidentiality, we say nobody else is able to interfere in between and he will be able to steal the information. And the availability says ensuring the timely and reliable access to and use of the information. If some information is sent by location A, it should be available to the B at all times. So such things CIA should be taken into consideration when we talk about this IoT applications. So fog computing inherits these security issues of cloud computing as well, and those we will be using here. So these are the major elements of the IoT systems. Those we talk about the at the bottom, we have some IoT devices, maybe sensors or actuators. Over there, we have some REST network, that is the representational state transfer kind of network. Then we have the IoT's gateways. Through that, we will be able to connect with the help of edge network or fog computing kind of network, where we are doing some level of computation or storage at the edge of the network over here. And finally, at the top, we have the cloud. So all the data will be going to the cloud only, but in between, we have some edge network also. So we need to apply these security or the CIA tried at each level when we talk about this. But now, the major problem with this IoT is all such things, those were possible with the help of conventional CIA tried, is not straight away applicable to the IoT devices. Now, why these are not possible with the help of IoT devices? Because IoT devices, the first property we talked about, these are resource constrained devices. They are not full-fledged, they don't have the full-fledged computing capability. So if we apply all such algorithms, those were possible with normal conventional cryptography kind of thing, then the system will collapse over here. I will share another example before going further here. Like there is one big project the government of India is in process, like one nation, one card. One nation, one card. Like nowadays we are having a separate ATM card, we are having separate credit card. When we go to Delhi Metro, for that we are having the separate card. When we go to Kolkata Metro, separate card, and there are a number of cards. Government of India has proposed one nation, one card. There will be a common card that will be applicable for all the applications. Now, this project is being handled by the CDEC. Now, what is the challenge with this card is, like we talk about the SBI. Some of the users may be having their account in the SBI. Some of the users may be having their account in the HDFC. Now, SBI nowadays is offering, suppose you would like to withdraw the money from your account, they will be sending the one-time password over there to enable the security. So only through that you will be able to withdraw the money. But if you talk about the other bank, they are not offering one-time password when you are withdrawing the money from the ATM. But let's talk about the case if you have a common card with these banking facilities as well as for the Delhi Metro. Now, I think all of you have seen the crowd, that those who are traveling by the Delhi Metro. The normal Delhi Metro card even takes less than 1 second to scan it, and just the money is deducted from the card without any kind of security over there. Like there is no one-time password, there is even no password entered by this. Like when we withdraw the money from the ATM, we need to enter my PIN. When we withdraw the money from the SBI, we need to enter the PIN as well as the one-time password, double level security. But when we enter into the Delhi Metro card, this card is not going to take any kind of security mechanism, because if security kind of mechanism is implemented, it is going to take some more time. Now only there is a very huge queue over there. There is a huge queue in the Delhi Metro 9. If one card will take, suppose 5-10 seconds for verifying the things, then there will be a huge queue and totally system will collapse. So we don't want such thing to happen. That is why Government of India is dreaming about a dream project of one nation, one card, which will at some location, it is not going to ask for any kind of security when it comes to, suppose you are using the same card at Delhi Metro, but when you are going to use same card for internet e-commerce website, it is going to ask for one-time password. But when you are going to withdraw the money from the bank, it is going to ask for the PIN. So same card, but different security mechanisms are going to be implemented. This is a challenge. But here in case of IoT, as we talked about, these are heterogeneous devices. So some devices are well capable of computation. Some devices are not even capable to perform even the small level of computations, because they don't have much computing capability over there. This is when I baat ki smart refrigerator, even my smart watch, it does not have a big processor over there. It does not have a big storage capability over there. So how they will be able to do that? So that is not possible. So that is why it is difficult to update. When an attacker compromises a vulnerable IoT device, it is difficult to shut down that system. Even rebooting or reinstalling its software or replacing its part or subsystem are not ideal for multiple IoT system. Kisine hack kar liya, even one of our component of the IoT network, even it is not possible to reboot it, because once the malicious software has been installed in any of the component of my IoT network, now the whole particular node as well as the whole network has come into the purview of that particular malicious user. So it is unpractical and infeasible to use the security firewalls for IoT devices. यहाँ पर नहीं कर सकते. So public key infrastructure is not suitable for IoT environments. As I said, PKI cryptographic algorithms are complex and computationally expensive. Those can't be used here. And IoT devices have limited battery processing capabilities, so complex algorithms can't be used. So here, mutual authentication between the device and gateway is required. So IoT gateways needs to manage a trust relationship with the devices so that these devices can be authenticated and authorized to share the data. हमें कुछ ऐसा mechanism चाहिए that should be less complex, but still it is able to manage the trust relationship between the devices and the gateway node. So it needs to ensure authentication prior to communication with any device, enabling the proof of origin of data. As soon as any node enter into the particular network, it should be authenticated prior to the communication. Before it communicates with any other device or node of the network, it should be enabled with some proof of origin of data. So these devices are assigned some unique identities that disallows the reuse of security credentials across the devices. So it is a challenging task to store all the data collected on the gateway and then allow the user to access the device data via the gateway using the CIA tried. But still, it is required in case of IoT. Otherwise, the whole system will be at risk. Then when we talk about this machine-to-machine kind of architecture, the device domain is also very important. Like it consists of the set of devices involved in running the machine-to-machine application. We should be able to know prior. We should know the prior. What are the types of devices those are going to be connected with my network? So network domain, it consists of a set of heterogeneous access networks enabling the device domain and the application domain to communicate. Like किस type का network से आप connect करने वाले हो, whether it will be a WiMAX kind of thing, whether it will be a DSL line, it will be a Wi-Fi network, it will be a 3G network, and accordingly, the device that is going to be connected, that will be enabled or disabled accordingly. Then we have the application domain. It includes the servers where data collected by the machine-to-machine devices or other network nodes are stored. So these real-time data is made available to legitimate users through a variety of machine-to-machine applications. This machine-to-machine communication basically allows wireless as well as the wired system to exchange various information without human interventions. This is the key for IoT system. Now, these are the vulnerabilities when we talk about the machine-to-machine kind of systems. First one is the configuration attack. Now, any node that enters into the system, and suppose there is some malicious user who is sitting outside, through this, he will be able to install some software, some malicious software onto the node. That is a kind of configuration attack. Then this DOS attack, it is possible in conventional network as well as in IoT also. It is a denial of service attack kind of thing. I have installed one node over here that is providing the services to the user, but malicious node that has entered into the system, it is blocking the services of that particular node. Similarly, we have the man in the middle attack, and this person who is man or maybe the machine here, because in middle it is not the man, it is the machine which is just dropping the packets. Whatever it is receiving from the, suppose, A node, it is just dropping all the packets and they are not going forwarded. Then this machine may also do the selective forwarding and interception. Like some of the packets, those were received from the node A are forwarded and some of the packets are dropped. The user data and identity privacy attack is also there. Like it is analyzing the user data and sending it to the outside network and disclosing the identity of the nodes. So that is why these machines are vulnerable. This we have already. For that, the solution is the key management. Like we talked about, the normal cryptography algorithms may not work over here, but we need to have some special mechanism over here. Like key management solution is required, whether it will be authentication, confidentiality, integrity, or even the privacy. They are all based on the use of keys. We need to have some kind of keys. Now, who will be sharing the keys? Who will be authenticating? That is a challenge here. So consequently, the entire security and trustworthiness of any communication relies on the security of those keys. Until and unless keys are compromised, my network is completely secured. Any node, even if it enters the network, but because keys are not compromised, that particular machine or the node will not be able to compromise either the confidentiality, integrity, or the authenticity. Even more crucial when dealing with shared keys, especially is the case of group communication. Because in IoT, it may be possible that there is a network where we don't have one-to-one communication. It may be kind of one-to-many communication. Like I have given you one example of smart car. Suppose an accident has been discovered ahead. So I will be sending the message to all the cars those are coming behind. It is a kind of one-to-many communication. So there we need to have the key management should be done in that way. So indeed, these keys need to be updated whenever a device joins or leaves a group in order to provide both backward and forward secrecy, because these keys can't be kept static. Because if one node enters into the network, he has known about the key. If he leaves the network, it may be possible that he or she may be disclosing the keys to the outside network. So these keys should be updated regularly from time to time. Moreover, for greater security, all used keys should have a limited lifespan. We may limit the lifespan of a key for suppose maybe 10 minutes, maybe 20 minutes. And please come later. I'm in lecture. Okay. And out to be updated after a given time period. So moreover, for greater security, all used keys should have a limited lifespan and out to be updated after a given time period. After some time period, maybe it is defined maybe as suppose maybe 5 minutes, maybe 10 minutes. These keys are updated time to time. And all nodes in the network must be communicated accordingly. So key management is basically a key in case of IoT network. So node capture attack is one of the prominent attacks that completely destroys the integrity and confidentiality of the sensor network security. If any of the node is compromised, whole security of the network is compromised. That is why this node capture must not be done in the network. So if there is a reliable, attack resilient and realistic key management system, an attack like physical node capture would not be able to destroy the integrity and confidentiality of the keys to a great extent. Agar hamara system strong hai, their key management is successful, then even if the node is captured, still keys are not compromised. Only one of the node will be compromised. The whole network will not be at stake. Attack modeling can be effectively used to improve the network designer capacity to protect against such attacks ahead of the occurrence in the network. The attack modeling of a node capture may also be applied to know the attacking activities of the adversary, and hence the complete attacking process can be more efficiently expressed and used. This we will be discussing it further in detail in future slides. Now, this is one of the important mechanisms that was proposed by Sahai and Waters in 2005. That is the attribute-based encryption. It is widely used in this IoT. It says attribute-based encryption is a public key-based one-to-many encryption that uses the identity attributes of the user. Here you can see it is the one-to-many kind of encryption. So this is one of the requirement of IoT, because at a many time one device is communicating with multiple devices. So the identity attributes are specific for a particular user. Here user may be either user or maybe the machine. These could be current city of the user, his last visit, or role of the user. Here we have taken one application here where we are talking about the user. We have taken one of the attribute as the key. So the attribute set of the user will be used as the attribute based encryption procedure to generate a private key. So I have taken the attribute as suppose his last visit. We have taken multiple attributes in that, like suppose it is the Delhi, Mumbai, Kolkata. So if the user enters the attribute out of that, it is valid in that case. So decryption would be possible if the attribute set satisfies the defined access structure. So with the help of the attribute based encryption, data could be stored on an untrusted cloud as only the user whose attribute set matches the access structure. So here we are not considering the separate key like we do in conventional key management system, where we have the public key cryptography or the asymmetric cryptography kind of things. Here we are using the attribute set as a one set of key, and if the attribute set of a particular node matches, automatically it will be allowed, otherwise it is disallowed. So attribute-based encryption scheme uses the two types of data. It uses the identity attribute set and the access policy that needs to be developed here. Whatever access policy you are going to use, that needs to be taken into consideration, and accordingly the decisions will be taken. Let's take another example over here. You let an attribute set be the date, time, manufacturer, and model ID. Now, suppose user one has the key of date and manufacturer. Now it is, and we have taken two things into consideration. One is the identity attribute set and another one is the access policy. These two things needs to be defined here. So we have the identity attribute set as this one. And suppose access policy says if the ciphertext to be decrypted has an access policy of date and manufacturer. If these two attributes are there, it will be able to decrypt the ciphertext which has been communicated over here. So if suppose user one has the key as the date and manufacturer and user two has the key as date and time. So only user one in this case will be able to decrypt this ciphertext. User two will not be able to decrypt it. So with the help of data itself, we are enabling the security mechanism over here. Whatever data these users are going to be stored onto the system, accordingly these attributes are selected and this key management is done. This is one of the mechanisms that was proposed in 2005. After that, there are multiple mechanisms proposed. There are many algorithms are there, but this is the very fundamental algorithm. Those are proposed by Sahai in 2005. So data could be stored on an untrusted server as only the user whose attribute set matches the access structure will be able to decrypt the data. We can change the access policy time to time, and suppose attribute set may also be changed time to time so that the keys are changed regularly. Then when we talk about this attribute-based encryption, we have two approaches over here. One is the key policy attribute-based encryption, and another one is the ciphertext policy attribute-based encryption. In case of key policy attribute-based encryption scheme, the ciphertext is defined using the attribute set that was generated using the user's attributes, while the user key is generated using the access policy. We have talked about in case of attribute-based encryption, we have two things. One is the attribute set, another one is the access policy. So it says in case of key policy scheme, ciphertext is defined using the attribute set. Ciphertext banega with the help of attribute set. And the user key is generated on the basis of the access policy. Whereas in case of ciphertext, it is just the reverse of this. So this is reverse in case of ciphertext policy, attribute-based encryption. The user key is generated using the attribute set, whereas the ciphertext is defined using the access policy. So we have just replaced the two things, but the two things those were talked about will remain same, either whether it is the key policy or it is the ciphertext based. Now, what are the issues in this attribute-based encryption scheme? The first and the major issue is the collusion resistance. Now, users can't decrypt a ciphertext using their individual key. Akele key se to nahi kar sakta tha, but suppose if two of the machines or two of the users, they join hands, and by joining, they will be able to get the attributes. Those were either not available with that particular machine earlier. So now they have joined hands, they merge their secret keys to make a new secret key in such a way that it could decrypt the ciphertext. So collusion problem needs to be solved in case of attribute-based encryption. This is one challenge over here. Although it seems very simple, it is working fine. But when some machines join, because it may be possible that if there is any hacker or some malicious user, he may join the network with multiple devices, and those multiple devices may join together and they are going to create a problem. Similarly, we have some backward security issue. Here, the nodes or users who have just joined the system should be prevented from accessing the data that was transferred before their joining. Because what happens, whatever the data has been communicated earlier, it is available with either edge network or maybe the cloud or maybe some of the networks over there, some of the nodes over there. But as soon as some new node will be joining, the new node is joining at the current time. So the earlier data that has been shared in the network should not be available to the new user. So that is only possible if we have some key distribution mechanism such a way that past data will not be available. And similar is the case for the forward security issue. In this security concern, if one of the node will leave the network, will leave the IoT group, it should be prevented from accessing the data currently being exchanged, because he is no longer now a part of a particular network. So how we will be able to do that? So this is not possible with the help of normal conventional attribute based encryption. Here we have these issues over here. So these are the security requirements for different pillars of the IoT systems. As we talked about, IoT is not just the actuators or the sensors, those are collecting the information. We are having the multiple devices at different levels. Like we have the IoT users at the first layer, then we have the IoT devices connected with that, then we have some middleware, maybe gateway nodes, maybe some edge network, after that maybe some fog network over there, and finally at the top we have some cloud. So different level of security is required at different pillars of system. You can see at the IoT users, we need the privacy and information security. We need some access control also. But when we talk about the IoT devices, we need some identity mechanism. Each device should be addressable, identifiable. Then authenticating each device. Whatsoever device will join the network, there should be some centralized authority which will be authorizing or unauthorizing a particular device over there. Then some trusted data. Whatever data is being generated by these IoT devices, it should be the trustworthy. It should not be like that they will be just generating the garbage data into it. And some access control. Who are the persons or the other devices, those will be able to access these IoT devices. Then at the next layer, we have the middleware or the IoT gateway or the gateway nodes. There basically we need the secure communication only, because none of the users or the devices can be directly interacting with these middleware devices. But still we need some data centric security solutions, or the backbone kind of network is there. We need to protecting the middleware. It is required over there. So it is common either for the gateway nodes or for the edge nodes over there. And finally at the cloud, where we are storing the data, so data protection should be required, because here we have applied the security, here we have applied the security, but if the security fails at the cloud where the whole data is available, ultimately the data, the CIA tried is not fulfilled. And once the data is stored onto the cloud, it should also be provided access to the authorized user, because user is at the lower end over here at the first level, but data is available at the cloud level. So we need to provide a certain mechanism over here through that the authorized person should be allowed to access the data which is stored at the cloud. So we need to apply some different security mechanism over here. No, please come later. So we have some different attacks over here. Like one is the side channel attack, which is a unique kind of thing here. Like the cryptographic algorithms are always implemented in software or hardware on physical devices which interact with and are influenced by their environment. These physical interactions can be monitored by adversaries and may result in information useful in cryptanalysis. This cryptanalysis, they are using some analysis and they can decrypt it by applying some bots. So this type of information is called side channel information, and the attacks exploiting side channel information are called the side channel attacks, also called as the implementation attacks, because these algorithms are always implemented in the software or hardware. If you are able to monitor these algorithms with the help of some devices, then cryptanalysis, they will be applying some brute force kind of attacks and they will be able to know. Then impersonation is also possible here. An attacker may spoof the identity of a back-end server and machine-to-machine device or a gateway. For example, an adversary who succeeds in spoofing a smart meter identity can make its owner pay for the adversary charges. So there may be multiple applications over there, because here an attacker is able to spoof the identity of the neighbor. So whatever the billing will be generated, it will be in the name of the neighbor. It is simple. So in the case of e-health applications, such attack may pose even the threat to human lives. This we have already discussed. Because suppose I am using a pacemaker and suppose some of the parameters of the pacemakers are hacked, then the person's life is in danger. Then we have the man in the middle attack. Attacker is active between the front-end sensors and back-end service systems in order to achieve the eavesdropping or the fake data. Suppose with the help of this IoT network, you may be able, you are trying for a bid or a project that is going to be closed together. But there is a man in the middle attack in your network. So attackers can gain access to the communication channel. So whatever information you are communicating from your network to the outside agencies, this man in the middle is able to crack it. And the patient and healthcare systems, as they will insert themselves and gain access to the data being shared between the two parties. The healthcare system needs to authenticate each user to overcome this man in the middle attacks. Then resource exhaustion, because if any malicious person or malicious entity enters into your network, or definitely your resources will be exhausted. So prematurely drain the device battery, causing the application failure. Suppose a pacemaker has been installed in the body, which is working on some kind of battery, but some malicious software is installed with the pacemaker. So ultimately it will start consuming more and more battery. So the device, which may work for maybe 20 years, 30 years, will drain its battery within suppose 1 year. So ultimately the person's life will be in danger. Similarly, if I have deployed some sensors in my building, suppose as soon as there will be a fire, automatically the alarm will be enabled and the signals will be sent to the users. But if those devices are compromised, their battery will be drained very fast, and it may be possible that the actual working of the device may no longer be working. So for example, when dealing with telesurveillance application, in order to prevent it from notifying the user of an intrusion detection. So your battery is drained off, so your IDEA system is not working now, as soon as the malicious user or the entity may enter the system. The resource unavailability may lead to tremendous financial losses in many applications. Like suppose you are providing cloud services to the users. For each and every service, you are basically charging the amount. But if you are not able to provide these services to the user, ultimately what happens? Nobody is going to pay for you that. So ultimately you are losing the money. Similarly, blackout may also occur if your whole grid may collapse. So due to the pervasiveness of the M2M devices, through the eavesdropping of exchanged packets, malicious parties can invade users' privacy and link machine-to-machine devices, obtain the data of individual and thereby interfering the user's habits, health conditions, and so forth. Many of the information can be easily revealed through this if this privacy attacks occurred in the network. So attackers may disguise themselves as normal users or connected equipment and reveal a user's network ID or confidential data to an unauthorized third party. Configuration attack, we have already talked about. The fake software updates are provided to the entity or the nodes in the network, and once it is installed on any of the node in your network, it may be copied onto all the machines. Those are part of that particular network with the help of this configuration kind of attack. Denial of service attack, we have talked about. This is possible. User data and identity privacy attack. It includes the eavesdropping on data from users and devices. Attackers may disguise themselves as normal users, and users' information is stolen. This is the multi-vector DDoS attack. You can see here we have the TCP sync plus UDP flood attack around 4.71. We have CLDP reflection plus UDP fragmentation attack. So this is the percentage in which you can see this DDoS attack happened with different kind of protocols used, maybe either the UDP flood or maybe the internet control message protocol. The ultimate aim is to just disrupt the network, because it is not always required to steal the information from the network. Sometimes just disrupting the services of the network will itself be sufficient. This is possible here. Then we have the network-based DOS attacks like the UDP bombing, TCP sync flooding, ping of death, Smurf attack. All these attacks are also possible in IoT. The system is flooded with the spoofed ICMP message, creating high traffic on the victim's network. So even if one of the node is compromised with this ICMP messages, with bulk messages over there, maybe your gateway node is down, and all the nodes, those are part of your network. Please just wait. I am in the lecture. Please wait. Please shut the door. So Smurf attack, the system is flooded with spoofed ICMP messages, creating a high traffic on the victim's network, and whole network may gone down. So most involve either the resource exhaustion or the corruption of the operating system, runtime, environment failure. This is done over there. So we have the ZigBee network kind of thing. So each ZigBee network includes a trust center. We may connect either with the help of WiMAX, maybe ZigBee, maybe the Wi-Fi. You can connect it with multiple modes. So each ZigBee network includes a trust center. That is a device trusted by all the other nodes in the network. We can have such things in our normal IoT kind of network also. The trust center usually corresponds to the network coordinator and is responsible for authenticating the devices that require to join the network. So any node or machine that joins the network, it has to be authenticated by the trust center. So it has to be decided whether to accept or deny the join request. Maintaining and distributing the network keys and enabling end-to-end security between the devices. Now let's talk about the intrusion detection system for IoT, because this IDS may help the network from preventing the multiple kinds of attacks. Maybe it is a honeypots kind of thing. It helps a lot. Now, what is possible for IoT? So besides preventing the attacks, it is also fundamental to be able to detect the ongoing attacks. Complex antivirus softwares and traffic analyzers can't be used for IoT devices due to the resource and energy constraint. This is a challenge over here. For this, lightweight intrusion detection methods have been presented in the last few years. Like the operating system for the IoT devices are different. Like we have the tiny operating system for the wireless sensor network. Similarly, those we have the different operating system for and mobile devices or smartphones rather than the operating system for the computers. Similarly, we have the separate IDS, lightweight intrusion detection system for these IoT devices. For examples, so here we have some limited functionality or capabilities like anomalies in the system parameters like CPU usage, memory consumptions, and network throughput may be analyzed. All the intrusion detection system, the functionalities, those were available with the conventional system is not available here. So it obtained the cryptographic keys here. Sinkhole attack is also possible here. Though a malicious entity legally joins the network, but then pretends to have an efficient routing path towards the coordinator in order to attract more traffic flows. So what happens in this case, all the traffic, because it is showing that the better path is passing through this particular node, so all the traffic will start coming towards this node. But rather than forwarding the packets further, it is just dropping the packet. So it is a kind of sinkhole, which is consuming all the network traffic to a particular place. So attackers can modify or drop incoming packets. Network may get exposed to internet attacks. A ghost attack may aim to drain the ZigBee node energy. And ultimately, the network will be at stake. Now, another challenge that happens is the key discovery. So a possible attack vector in ZigBee network consists in discovering the keys used to secure the communications. Because once the key is compromised, your whole network is at stake. More the complex mechanism you attain for the key distribution, the IoT, because it is a resource constraint, it will not be able to work. So the repeated encryption of known and unfixed messages makes the system vulnerable to plain text attack. So this technique enables the recovery of cryptographic key by having access to both the encrypted as well as the decrypted messages, hence to ensure the high security level. This is there. Then botnet kinds of attacks are also possible here, because a bot is a collection of internet connected devices infected by malware that allow the hackers to control them. So these are the group of nodes. Those may be part of your network or maybe the outside your network. Through that, it is connected with your network. So cyber criminals use these bots to instigate botnet attack, which includes either the malicious activities, maybe the credential leaks, maybe the DOS attacks, maybe the DDoS attacks, whatsoever it is. Then there is another Mirai IoT malware. So malwares are very common. Even the ransomwares are there. You have heard about even the WannaCry ransomware. It stuck, I think, 5-6 years back. The whole world was were attacked by that. In IoT also we have the malwares, like one is the Mirai. So this automatically finds IoT devices to infect and make them part of the bot. Bot is basically the robot. So then this IoT army is used to mount DDoS attacks to flood targets servers with malicious traffic. To fulfill its requirement function, Mirai performs wide-ranging scans of IP addresses. The purpose of these scans is to locate under-secured IoT devices. It will just scan all the devices and just try to identify the nodes or the devices those are less secured. So malware scans for telnet before attempting to hack into the vulnerable devices using a brute force attacks, featuring 62 different password user combinations, because many of the users even don't change their usernames and password. So with the help of that, it is able to enter into the network. So once an IoT device joins, it immediately begins scanning for other vulnerable devices to compromise it. Then this modified Mirai, it's the routers, most of which were made by Zyxel and Speedport and had port 7547 open. By default, many of the manufacturers keep one of the port open. So they just try to scan into the network and try to identify the nodes which has a particular port open. Like here in case of routers, this 7547 port was left open in case of Zyxel or Speedport. So if any of the device is manufactured by this, most of the administrator have forgot to just close this port because it is by default open. Although it has not been specifically enabled by the users, by default it is enabled. Even the rebooting does not help because it is by default, it is open. So attackers in a particular case made by 253,000 bits sending this much per second to generate the traffic, and ultimately the whole network will be down. It is not able to provide the services to the users. Then once the network has been compromised, whether it is the IoT network, now what are the forensics that we can go ahead with that? So cooperates with the network traffic monitoring and analysis. We maintains the log of each and every activity. Whatever activity, whatever node has joined, whatever action he has performed, for each and everything, we are creating the log. And log is always maintained in the permanent storage. So objective of the network forensic is to determine the identity and location of the attackers and find out the crime process of entire network attacks so that in future such things can be stopped. Replay or duplication attacks due to the fragmentation is also possible. Users can just fragment the packet, and at the receiver side the packet is clubbed together and there will be overflow kind of errors over there. Then insecure interfaces. There may be multiple interfaces in your devices, maybe multiple applications are installed over there. So insecure interfaces needs to be checked thoroughly. Like interfaces used through web, mobile and cloud are vulnerable to different attacks. Like in case of our web servers, if it is connected with the help of our IoT network, my web server, there may be some SQL injections are installed over there. So I need to check those ports or those locations thoroughly, so that those interfaces can be closed securely. These are some countermeasures against the attacks on the authentication schemes. Like we can have some lightweight authentication schemes, cyclic redundancy check kind of thing. We can have the ultra lightweight authentication scheme. We can have some middleware based system models. Those can be installed on your edge network or the edge devices. Access control mechanism, data centric security solutions. We can have the public key infrastructure providing like simple algos may be used, elliptic curve cryptography may be used. Then blockchain may also be brought together with the IoT it has not been a reality till date, but maybe in future we will be talking about this, because individual node in my IoT is not capable enough for computing as well as the storage. But in case of blockchain, what happens is we have the group of nodes, those are working together. So in this also, we can have the group of nodes, they can work together and can perform some complex algorithms also. So this may be the future in the coming years, where we will be finding the blockchain kind of technologies for implementing the security in our IoT network. Like smart contracts may be deployed for handling and preventing various attacks, just black hole attack. Please wait. On recurrence of malicious activities in the network, the node is removed from the network and can no longer take part in the transactions, thus making the system more resilient to cyber attacks. This is a kind of scheme you can see here, where we have the blockchain based group key management scheme for the IoT. Here we have some wired or wireless networks. We have some the directions of message propagations. We have the fog systems, and we may apply some kind of blockchain using these entities, and those can be providing some security mechanism to the users. Then honeypots and active defense systems may also be enabled in case of our IoT IDS, where honeypots may be deployed over there. Then this is the life cycle of the IoT device management, where we talked about the there's the manufacturer, then after there is the distributor, then the delivery people, then the deployment model, then the maintenance and the retirement. So at the each different life cycle stage, different kind of security mechanism needs to be established. We talked about this IoT malware. So it is just expected that the networks with IoT devices will soon be outnumbering the traditional computing devices soon, because as we have discussed, he may be one device, one people will be joining with the multiple devices. Soon we will be having the
इस सेमेस्टर की तो दिखेगी ना, जमा करी होगी ना, और उसके पहले जमा.
So we will be able to detect these users, these malicious users, with the help of these blockchain technologies maybe in future. Then anomalies based detection versus the signature based detection, like the high network latency hai. On the basis of certain parameters also, we will be able to analyze the particular network, like the high volume of traffic, unusual system behavior, like we may be able to do this also with the help of this. Then there is another area in which people are working for this security mechanism, like earlier antivirus softwares or those were developed, they will be working on the static mechanism kind of thing. We will be giving the static information, static cases, static mechanism, and on the basis of those rules, it is detecting whether it is the malicious or not. But nowadays, AI based or the machine learning based of techniques are also being used, where we can say the dynamic behavior is being monitored with the help of some machine learning algorithms to analyze whether it is a malicious user or not. Like in credit card fraud detection, we all know machine learning is used a lot. Similarly, machine learning may be used here also to provide some artificial intelligence to the IoT network, so that we will be able to know on the basis of the training and testing data, the machine will be writing the code for this anti-malware software, and they will be able to generating the users requests. We may generate even the binary classifiers or maybe the distributed kind of classifier, so that we will be able to know whether the particular node or a particular user is malicious or not. We have different approaches for this machine learning nowadays. We may apply such things, maybe you can apply some SVM, we may apply some neural network to apply some to provide some security mechanism. But the problem here is again with when we integrate these things with the IoT, we need to have some strong computing facilities. This we have discussed here. These are some applications. Because when we talk about these things, it is not like that we study these things in separate. Like we talked about the cloud, we talked about the IoT, we talked about the fog, we talked about this data analysis portion. But in real practical scenario, we need all these things together so that we will be able to perform some action. Now, this is why we use the machine learning here, because feature-rich smartphones and applications have induced security research on various new aspects. Like as we have talked about the WannaCry anti-malware that struck the world few years back, similar kind of malwares or the ransomwares may attack the smartphones also, or may the IoT nodes also in future. So we need to provide some mechanism over there, because simple rule-based mechanism will not be enough to provide the security. We need to provide a security mechanism that will write the code on its own behalf, like automating the automation. This is possible with the help of these machine learning kind of things. These are the references that used for this PPT. I will be sharing this PPT with the coordinator, sir. Now, if you have any questions, we can have some time and we can have some question and answers also. So this is from my side. We can have some questions from the participants if you have, or we can have some feedback from the participants.
Okay, thank you very much, sir.
You can unmute yourself.
Yes,
yeah.
Yeah.
Good afternoon, sir.
Hello, sir.
Yeah, ma'am, you are audible.
Thank you so much, sir, Dr. Rakesh Kumar, sir, for this informative session. I would like to ask one question that nowadays IoT is going to be used in various fields. So I want you to just describe, just brief us how IoT technology is going to be used in agriculture monitoring system and for the growth of agriculture production.
Yeah, I think, ma'am, with reference to your question, I think I have already discussed one of the application, like the automatic.
Yes, sir. Yes. You have discussed one water.
We may have another applications like we may with the growth of the, suppose I have planted one particular kind of crop in my field, and according to the growth of the plant, I may even deploy some kind of pesticides or maybe some kind of urea according to that. So we may keep some parameters fixed over there. Suppose if this is the growth within the particular duration, maybe 2 months, maybe 3 months, if the growth is less in my field with reference to my past experience, maybe for the last 4 years, or maybe the nearby fields, I can put some fertilizers over there, or maybe if my plants are suffering from a particular disease, suppose we may also capture the images automatically with the help of drones. And if we find that the crops are suffering from particular disease, we may also apply some kind of cure over there automatically. So these applications are possible with the help of IoTs.
Okay, sir. Thank you so much, sir. Sir, what would be the challenges when we are going to implement this technology in this agriculture field?
Yeah, challenge, like one of the challenge we have discussed in the purpose of this session was basically the security and privacy. In this, we basically talked about only security and privacy. But the other challenges are that the first aim of implementing any technology is to be cost effective. Unless and until the technology is cost effective, the benefit that we are going to achieve will be more than the cost we are going to spend. The technology will not become the practicality. Like when these mobile phones came earlier, they were very costly. People was not buying it. But nowadays, the cost of mobile phone has gone drastically down. That is why even a farmer is using it. So once the cost of this technology will be lower than the actual cost, then only it will become a practical.
Okay, sir. Thank you so much for the insight in this technology. Thank you, sir.
Thank you very much, sir. Thank you, Archana ma'am. Anybody else who
Thank
is
you,
having
ma'am.
any query?
Hello, sir. Am I audible?
Yes, sir.
Hello. Good afternoon, sir.
Good afternoon, sir.
Sir, I have a question. In this, the sensor is the essential component. Any specific types of sensors are used in the IoT?
Yeah, sir. There are number of sensors, sir. It depends upon the field in which you are using. Like suppose if we are talking about the smart vehicle, there may be thousands of sensors. Even our normal car which we are purchasing nowadays, it contains thousands of sensors, sir. One sensor maybe for suppose coolant management, one sensor is for automobile or this mobile management. Maybe even nowadays we are having the traction control mechanism that also is based on the sensors, because our vehicle is not delivering the equal power to all the 4 tires. Maybe it is a 2-wheel drive, 4-wheel drive. Everything is, sir, nowadays sensor control based now. This is for vehicle.
Multiple sensors can be used in IoT.
Yeah, definitely, sir.
Okay, thank you, sir.
Am I audible, sir?
Yeah, ma'am, you are audible.
Sir, you focus on through attacks on IoT environment. I just want to know about the malware attack. So what type of mechanism we can use to malware attacks in IoT environment?
Yeah, one of the mechanism we have discussed about to handle the malware, like we can have the dedicated antiviruses, like we have the dedicated operating system for IoTs, the dedicated antiviruses for these IoT systems. Those will be able to tackle these malware. But these, because nowadays new malwares are coming, once you will just do it with the help of a root, it will not help us. Once we integrate this machine learning with this IoT for identifying the malicious
Please mute yourself. Some background noise is there. Hello.
Yeah, ma'am.
Yes, but because of the resource constraint, is it possible to use antivirus on IoT devices?
Yeah, ma'am, I am saying you ki normal conventional antiviruses are not feasible here, but like as I said, ki for IoT devices we have the separate operating system, that is a kind of tiny operating system where we have some limited functionalities. Similarly, in case of this IoT devices, we expect the malware the anti-malware software should be of a tiny kind of thing that may be identifying these devices on some different kind of parameters. Full functionality is not required over here. And ma'am, in IoT, all the devices are not completely resource constrained. The actuators or the sensors, those who are at the field, they are resource constrained. But the devices, those are part of your edge network, fog network, cloud. There we can apply some complex security mechanism also.
Okay, sir. Thank you, sir.
Thank you very much, sir. Are there any queries, more queries?
Hello, sir. I'm Vinay.
Yes, sir, please.
Sir, can we apply these IoT technology on our security purpose, basically like fraud detections and other malware detection and other things?
Yeah, sir, actually, we cannot apply the IoT for fraud detection. Basically, for credit card, like I have shared one example of credit card fraud detection. There we are using the machine learning to detect the credit card fraud. Similarly, we can apply the machine learning to detect a particular node which is part of my IoT network for detection. But IoT cannot be straight away applied over there. IoT is generally used where you would like to have some machine-to-machine kind of interaction without human intervention. Like there is some device which is part of your network, it is performing some action. I want when a particular condition is met, this will send some information to the another node or the another part of your network, which is going to take some counter action in response to that event. We have discussed many of the applications also in this lecture.
Thank you, sir.
Sir, I have a question.
Yeah, ma'am, please.
Sir, good afternoon. I'm Devya Jain. Sir, I want to ask that is there any physical device is there in agriculture that is implemented and which is provided to farmer related to IoT? Is it implemented in anywhere in India or?
Ma'am, I think government of India is not exactly distributing such devices, but like there are various labs like CSIO, CSIR, they are working on these kinds of projects and they have very dedicated devices. Because the cost of these devices is quite higher at present, that is why it is not has become reality till date. But maybe in the coming years, you will find that these devices, those are available with the labs only till date, they will be purchased by the farmers also in the near future.
So thank you.
Thank you very much, sir. Any more queries?
Hello.
Yes, sir, please.
Good afternoon, ma'am. Good afternoon, sir.
Yes, sir, please.
Hello.
Yes, sir, please, you are audible. You can ask your question.
Yeah, okay. My question is, sir, how does the IoT only working in villages? And if IoT is working in villages, how we can improve the IoT in the villages?
Yeah, sir, we have discussed a few of the applications. I can discuss one more application with you. Like, sir, in Dharavi, in Mumbai, if you talk about the Mumbai, there is a one locality that is Dharavi, which is the most congested one. And there is a posh area near to that. But when you go for the electricity charges over there, you will find that the Dharavi, which is basically a kind of slump area, the electricity charges are higher. But in the posh area, the charges are lower. This is because there even the person, those who verify the electricity bills, even not able to enter. That is why they have increased the companies, they have increased the charges. But if suppose we are able to deploy some kind of sensors through which we are able to stop these electricity stealing, then we will be able to distribute the electricity properly. So ultimately, if we deploy some kind of automated things where even humans cannot go and just verify the things, we can do it with the help of drones or some automated sensors, and where human intervention is very less. So we will be able to reduce the charges of that particular services. This is one application, sir. Similarly, in villages also we can deploy these, like for garbage collection, sir. We have some municipal corporations, persons, those are coming. But suppose if we have automated it with the help of drones and sensors, it will be automatically connecting the garbage bin that is placed outside my house, and it will be delivered to the particular point. Then it will be done with this. And accordingly, human intervention will become, and this person who is supposed to perform the task on behalf of municipal parties, he may or may not be coming, I think 6-7 days in a week, maybe 2-3 days, less of the day they are not coming, but getting is this salary for the whole week. So such cost may be reduced with the help of these IoTs, sir.
Okay.
Thank you, sir. Any more queries?
Thank you, sir. It was a very informative session. Definitely all the participants probably enjoyed the session, and the things were very knowledgeable. Okay, now over to Vibha madam.
Okay, now with this, we are going to conclude this session, and now it's the time for the lunch break. We will resume here at 2:30 p.m. Enjoy the meal. Thank you.
Thank you, Rakesh sir. Definitely, thank you. We'll talk. Okay, sir. Thank you. Thank you.
Very long time, and it's been like proud for me to be a part of this Technocrats group previously. So it's like a integral part for myself as such, right?
Yes,
so
sir, definitely.
Maybe this Vibha ma'am or Nimade sir, or maybe Vikas Gupta sir, or maybe Shivraj or Divya Jain ma'am. So I can remember each and everyone. I cannot quote all the names, but I am connected with all of them, like very personally, not only with professionally, but personally also I'm very much connected. And especially thanks to like all the management of TIT group, that is Karsolia sir, Saurabh sir, Surbhi ma'am, and everyone, maybe Karsolia madam. So everyone is like, they are like part of my family as such, what I could say. So, but overall, over and above, let us come on to the theme of this particular IoT, what we can say, Atal FDP. So it is just a like a way to connect with our own institute, that is Technocrats Group. So initially,
welcome Abhishek sir.
Yeah.
Welcome Abhishek sir. I should also welcome you.
Thank you. It's always like working with you. It's like working with like my own counterpart as such, or like that. So let us come on to our topic itself. That is the topic for today. As far as for myself, it has been given. However, I am working in various domains, especially related to maybe it is image processing, signal processing. But nowadays, as like thrust area, the IoT is one of the thrust area for today's research as such, right? So even we are working with one of the core PG diploma in IoT and embedded programming at College of Engineering, Pune. It's a 4-trimester course that we have already running over there for industry personals. And me along with some of my faculties are teaching over there as the subjects for the PG diploma in IoT. Right. So, and we have good collaboration with industries as such, as like COEP is concerned. But now I'm going to start today's session. And so let us share my screen first. Right. So hope it is visible to everyone.
Yes, sir, it is visible.
Yes, sir.
Yes.
Great. So as far as like IoT is concerned, so as we are, all of us belongs to electronics. So in electronics, what we know is two different equations. What we call it, first, what we call it analysis equation, and second thing, what we call it synthesis equation. So every kind of what we can say, every implementation in electronics basically works with, like move around these two kind of equations only. So, but in case of an IoT, we are more towards what we call it on synthesis part rather than on analysis part, because analysis could be done by using various other techniques, what we can call them machine learning, or these kind of analysis that we can execute. But we are more on synthesis part as such, like we have to implement the whole product as an own. So this particular presentation is going to cover in 3 parts. Initially, we will go to introduction to cloud computing. Then we will work on idea about AWS, that is Amazon Web Services. And then thirdly, we will go to AWS IoT Core, and we will have some, what we can say, hands-on with some of the hardware, what we like, for example, over here, we have some ESP32 boards. So we can just start with this introduction to cloud computing. However, it is bit, what we can say, orthodox and kind of a presentation, because cloud computing is somewhat related with theoretical things as such more, rather than we can have some numerical concepts as such. But bear with me, we will have some good sharing of knowledge over here. So let us start with introduction to cloud computing. Okay. So actually, what is cloud computing as such? So we can define cloud computing as nothing but in general terms, we can define it like it is a new class of network-based computing that takes place over the internet, right? So ultimately, if I talk about cloud computing, then the first and foremost requirement for ourselves is nothing but the internet, right? So everything is being put somewhere into the cloud, that we can say, that is the database that we create somewhere in the cloud, and we are connected to the database through a link, through the what we can develop, that is what we call it internet, right? So if we are moving into the cloud computing, then we must be very good in the concepts related to what we can call it the networking concepts and how we create the various servers. Generally, we will call it DNS servers, domain name servers, right? But here we have what we call it virtual packet cloud, that is called VPC. So there are some terminologies that we will go into deep later on when we are going with the presentation forward, right? So basically a step on from utility computing, a collection group of integrated and networked hardware, software and internet infrastructure, right? So actually why we need this kind of things, what we call it the cloud computing, because ultimately a person need to control his devices from far-flung sources or far-flung areas, right? But nowadays, the main problem with this IoT devices are that we have a problem with the energy efficient protocols, right? So these need to be addressed, or the security, that is another issue. So later on, we have some other concepts as far as the IoT is concerned. The new developments are there, like some, for example, LoRa and all these kind of things are being devised, but they are not being the part of this particular presentation. So we are mainly focuses on AWS, IoT, and how the cloud computing works. Okay. So using the internet for communication and transport provides hardware, software, and networking services to clients, right? So that is what we can say, like we have to service our client, that is by providing him a control that can be controlled from a far areas. So these platforms hide the complexity and details to the underlying infrastructure from users and application by providing very simple graphical interface, what we call it API. So you are going to heard this particular word so many times. That's what we call it API. That is applications programming interface. So we must be very much thorough about this API. However, we will discuss it about in detail in later sections. So what is cloud computing? As the name stands, there's a cloud in which all the algorithms are going to be executed over there. So we can say a little amount of infrastructure that need to be deployed, and most of the calculations, most of the algorithm implementation will be done into the cloud. So ultimately it produces less amount of resources to be utilized as the, like what we can say, where we have implemented the IoT. So cloud computing is defined as storing and accessing data and computing services over the internet. So it doesn't store any data or any personal computer. It is the on-demand availability of computer services like servers, data storage, networking, database. Means whatever you demand, that will be provided by the cloud service provider, what we call it CSPs. Means that suppose that I want 9 CPUs with a particular amount of RAM, say for example, my demand is 32 GB RAM, that will be provided by the cloud service providers. Suppose that at any instant, suppose that like, for example, if we take an example of like I am hosting a website, right? And that particular website is having only say 50 to 100 users. So we don't need that kind of data or that kind of infrastructure that we will require if suppose my website is become very famous and it requires some more amount of resources. So what have to do if I have in-house premises? We have to purchase the servers, we have to install them, we have to provide more number of RAMs, we have to provide more number of CPUs in the in-premise. But in case of a cloud computing, it totally depends upon the requirement, and on-demand availability of services will be there. That's why it is much more cheaper. So it is the basic heart of what we can say cloud computing. So the main purpose of cloud computing is to give access to data centers to many users. So users can also access data from a remote server. There are some of the cloud service providers like AWS, Azure, and the Google, or what we can call it Amazon Web Services, that is provided by the Amazon. Then we have Azure, what we can say Microsoft Azure it is. And then we have Google Cloud Point, that's what we call it GCPs. So everyone have their own kind of cloud servers and they are providing it in their own ways, right? But the concept is same. However, the syntax is different. Like for example, here in Amazon, what we call it instance, but here in the Google, we will call it compute. And there are some differences between them. So in addition, the platform provides on-demand services that are always on, anywhere, anytime, at any place. So we have this pay-for-use facility and as needed. So the elastic scale up and down in capacity and functionalities. So we have this term that we have got over here, that what we call it elastic compute cloud. That's called EC2 as far as what we talk about like AWS, right? So we have elastic scale up and scale down. Scale up and scale down means over here, that is we can increase the number of CPUs, we can increase the number of RAM or the kind of infrastructure that we require. Suppose we will take an example of what we can call it Netflix. So what is actually Netflix is? Netflix is nothing but an app, and all the infrastructure, all the coding, all the data hosting is being provided by the Amazon itself. So Netflix has to do nothing, that only has to maintain his or her app, that is the Netflix that we use in our television or in mobile phones or whatsoever it is. So it is basically the responsibility of Amazon that is going to provide the infrastructure to the Netflix, and the Netflix is running on that particular AWS framework. The hardware and software services are available to the general public, enterprises, corporations, and business markets. So let's learn cloud computing basics with an example. So here I have taken this particular example so that we can understand, we can develop our connection with cloud computing as such. So suppose that you are traveling in a bus or a train, you take a ticket for a destination and hold back on your seat till you reach your destination. Likewise, other passengers also take their tickets and travel on the same bus as you, and it hardly bothers you where they go. Means you are concerning with your destination only, none other than that. So when you stop, when your stop comes, you get off the bus, thanking the driver. It's just a gesture so as to say thanks. So cloud computing is just like that, bus carrying data and information for different users and allowed to use its services with minimal cost. Right? So we are just a passenger in that cloud, nothing else. However, there are other services which are being offered to the other users also. So here we can have a description over here. What we can say, cloud computing is an umbrella term used to refer to internet-based development and services. So we can say we have these applications that have been developed into the cloud that are being used the services, and then we have some storage database, and then we have the servers, and we have a network. So a number of characteristics define cloud data, application services, and infrastructure. So the three main things that we can define our cloud, that is remotely hosted, ubiquitous, and the commodified. So remotely hosted means services on data are hosted on remote infrastructure. Ubiquitous means services or data are available from anywhere, means I can access my data by sitting in India, by sitting in Dubai, by sitting in US, or maybe anywhere. So I can use or I can access my data from anywhere else in the world. And the commodified. What does this commodified means? The result is a utility computing model similar to that of traditional utilities like gas and electricity. You pay for what you actually want or what you have used. So why the name cloud? So we can have these end users over there, and we have service provider over there. So we can have two ends. One is called end user, and other is what we can call it service provider. And in between of that, there is an internet connection, and through which the cloud is going to be operated. So the term cloud came from a network design that was used by network engineers to represent the locations of various network devices and their interconnections. Means that I have my, what we can say, my thermal sensor, or what I can say, my humidity sensor, or maybe my gyroscope, or maybe my ultrasonic sensor that has been deployed at my location, and I can use that data in order to manipulate it and in order to control the various other devices in order to control the equipment. Suppose that I have a polyhouse, right? And I have deployed some sensors over there at polyhouse, and I want to control the polyhouse water irrigation through the far areas. Recently, I have got a project, one of the person from Dubai, that he has their farmlands in somewhere near Solapur, and he want to control their farmland at Solapur from Dubai itself. So we are deploying that IoT networks over there so that he has a control of his farms and all the details related to his farms when he's sitting at the Dubai itself. So that is what we can do with the kind of IoT and the cloud. So why cloud computing? So as we already understand, it is economical, less infra requires, user-friendly and efficient. And let's take an example. So the example that is being given, like for example, in an in-house IT server, you have to pay a lot of attention and ensure that there are no flaws into the system so that it runs smoothly. And in case of any technical glitch, you are completely responsible. So it will seek a lot of attention, time and money for repair. Whereas in cloud computing, the service provider takes the complete responsibility of the complications and the technical faults. As we have already discussed about the example that we have taken, that is of Netflix. So ultimately, everything will be taken care by the cloud service provider, what we call it CSPs. But again, there are a category of services. So there are various kind of services that can be offered by the cloud companies. So there are 4 different cloud models that you can subscribe to according to the business needs. So following are the different type of cloud models, that is private, community cloud, public cloud, and the hybrid cloud. So let us take a definition about all these kind of cloud systems. The private cloud, it is nothing but a group of persons or deployed for one particular organization. Then we have community cloud. Here computing resources are provided by community and the organizations, or maybe shared between the organization. Public cloud is like an open cloud. Like for example, nowadays we are taking about what we can say CoWIN app. So CoWIN app is nothing but what we can call it public cloud. So you just send a number to a particular destination, to a mobile number. You can send your number, and the basis of your number, it is going to fetch your vaccination details from the database that has been created by the government. So it is like a public cloud. So using a services created by a particular company. So this is the type of cloud which is being used usually for B2C, that is business to consumer type interactions. Here the computing resources owned, governed, and operated by government, an academic or the business organization. Suppose that I want to create a question paper, and suppose that my 60 student of the class used to access the same data. So I can create my private public cloud. It is being used by all the students who have been registered with that particular cloud service. Like nowadays, at COAP, we are using what we call it, that is maybe like, for example, if we take the example of this Zoom meeting. So this Zoom meeting is what? It's nothing but an example for a cloud services. Hybrid cloud, this type of cloud can be used for both type of interactions, that is B2B, that is business to business or business to consumer. So this deployment method is called hybrid cloud, as the computing resources are bound together by different clouds. So this is what we have, different kind of cloud models. So till now, what we have covered the type of what is cloud computing, why it has been used, and what are the different kind of cloud models. Now, the benefits of cloud. So we have different benefits of the cloud that we can understand, like from here. It is lower IT infrastructure, improved performance, fewer maintenance, instant software updates, improved compatibility between operating systems, backup and recovery, performance and scalability, increased storage capacity, then increased data safety. So these are some of the advantages of using cloud. So we can have this cloud computing characteristics. So we can categorize them, or the common characteristics are something like this. That is massive scale, homogeneity, virtualization, low-cost software, advanced security, service orientation, geographical distribution, resilient computing. What are the essential characteristics that my cloud must have? So it can have an on-demand self-service, broad network access, then we have resource pooling, then rapid elasticity, and the major services. However, these are the terms that we need to elaborate, but if the time permits, we will go deep into the terms, but here I am just leaving these terms as such. So application on thrust area for cloud. So there are some of the application where actually we can use the cloud. That's for healthcare. We can use it for education. Like for example, healthcare, recent in the COVID time, suppose that I want to create an app that will shows the vacant position of the beds at different hospitals. So we can use that particular cloud service as far as the healthcare is concerned. And nowadays, this cloud technology has become very much famous, as we can interact with a pool of doctors without actually visiting to the doctor, by just sharing our, what we can say, our reports to the group of doctors, right? So what we can say nowadays, a new term is going to be originated, what we call it medical tourism. So this medical tourism is nothing but going to provide the cost-effective services to the patients for various different kind of diseases. Now, education, the cloud computing is also useful in educational institutions for distance learning. It offers various services, like for example, we have the various kind of platforms, like whether it is Udemy or Coursera or maybe whatever it is. So they are using the same, maybe NPTEL. So we are using this cloud computing or the cloud resources in order to utilize this education as a whole. Now, government. So like, for example, the US military and government were early adopters of cloud computing. So anything which has been developed, it has been developed for, initially it has been developed for the US military. So this cloud incorporates social, mobile, and analytic technologies, although they must adhere to strict compliance and security measures. Means there are some restrictions out of there which they must have to follow. Now, big data analytics, again, they can be used for the big data analytics, communication. So cloud computing provide network-based access to communication tools like emails, like for example, Gmail that we are using. Gmail is also nothing but an application for the cloud, because we are just putting our data onto the cloud, but we don't know where actually it is going to be stored, right? Maybe the Google is having different servers, maybe situated at India, maybe at US, maybe at Singapore, different at different location. But again, the concept that being used, that is of the latency. So latency is the thing that we have to need to consider when you're going to store the data somewhere into the cloud, and companies are also looking after this particular thing. Some others are precision agriculture, air traffic control, ERP management, electronic warfare, defense system. So this is the all applications areas related to the cloud computing, where actually the cloud computing can be used. Now again, business process, Facebook, Dropbox, and Gmail. So these are some of the application areas where actually the cloud computing are using nowadays. Whereas citizen services. So here are the, so we have seen the big picture of cloud computing, that how it is being useful for the modern day life. Now, we have to differentiate it with the previously used terms, what we call it. Nowadays, actually, there are so many terms that comes nowadays. Maybe it is called grid computing or edge computing or fog computing or the utility computing. And we also have the cloud computing. So we need to differentiate among these terms, that how actually cloud computing is differentiate from all these terms. Then only we can focus on our area. That is what we have, this cloud computing, and especially how it can be utilized for IoT platforms. So what is grid computing? So it's like a computing grid is compared to electricity grid, where it is passed through a network to provide its services. So as you can see from here, we have a power station through which the power is going to be delivered to transformers. Then it is going to 132 kV substation. Then it is going to industry or the town or the villages or to the farms. Means that we have made a cluster of the resources and then they have been distributed to among other, like what we can say, nodes or the service users. So we have a grid of the, what we can say, servers or the infrastructure, and it has been distributed through the Ethernet to the different clients or the servers. So when we switch on the fan, this is an example. So when we switch on the fan or any electric device, we are less concerned about the power supply from where it comes and how it is generated. The power supply or electricity that we receive at our home travels through a chain of networks, which includes power stations, transformers, power line, and the transmission stations. So this is how we actually can call it, like I'm getting the power from the power grid. Recently, I'm just studying that concept of one of the person, I just forget the name. It has been mentioned that like maybe it is like creating a common grid, one grid for one world. Means that there is a research showing that there is a sun which is nowhere going to be set. Like sometime the sun is there and on one side of the earth, and sometime the sun will be on the other side of the earth. So can we create a grid that has been all connected around the world, so we can utilize the energy of the sun 24 hours, so we can create it, that kind of concept, so that we can use it as a non-conventional source of energy, so that more and more power can be extracted from the sunlight, and as it can be utilized in order to run our various appliances and the industries. So this is what we can do. So we can utilize the energy of the sun by following its path. So that is the way like the next 20, 30, 40 years, the people are working on that kind of resources of energy. But it's again a concept. So grid computing is a middleware to coordinate disparate IT resources across a network, allowing them to function as a whole. It is more often used in scientific research and universities for educational purposes. Like for example, if suppose a group of architect students working on a different projects require a specific designing tool and software for designing purposes, but only a couple of them got access to the designing tool. The problem is how they can make this tool available or the rest of the students. To make it available for other students, they will put this designing tool on the campus network. Like for example, if we have working with the MATLAB, so MATLAB comes with two editions. One is what we call it a standalone edition. One is called server edition. So we can put that MATLAB onto some server in our computer lab, and everybody is going to use that particular server or that particular MATLAB in order to solve his or her problem by setting his own her own standalone machine. So to make it available from other students, they will put this designing tool on the campus network, and now the grid will connect all these computers on the campus network and allow a student to use the designing tool required for their project from anywhere. So cloud computing and grid computing is often confusing. So their functions are almost similar. Their approach for their functionality is different. Let's see how they operate. So there is a difference between cloud and the grid computing. So cloud computing works more on a service provider for utilizing computer resources, whereas grid computing uses the available resources and interconnected computer systems to accomplish a common goal. Cloud computing is a centralized model, right? So grid computing is a decentralized model where the computation could occur over many administrative models. So cloud is a collection of computers usually owned by a single party, whereas a grid is a collection of computers that is owned by a multiple parties. As like I have said, I can situate the grid all along the earth that will be owned by different countries, but however, the energy is being going to be what we can say utilized in a distributed way. So it is like what we can say, it is a distributed kind of platform. So cloud offers more services, almost all the services like web hosting, DB, that is database, support, and much more, whereas grid provides limited services. So cloud computing is typically provided within a single organization, that is Amazon, whereas grid computing federates the resources located within different organizations. So here we get to know how the cloud computing is different from grid computing. Now we comes on the utility computing. So utility computing is a process of providing services through an on-demand pay-per-use billing method. The customer or client has access to a virtually unlimited supply of computing solutions over a virtual private network or over the internet. So which can be sourced and used whenever it's required. So based on the concept of utility computing, grid computing, cloud computing, and managed IT services are based. So there's a difference between how the cloud computing is different from the utility computing. So utility computing refers to the ability to charge the offered services and charge customers for exact uses. Whereas cloud computing also works like utility computing. You pay only for what you use, but cloud computing might be cheaper. As such, cloud-based app can be up and running in days or weeks, right? So as soon as you can use or you can release the CPUs or the RAMs, you will not be charged. So when we go to the AWS, that is Amazon Web Services, we will find out the billing option over there that will be charged on hourly basis, that for how many hours you are using, how much of RAM and how much of the CPUs. So it's a whole new world that is going to be opened for various kind of researchers, that how they want to utilize that cloud computing that's been provided by Amazon or any other companies in order to implement their research as such. So utility computing users want to be in control of the geographical location of the infrastructure, but however, in the cloud computing, its provider is in complete control of cloud computing services and the infrastructure. Utility computing is more favorable when performance and selection infrastructure is critical, whereas cloud computing is great and easy to use when the selection infrastructure and performance is not critical. Whereas utility computing is a good choice for less resource demanding, whereas cloud computing is good choice for the high resource demanding. So when we will go to AWS, let me open this AWS console so that you will get into it with a deeper understanding. So this is my AWS console as such, so you can have a look. So maybe my screen is visible to everyone, I think.
Yes, sir.
Great. So we have this AWS console, which is being visible over here. So we can have this AWS console and you can get these different kind of services as well as the different kind of pricing. If you go to over here, so we can get a pricing about AWS and various solutions that it provides. That is the various kind of facilities that it provides, as well as the products. Like for example, if I will go to like, say for example, if I will go to one of the basic example, like maybe it is blockchain, maybe it is like container services, database, developer tools. There are various services that can be applied. Like for example, if you are really, what you can say, if you are enthusiastic, or what we can say, you're enthusiastic as far as like image processing is concerned. So AWS has its own console, what we call it AWS Rekognition. So it is again what we can say AWS Rekognition AI. It's not like this. So it is Amazon Rekognition. So it simply provide various machine learning algorithm that can be involved with various kind of what we can say building ML models and infrastructure from scratch, especially for image and video processing. So it can easily analyze your image and video processing kind of models related to ML and the AI. So Amazon Rekognition offers pre-trained and customizable computer vision capabilities to extract information and insights from images and videos. So again, like it is not our duty to make the model to be built. It has its own pre-trained model, or initially what we call it transfer learning approaches when we talk about various Python libraries as such. So we can have these kind of models available with Amazon. So if I go to Amazon, so what you have to do with this, you have to create your own account. So maybe I'm taking it from scratch so that everybody could get to know that how this particular things could be done. So initially I have to create my account. However, I have already created my account with Amazon. So it is like we have this sign into the console. So you can just sign in over here. And if suppose you don't have any account, you can create a free account with the Amazon for 12 months. I have already created that. So I can use this as a root user. So I can create this, just make a login over here and just put some captcha over there, like E87WXH. You can submit it over here. Now it is
Sir, your AWS screen is not visible.
Okay, it's not visible.
Yeah.
Just hold on. Is it visible now?
Yes, sir.
Okay. So as you can see, we have this AWS screen. Let me open it from start. So you have to go for AWS console. So you can search in Google and just open this AWS console over here. And as we are talking about AWS recognition, so you can just search it over here, AWS recognition. This is my AWS recognition, actually where I am working. So this is my AWS recognition. Do it visible for everyone. Is it visible for everyone?
Sir, yes, sir, yes, sir.
Okay, great. So this is my AWS recognition where I can do various kind of machine learning approaches that can be applied to various computer vision capabilities. It has various pre-trained models that can be utilized in association with your data set, that is image and the video data set. But we are not going over here. We're just focusing over here only. So you can create your AWS account for a 12-month free tier account. However, it is having with some sort of limitations. Okay. So it is having with some sort of limitations, but again, it is very useful as far as the initial understanding of the AWS. So the screen is visible for the sign in?
Yes, sir.
Okay, great. So let me sign in from here. I just put on some captcha over here. So it's YTFT23. I just submitted. Let me have to input my password. Let me enter this password. So can you ask me an MFA code? What is this MFA code is as such? Actually, I have secured my account or I have secured my AWS account with an authenticator, what we call it Google Authenticator. Right? So you can search over here, that is Google Authenticator over there. You can easily download it on what you can say, your Play Store. That is Google Authenticator. So this is my Google Authenticator, what I have downloaded on my mobile phone as a from Play Store. So I got a code from here and I can enter this particular code on the Amazon Web Services. So say for example, my code is that I have received. So every time when I log in, the code will change and I have to separate a new code. So no one can use my AWS account as such or cannot like enter into my AWS account if just by getting this particular password, right? So I can have the different services into the AWS console itself, right? So you can go to services. So you can have these kind of services, or I can go from here. I can have this all services that I can have with the AWS, that is Amazon Web Services. Like for EC2, that is Lightsail, then Lambda, Batch, Elastic Beanstalk. There are various services that are being associated with the Amazon that are being dedicated for different kind of applications. However, there are some basic needs or the basic applications that we can use with various kind of like users, like for example, S3 or the EFS, and we can use this RDS, DynamoDB. So these are some of the services that we use with each and every applications. However, when we move on, like when we progress through this particular AWS IoT, we are mainly focusing on this IoT core that is given at the end, that is Internet of Things, that is IoT core that is being given over here. However, I can use this AWS IoT with various kind of applications, as you can see from here. Right. So this is how the AWS works. So we have to do nothing, but we have to know how we can interface our IoT device. That is, maybe it is ESP32 or maybe Arduino microcontroller or maybe Raspberry Pi or whatever it is kind of the device is there. We get to know that how we can interface that particular devices with the AWS using some certifications and what we can say policies. So that we will discuss later when we go to AWS IoT core. Now we will again come back to presentation as such. Right. So here we get to know that how the AWS is going to work. So we are mainly focusing on AWS. However, we are having this background of the cloud computing as well as we must have the background of the IoT. So in a short summary, what we have, cloud computing is defined as storing and accessing data and computing services over the internet. Means that internet is the main thing, or internet is the main, what we can say, integral part that we require in order to connect my cloud to the, what we can say, IoT device, so that it can be, data can be uploaded, or maybe here what we can call it publish and the subscribe, right? So here we don't use the term send and the receive. Here we use the term publish and the subscribe as far as the AWS IoT core is concerned. So cloud computing is defined as storing and accessing data and computing services over the internet. The term cloud came from a network design used by network engineers to represent the location of various network devices and their interconnections. Today, many large and small scale businesses thrive on their data, and they spend a huge amount of money to maintain this data, right? So cloud computing architecture helps organizations to lower their IT infrastructure and computer cost per user. So ultimately, if suppose I want to start my company, that's why now you can see there are lots of startup coming into the market, because there is not so much infrastructure requirement as such, right? They can use these cloud services, just devise this. We are going to more focus on what the services that they are going to offer, right? Like for example, if you take the example of the CoWIN app, right? So it's a kind of service that has been offered through the cloud, right? So we can more focus on the service that we can provide, and rest of the things will be done by the cloud. So suppose that I want to start a company, and I want at least, like if we talk about the previous times, we have to start the company or a startup, we need a time frame of around 6 to 8 months. But now the same company can be started in hours, like 3 to 4 hours that I needed in order to configure my cloud services. And I just put my app somewhere onto the Play Store, and I can live my data and I can live my app globally in few hours. So that is what we can have with the technology as such, cloud computing itself. Now, type of clouds that we have understand: private, community, public, and the hybrid. So important cloud computing services. So in the next session or in the next upcoming slides, we are going to discuss about kind of services, that is software as a service, platform as a service, and the infrastructure as a service. Now the grid computing, we have taken this point, that is grid computing, utility computing. So how they are going to differ from the cloud computing that we have understand, and what is the barrier? Again, every technology has some sort of limitations. So what is the limitation with this cloud computing? The major limitation with the cloud computing is the privacy, and which is, or what we can call it, security. Like for example, nowadays IBM is also coming into the cloud domain. Initially they have Bluemix, then we come on Watson, and later on they are having their IBM cloud. So again, every other company is coming into the cloud services because we can see a lot of potential as far as the cloud computing is concerned. So what is cloud computing architecture? So we have understand the various background related to the cloud. Now we comes on to the architecture, the how we can deploy or how we can create the model using the cloud computing. So architecture is a combination of components required for a cloud computing service. So ultimately we have to deploy our service, right? What our end goal? Our end goal is to deploy our service by using the cloud infrastructure, or what we can say cloud computing architecture. So a cloud computing architecture consists of several components, like a front-end platform, a back-end platform or servers, a network or internet service, and a cloud-based delivery service. The front-end, as you understand, front-end is always nothing but a client. Like as far as the person who is sitting in Dubai, who wants to look after their farmland at the Kolhapur. So my client is nothing but my front end, those who are going to use the services that I'm going to deploy using the cloud. So it comprises interface and application that are required to access the cloud computing platform. Means that I'm creating an API to my client so that it can use to control the various and can access the data, maybe for a moisture sensor, maybe for a temperature sensor, maybe for any other sensor, that it can utilize this particular data in order to control the various other appliances. Maybe it want to run the motor, or maybe it want to run a pump, or whatsoever it is. So it can utilize that particular data in order to control that particular devices using this cloud programming platform. So now this is my front end. So what is my back end? My backend refers to the cloud itself. It comprises the resources required for cloud computing services. It consists of virtual machines, what we can call it nowadays VMs, right? For the company working in this particular domain, what we call it VMware. So VMware is the company which is actually working with this cloud domain from so many times, and they are very good in providing such virtual machines in order to facilitate various cloud computing professionals. Then servers, data storage, security mechanism, etc. So it under the provider's control. So whatever the cloud service provider company, maybe it is Amazon or maybe Microsoft or maybe Google, whatever it is the company, if it is providing some services, so I am utilizing their resources or their servers. As you can see, if I go to my AWS console, so as you can see, presently I am using this North Virginia or the US East, right? So if suppose I am going to my various kind of, maybe I can have this, if I make the, what we can say, sign out, let me, if I go to my documentation and where it is, AWS Marketplace. So where it is, let me open that support centers. Let me open this AWS. Yeah. So do my screen is visible of AWS? AWS free
No,
tier?
sir. No, sir.
Okay. Okay. Just new share. Let me go to this screen. Share. Is it visible?
Yeah.
Yes, sir, it is visible.
Okay, great. So actually we can provide these different kind of services using the AWS. However, I'm using this as such like free tier details. So in this free tier details, I'm having these kind of facilities that is being available with the Amazon. So as you can see, like for example, I can use this AWS management console. Again, I have to log in. No, I don't want to log in as such. So let me see AWS. Global infrastructure. Okay. So as you can see, AWS has a global infrastructure. As you can, like, we can go to this 26 launched regions. So we have various regions, 84 availability zones, and we can go to its list. Where is that list? Okay, the regions and the AZs, right? So you can see, let me open it, regions. In South America, then Europe, Asia, what is the list? Where is actually list? Availability zones, AWS local zones. It's not there. Yeah. Okay. So as you can see, the AWS is being deployed at various availability zones, like as you can see, US East, US West, then government cloud is there, again US West, then US West East, then Canada and government cloud regions. Suppose that as I'm just sitting in Mumbai, so it basically comes under the Asia Pacific region. So in the Asia Pacific region, we have, these are the regions, whereas these are what we call it edge locations. So we'll discuss about these two terms later, but as you can see, we have the servers or the, what we can say, regions at various locations, like for example, mainland China, then over here, Singapore, maybe in Tokyo, Seoul, Sydney, Mumbai. So in Mumbai also, there's an, what we can say, the AWS region. Suppose that I'm deploying a server, deploying a service for specifically for the Indians. So we can use this particular region, or we can use this particular server that is from Asia Pacific. So in order to reduce the latency, right? Suppose that I want to deploy a service for the Indians, but I'm using a server from the US. So again, it has to extract the data or fetch the data from the server situated at the US. So again, it takes too much of time in order to extract the data, or maybe the website taking too much of time to load. So again, there's the issue that comes with the latency. So again, it depends upon the what kind of where actually we are going to deploy the service, right? So we are using that kind of servers. One thing. Second thing is that mostly most of the services or various services could not be available at one location or one region. So if suppose I want to use a particular specific service, so it depends upon that in which particular server or at which particular region that particular service is being available. Like for example, if suppose I'm using a service, what we call is RTOS. So RTOS may be not available at my Asia Pacific region, but it is being available at US or maybe my US East or US West or whatsoever it is. Like for example, we have different regions that has been deployed, that is US East. So maybe it's called Northern Virginia. So I can use the servers from here only. However, for the inception, it has been inception in 2006. So in 2006, the AWS has been deployed over there. So this is what we have with the different region. Means what we can say, we have this, what we can say, redundancy of the data. Like suppose that one of the server is not going to be respond, maybe the load has been distributed to another server. So in order to maintain that particular website to be up at various amount of times. Okay, so we have this architecture that can be defined. So we have two ends, that is a front end and the back end. So back end that has to be designed at the particular server location or the region that we have decided, or it has been given by the AWS. So cloud computing is a strong distributed environment. It distributes the file system that spreads over multiple hard disks and the machines. Means the same website can be hosted by a server situated at Asia Pacific, and the same website is being hosted at the server situated at what we can say US East. Means that we have a load balancing. Means if suppose that load is going to be increases onto the website, then there will be a balanced kind of concept that can be applied to the servers, so that a single server could not have that kind of load, so that it gets failed. So data is never stored in one place, and in case one unit fails, the other will take over automatically. I mean, what we call it, elastic load balancers, right? So architecture of cloud computing contains many different components. It includes client infrastructure, applications, services, runtime clouds, storage spaces, management, and security. So these are all the parts of a cloud computing architecture. So front end and the back end for cloud architecture. So if we talk about in terms of IoT, so we have a client infrastructure that has been deployed at the front end, whereas at the back end, we have some database. So ultimately, we have an application that has to be given to the client, and behind of that, we have the servers, or what we can say service, because ultimately the word service that comes out from the term, what we call it server. So every service is going to be run in a server and into the cloud. Right? Because why we are taking the cloud as a term? Because we don't know where actually the server is being installed. Whether it is being situated at Mumbai, maybe whether it is being situated at Singapore, whether it is being situated at Tokyo. So means that we don't know where actually what it could be the physical location of the server is, but we are accessing that data. Like for example, Gmail. If suppose I'm going to mail an attachment to an end user, we don't know from actually where's the location that particular attachment is going to be saved into the cloud. But we have that particular drive associated with us, so we can access the data without actually knowing its physical location. So we have runtime cloud, then we have storage, and what we can call it, that is the infrastructure, means the network and some sort of things that will be provided over here. So we have front end and the back end. So the front end, the client uses the front end, which contains a client-side interface and application. Both of these components are important to access the cloud computing platform. The front end includes web servers, clients, and the mobile services. And the backend part helps you manage all the resources needed to provide cloud computing services. This cloud architecture part includes a security mechanism, a large amount of data storage, servers, virtual machines, traffic control mechanism, etc. So it means that we can deploy any kind of model by just knowing its framework, nothing else. We need not be taken care about the hardware configuration. We need not be taken care about what could be the load that is going to be executed over there. It is going to manage the load, depends upon the requirement of the traffic that is coming from our website. What we have to maintain, nothing but a domain, that is what we can use, that is like HTTP or HTTPS, that we have to maintain only, nothing else, right? So this is what we can have with the cloud service. So important components of cloud computing architecture. So we have a client infrastructure, what we can call it a GUI. Then we have an application. So the application can be any software or platform where the client wants to access. Then services. Now our main heart of the cloud computing comes, that is the services that we can deploy. So there are three main cloud computing services, that is software as a service, platform as a service, and the infrastructure as a service. Then runtime cloud. So runtime cloud offers the execution and runtime environment to virtual machines, because ultimately we are going to create some virtual machines. Why they're called virtual machines? Because we are creating that kind of machines over there into the cloud, which are virtually being available to the user, right? Storage is another important cloud computing architecture component. It provides a large amount of storage capacity in the cloud to store and manage data. Then we have infrastructure. It offers services at the host level and application level. So cloud infrastructure includes hardware and software components like servers, storage, network devices, virtualization software, and various other storage resources that are needed to support the cloud computing model. Then we have management, security, and the internet, right? So it's like 3:30. So I'm going to finish it in next 10-20 minutes, because we have to move on to AWS IoT Core in order to get to know that how this IoT could be applied as far as the AWS is concerned, because maybe the number of slides are like, how many? 76. So we have to finish it a bit early. So I'm just skipping some of the part. However, I will share these slides with the Vikas sir. So if suppose all of you want that, you can get these particular slides, right? So goals with designing cloud service architecture. So make the overall cloud computing system simpler, easy to enhance to data processing, provide high security, disaster recovery, and accessibility. So significantly reduces IT operation cost. So main issues with the computing world today. So we have the servers and infrastructure cost increasing day by day. So these are some of the concepts that we can use. Now the solution to such issues is virtualization, right? So virtualization, it has many benefits, but not enough. So what actually virtualization is? It is nothing but process of creating a virtual versions of an operating system, a server, or network resources. Here we have to need to understand the concept of containers also, right? But again, the time is not going to permit me to elaborate all these kind of terms, but if suppose the time left it out, we will go into deep of that. Now using virtualization, you can host multiple operating systems at the same time on a single machine. So virtualized servers, what we call is hypervisors again. So using virtualization, that cut cost for hardware acquisition, maintenance, energy, and cooling system uses. So this is all about the virtualization, right? So virtualization is nothing but like virtual workspaces that we can provide. So it can accommodate different kind of OS, different kind of resource quota, and what we can say the CPU and the memory uses. So as you can see, we have the virtualized stack where we have hardware and we have hypervisor, and it is going to define different kind of OS and the applications that could be run on different kind of virtual machines. So abstract of a physical host machine, that nothing but the hypervisor interacts with and emulates instructions from virtual machines and allow management of VMs. So some of the companies like VMware, Zen, etc. So it is nothing but my virtualization technologies or virtual machines that we can use. So we have this virtualization and the cloud computing. So it's nothing but partitioning of a single physical servers into multiple logical servers, right? So instead of using your PC for storage and computation, you can use their virtual servers. They are fast, cost-effective, and less time-consuming. So this is what about virtualization. And in a particular, in cloud computing, we have three different types of virtualization: network virtualization, server virtualization, and the storage virtualization. So again, I'm not going to cover this. Let us go on to short summary. So we can have this architecture as a combination of components. So what are these components? Front end, back end, and the various components that are being used. So these components are client infrastructure, application service, runtime cloud, storage, infrastructure, management, security, and the internet. So these are nothing but my part of this cloud system deployment. So goal of cloud computing architecture is to make a complete cloud computing system simpler. And the heart of that, it's nothing but the virtualization. So some of the companies that have been using this cloud computing as a resource generation. So this is Kamatera, and then again we have server space. So I'm just skipping all this. I'm not going to detail. Then Linode, then Amazon Web Services. So again, everything has their own features that are being deployed. So based upon the feature, we can use a particular service. Then Scala hosting. So then Cloudways, then OVH Cloud, then Microsoft Azure, then Google Cloud Platform, Salesforce, So these are some other cloud platforms that can be used. So these are the companies actually those who are using these cloud platforms, right? So however, out of this, some of the major companies that are using like Amazon, Google, Microsoft, and the Salesforce. So working models for cloud. So again, their working models are two types. That is basically deployment model and the service models. So deployment models define the type of access to the cloud. That is how the cloud is being located. That is public, private, hybrid, the community. We have already understand that. Now we comes on to the service models. That is the infrastructure as a service, platform as a service, and the software as a service. So however, there are other types of services also like SaaS, which is nothing but what we call it everything as a service. It's a concept of software computation across the network. So it is a subsection of the cloud computing. However, we have most common types of our infrastructure, then platform, and the software as a service. Whereas other services are what we call it data as a service, network as a service, and the communication as a service. So again, we have different kind of services that can utilize different kind of architecture. So again, as we understand, we have already studied different kind of network architecture like TCP/IP or the OSI models. So we can relate these services as far as various kind of cloud services to the models. Like for example, if we take an infrastructure as a service, so as the name understand, what we can have infrastructure. So infrastructure basically consists of the servers and the storage, means the hardware that we will provide to the system that will comes under the infrastructure as a service. So if suppose any of the company needs some hardware to be utilized, that is comes under the category what we call it infrastructure as a service. But when we call it platform as a service, so we are providing the operating system and the development tools and the database management also, that comes under the platform as a service. And when we are going to make it hosted application also, that is comes under the category what we call it software as a service, right? So we can have this SaaS, PaaS, and IaaS. So we can have this various kind of infrastructure or the cloud service models. So again, here you can understand what kind of different models. So this is my traditional IT service, right? So we have to develop everything in premise. Maybe it is networking, maybe it is storage or the servers or the virtualization, operating system, middleware, runtime, data, and the application. So this is my traditional IT infrastructure or my traditional IT uses that we have utilized previously. But with the advent of the cloud, we have these kind of infrastructure, that is the infrastructure as a service, platform as a service, and software as a service. So as you can understand, we can deliver all the components in software as a service. So it is the most costly affair if we talk about all these three, that is the infrastructure, platform, and the software. So we can have infrastructure as a service. So these are some of the best IaaS providers of 2019. That is IBM Cloud, Microsoft Azure, Amazon, and the Google Cloud Platform. Platform as a service. So you can see this is my AWS Lambda, Salesforce Platform, and the Morpheus. These are nothing but my top PaaS providers, and the SaaS providers are nothing but like this. That is Salesforce, Office 365, Google Apps, and the BuyBox. So these are nothing but what we can say. These are the companies which are using software as a service. Now NAS, DaaS, and CAS. So these are also nothing but a type of different kind of services. I'm not going in details. You can understand that. So now the characteristic of the cloud computing. So these are some of the characteristics that we can enumerate. One is on-demand self-service. So it can easily understand by the term. So as far as like the demand is going to be increases, the utilized resources are going to be increased or the decrease, means the scalability. Then resource pooling. So we can have, like as we have seen the example of the bus. So we can have the pool of the resources, elasticity, scale up and down, then broad network access. We can access our network sitting anywhere in the world. Then we have the measured services, depend upon the requirement, costing will be done. Pay as you go. So the resources that you use, you have to pay for that only. And the availability. So never your website or your front end or maybe your services will never goes down because there is some so-called what we call it balancers will be there. Then we have virtualization, virtual workspaces. So again, it is like virtual machines. So implementation of virtual machines. So this is an abstraction of a physical host machine. Hypervisor interacts and emulates instructions from VMs and allowed management of VMs, Xen, etc. It provides infrastructure API plug into the hardware and support structures. So again, advantage of some of the virtual machines. So you can get over here. So what is the purpose and benefits? So these are some purpose and benefits. However, we have already understand that. Then cloud computing. So why it's become a big deal? So using high scale, low cost providers, anytime, place access via web browsers, rapid scalability, incremental cost and load sharing, can forget need to focus on local IT, concerns and the performance. So what are the various concerns where actually research could be inculcate, that is reliability and the SLA, then control of data, then application features, interaction between cloud providers, no standard API mix or SOAP and REST API. So these are something but the challenges that we can consider as far as like the cloud is concerned. Then there are some opportunities over there. So what are the benefits that we have already gone through? The cost saving, scalability, flexibility, reliability, maintenance, and the mobile accessible. So again, we have this advantage of cloud computing. So store data that can be lost, and store data might not be secure. These are some of the disadvantages. The future of like cloud computing is like many of the activities loosely grouped together under cloud computing have already been happening, and centralized computing activity is not a new phenomena. So cloud computing was the last research-led centralized approach. So many new open source system appearing that you can install and run on your local clusters should be able to run a variety of applications on these systems. This is what about the future of the cloud computing is. Again, I would like to thank all the eminent researchers, faculties, scholars whose data has been incorporated in the above slides. And these are some of the references that I have been using in order to give you a detailed introduction about the cloud. So that is being ended over here. So let us go on to our next part, that is the AWS IoT Core. Okay. So how many PPTs are there? Again, there are 83. So again, we have to run a bit fast, right? Or maybe I will try to cover the things in a bit of understanding way so that we can cover these things a bit faster, right? So how much time is there? It's like 3:38. Okay, we have enough time. So Vikas sir, could we spare some more time after 4:30?
As you wish.
Okay, thank you.
We are having our college time up to 5 o'clock, but then also it is okay if the things are feasible, we can go.
Yeah.
Right?
Okay. Thank you. I will try my best. I will try to finish it before 4:30.
Okay, sir.
Okay. Right. So we are going to introduce then AWS IoT Core. So we have already gone through AWS, what is Amazon Web Services. We already know through various previous lectures that has been delivered by Kulkarni sir or maybe some other faculties. So you have already got into IoT, what actually IoT is. So I'm not going deep into IoT as such. So I am going into the application part for the AWS IoT Core. So what is that? Our goal for this particular presentation is like establish communication with the IoT sensor. So means whatever the sensor that we have deployed, we have to establish communication with these IoT sensors. Collect and transform the data, summarize and format the data for the business manager. Business manager means end user, right? So that is our goal in order to describe this AWS IoT Core as such. So in order to accomplish the above said objectives, what you need to, we need to register a sensor within AWS by adding a device using the AWS IoT console. So we already know what is AWS IoT console is. So what we need to do first? We need to do first to register our sensor, and in AWS IoT Core, we will call it a thing. So we need to register that thing in the AWS IoT Core, and then only it is going to communicate. Now, second step is secure the sensor by using its roles, policies, certificates in the AWS identity and access management. So now I have to define IAM service. As you can go through this AWS IoT console, let me do my screen is visible of AWS IoT Core? That is website?
Yes, sir.
Okay, right. So let me go to MH2. Okay. this is correct. Password again I have to enter. Enter this password. Now MFA code. Again, I have to go to my Google Authenticator. So this is my Google Authenticator that I have downloaded on my mobile phone. I'm using this code. Has been logged in. So I can search for the services. So either I can search from the console. This is my console, right? So in this console, as you can see, my first tab is services. Second is search. Third is what we can say the where actually I am working. Maybe I am working in US East, North Virginia or Ohio. So where actually in which particular region I am working, it will be described by that particular region, right? If suppose we can have some more lectures, so we can go into this deep of the AWS as such. But presently I am working under this US East, North Virginia, and I am searching for my service that I want to utilize. So either I can go from this all services tab over here to the AWS IoT core, that is at the end, or maybe I can search for this IoT core over here. So it is going to give me this IoT core. So that is, you can find it over here. So I can easily log into my service, that is AWS IoT core. So you can see this IoT solutions for industrial, consumer and commercial. So I can connect a device, I can have some pricing, so cost calculator. So every time whenever you are using this AWS IoT, you have to be very precious about what kind of resources that you are utilizing. Generally, with AWS free tier account, you will get T2 micro that is being associated with like around 1 CPU and 1 GB of RAM that you are being given in order to transfer the data, right? So in the manage option, I can go to the things, I can register a thing over here, right? So first, my first step, however, I have already registered this particular thing. I can delete this. So I can delete this. Okay. As you can see, none of the device is going to be connected over here. So first of all, I have to register my device over here. So with the option of create things, I can create a thing. Or if suppose I have already created some things over here, so each device that I'm going to connect with that particular, what we can say, AWS IoT core, I have to register that device with a thing. Like for example, if you can see, if like my camera is visible to everyone and you can see like this, maybe I can. So as you can see, this is my ESP32, right? So this is my ESP32 hardware, as you can easily see, and it is basically having one Wi-Fi module and some Bluetooth concept and some GPIO pins over there. So it is my simple ESP32 module. However, it is basically a development kit, right? So as you can see, if I just remove this back over here, so if you can see that in the back side of it, it's being written that it is a development kit. And it is like ESP32 development kit TV1. So you can use this particular kit in order to implement various kind of connections initially. But you can even go to Raspberry Pi or any kind of hardware that you can use. But initially you can start with this particular hardware only, because it's very easy to understand, right? So you can go to AWS IoT core from here and just create the things over here. Again, I will go to my PPT. So by just adding a device using the AWS IoT console, then secure the sensor by using roles, policies, and certificates. Means I have to create my IAM policies and the certificates for AWS identity and access management, because this particular IAM is going to play a vital role in order to define that what the things can do. Means either they can have transfer the data, or they can receive the data, or they can do both, right? So for that, I have to define the policies. Then establish communication with the sensor by modifying an existing policy to suit the business objective. Then we have collect data from the sensor by establishing communication to the device and collecting data. then transform and utilize or visualize data by using AWS IoT rules engines to transfer the data into AWS IoT Analytics and Amazon QuickSight. So this enables you to transform and visualize the data into an easily readable format for the business decision makers. Means like it's a whole system that we can define into the AWS. We have to go nowhere, right? What we need an internet connection, we need devices, and third thing, that is the AWS console account. Nothing else. These are the three things that we needed, or nothing else what we require, right? Next. So review the best practice by identifying your IoT accomplishment and discussing AWS best practice for telemetry. Now, overview of AWS IoT Core. So the AWS IoT Core, it provides secure bidirectional communication between interconnected devices such as sensors, actuators, embedded microcontrollers, or smart appliances and the AWS cloud. Means I am connecting, or I'm just controlling each and every devices, or what we can so call sensors, or the actuators, or the microcontrollers through my cloud using an interface within this AWS IoT Core and the sensors. So you can also create applications that enables your users to control their devices from their telephone or from their mobile phone, or maybe you are using tablets, right? Because what we have, we simply have what we call it a browser, right? We simply provide the AWS IoT Core is going to simply provide a browser in your mobile phone. Just simply go and browse that particular website. Maybe it's a DNS server, or maybe it is like what we can say domain name that has been given to you using this AWS IoT Core, and you just log in onto that particular domain name and you can access the data that is being provided by the IoT Core. Again, it depends upon the kind of certifications or kind of certificates that you have been issued to different users, right? Or what we call it here, rule engines. So AWS IoT Core is composed of 6 main components. One is IAM, that is identity and access management. It provides authentication, authorization, and easy onboarding of devices. Then device gateway, securely connect IP connected devices and edge gateways to the AWS cloud and other devices at a scale. Then we have message broker. It processes and routes data messages to the AWS cloud. Rule engines, that triggers action in the AWS cloud. Then device shadow, it enables applicants to interact with devices when they are offline through a digital twin. Then the registry, that helps to enable device registration and acts as a catalog of devices and their security certificates. So this is all about AWS IoT components, right? So one is AWS IoT Core, then we have a device gateway, then we have a message broker, then we have a rule engines, then we have a device shadow, and then we have AWS IoT registry. So based on these 6 different components, we can implement any kind of applications using AWS IoT console, right? So what our aim is to develop an application using this AWS cloud to the far areas, right? So we can control our home appliances or any sensors or any actuators or any controllers using this AWS IoT cloud. So as you can see, identity and access management. So my first thing that comes over here, as you can see, is AWS IoT Core. So you can have this AWS IoT Core over here. So it does. So AWS IoT Core provides a secure communication channel for device to communicate with each other and other services, right? So AWS IoT provides authentication by offering the following options. So what is the protocol that it uses? So it uses MQTT protocol. So it is very lightweight protocol. However, it is not a proprietary of the Amazon, but it is being used by the AWS. What is there? So do my screen is visible to everyone? That's identity and access management?
No, sir.
Yes, your screen is visible.
Yes, sir. Screen is visible.
Right.
Yes, now it is visible.
Okay.
Make it full screen, sir.
Is it full screen now?
Yes, sir. Okay, sir.
Okay, right. So this AWS IoT components, so basically AWS IoT is having 6 different components. One is AWS IoT Core, then is device gateway, then we have message broker, then we have rule engines, and then AWS IoT device shadow, and then we have AWS IoT registry. So this AWS IoT component slide is visible to everyone?
Yes, sir.
Okay, great. So This is first part, that is identity and the access management, what we call it IAM service. So if I go to, okay, again, if the screen will lost. Okay, so let it be there only. So AWS IoT Core, so it is going to provide authentication by offering the following options. So the protocol that it uses, it's simply called MQTT protocol, what we call it Message Queuing Telemetry Transport Protocol. So this protocol is being used by the IoT Core over transport layer security. So just relate everything with the model that we have studied earlier. Maybe it is TCP/IP model or the OSI model. So everything you can relate with them so that you can understand them very easily, right? So it is like SIG v4 and X509 certificates and custom authentication tokens over there. So SIG v4 over HTTP will runs, MQTT over WebSockets, which is similar to other AWS services. So you can also use custom authentication tokens that are provided by your authentication or authorization service. So AWS IoT also provides flexible authorization options and fine-grained access control through JavaScript object notation policies, what we call it JSON policies. So Message Queuing Telemetry Transport Protocol, what is this MQTT? So MQTT is a publish subscribe, like as we have understand that transmit or the receive or the send and the receive. So here what we call it publish and the subscribe, right? So publish means send, subscribe means receive. So messaging transport protocol, it is a lightweight, open and designed for easy implementation. So these characteristics make it ideal for use in many situations. Means you can take any project of IoT cloud, you can take any project from any company, you can just put that particular project onto this IoT cloud and it works very beautifully, right? So you can give your like the person who is giving the project, it's a very flexible and the very, what we can say, easy to use, very easy to implement and easy to handle kind of environment. So like the person can use it very easily, right? So such as the communication in the machine to machine or in the Internet of Things context, where a small code footprint is required and our network bandwidth is at a premium. Like because we are using ESP32, right? And it is a very small amount of memory, maybe 1 MB of memory. So we cannot burn a large code. Suppose that I'm using machine vision application in order to get it accomplished through ESP32. But I cannot run that particular machine vision code or maybe a computer vision code or maybe any deep learning algorithm on my ESP32. So we can run that particular code onto the cloud and we can get the data from the camera console of ESP32 and we can analyze it onto the cloud and then take the decision depend upon our requirement. So this is how actually cloud is helping in order to like get the data from the IoT devices and can utilize it in just analysis and various kind of implementation. So MQTT is especially useful in the context of IoT because it enables easy bidirectional communication. It doesn't require you to know who is sending the information and who is listening. And it allows for reduced consumption of resources, which is valuable in a world of hardware constraint. Because our hardware constraint is what? It's nothing but the bandwidth. It's nothing but the data that it can handle. So my hardware cannot handle large amount of data because it's very small kind of hardware, maybe ESP32, right? So what we need that most of the hardware processing could be done at the cloud, right? So that we can do. So AWS IoT Message Broker. So second part, that is AWS IoT Message Broker is a publish subscribe broker service that enables the sending and receiving of messages to and from AWS IoT. So communicating with AWS IoT clients sends a message addressed to a topic like a sensor, temperature, or room. The message broker sends the message to all the clients that have registered to receive messages for the topic. So as we have understood, like send and the receive. So what we will understand over here, that is publish and the subscribe. So it can be defined under the policies in the AWS IoT Core. We will look into it in our later slides that how it's going to be implemented. So basically message broker is what? It is nothing but to maintain a list of client sessions, right? And the subscription for each session that the client is subscribed for a particular topic or not, right? So the broker checks for session with subscription and map it to the topic. Like for example, if we can use a concept, what we call it MapReduce. It's again a service that will be provided by the AWS. Again, it can be a like service that can be used by AWS, but again, it will come on the AWS IoT device. Like, so my next part in the AWS IoT is nothing but AWS IoT device gateway. So AWS IoT device gateway enables device to securely and effectively communicate with AWS IoT Core with the help of AWS IoT Message Broker. So for that we have used the message broker. So in order to that, so that gateway will communicate or enable to securely and effectively communicate with the core, right? So the IoT device gateway can exchange messages using a publish subscribe model, which enables one-to-one and one-to-many communication. So the AWS IoT message broker. So as you can see, there are various IoT devices which are being connected to the message broker. So an IoT message broker processes and routes data from our devices into AWS IoT core. So message broker is scalable and has low latency and provides reliable message routing. It also helps a publish and subscribe model to decouple devices and the applications. Then we have AWS IoT rule engines. So these rule engines are going to define the different kind of storage services. So when a matching message is received, the rule acts on the data, such as writing data to the Amazon simple storage, that is S3 bucket, or invoking an AWS Lambda function, or sending a message to an Amazon simple notification service, right? Basically, Lambda functions are something like what we can do serverless computing. We are going to define some functions that is being used to utilize in order to convert, say, for example, the data from one form to another. Like, for example, if suppose I can say an example, like, for example, I'm using Facebook, right? And Facebook is having different kind of, means you can upload various kind of videos on the Facebook, right? But again, Facebook is used to analyze that whether this particular video could be like it's a kind of video that could be posted on the Facebook or not. Maybe there's some kind of videos which are not likely to be posted on the Facebook, and how Facebook could be utilized, how Facebook could be analyzed that. So for that, it is having some sort of Lambda functions which are used to define in order to find out whether the particular data could be posted or not, right? So that can be done with the help of this Lambda services. So again, in the same way, we can use some Lambda function or sending a message to the Amazon simple notification service, what we call it SMS. So we have this AWS IoT device shadow service. So again, actual device is being created in the AWS IoT core as a shadow. Means that suppose that my device is down. So if suppose my IoT core wants to send some message, so it will send the message to the IoT device shadow, right? So when the device comes online, the same data could be copied into the device itself, right? So it often referred to as a thing, shadow, or a digital twin. So device shadow service maintains a shadow for each device you connect to AWS IoT. You can use the shadow to get the state of a device over MQTT or HTTP, regardless of whether the device is connected on the internet or not. So each device shadow is uniquely identified by the name of the corresponding thing. Now AWS IoT registry. So AWS IoT registry is a database of services of devices. So it's using the registry for your device is optional. However, the registry helps you manage your device ecosystem effectively and act as a repository for device certificates, right? So when we are going to create a thing into the AWS IoT core, it is going to create some certificates in association with the device, maybe the public key, private key, and the CA certificate. So there are basically 3 certificates that are going to be created with each and every device when we create a thing into the AWS IoT core. Right. So this is the basic diagram that how we are going to represent the devices into the AWS IoT core. So as you can see, here we have the device, but there's a device shadow that is being created over here. And it is being controlled by using the API, and we have the AWS services over here, and we have a gateway that has been defined over here. And we have this rule engines, right? So things in AWS. Okay. So now we come on to our core part. So a thing is a representation of a specific device or the logical entity. It can be a physical device or sensor, for example, a light bulb or a switch on a wall. It can also be a logical entity, such as instance of an application, or a physical entity not directly connected to AWS IoT core, but related to devices that do connect to AWS. For example, a car that has engine, sensors, or a control panel. Like, for example, nowadays we have heard so many things about driverless cars. Right. So how the driverless car is going to be work? It is going to give like to go left or the right or way straight. So it is going to analyze the different situation and then connect it to the cloud. And then there will be some deep learning models or maybe some machine learning models over there. Those are going to optimize the output and get connect with the car and give it a message whether it is going to left or the right, depend upon the GPS coordinate as well as the location of the car, and depends upon the traffic conditions. So it is going to analyze various inputs that has been taken from the different sensors that has been put onto the car, and that will be analyzed into the cloud. And on the basis of that, my car is going to take the decisions, right? However, that comes under the category of what we call it reinforcement learning. Like, so if machine learning is also itself having different categories, that like machine learning, deep learning, or what we can call it supervised, unsupervised, and then again we have some sort of reinforcement learning over there. So where we have different kind of environment and different kind of policies that we are going to create. So it's like an amalgamation of various kind of things, maybe machine learning, maybe computer vision, maybe IoT, maybe cloud. So each product is nothing but a combination of all these kind of technologies, right? So if I'm going to deploy a particular project, if I want to deploy a particular product, then we must get to know these particular different modules. Then only we can deploy a particular project as such. So information about a thing is stored in the registry at JSON file, or what we call it JSON data. So examine the following block of JSON data. You can view the name, value, and all these kind of things. So a thing type limit. So there are some certain limitations with AWS IoT Core. We can have some attributes, we can have some naming, so we can name the device, standardization naming by convention things. But there are two things to be noted. After you create a thing type, you cannot change its name, right? So once you create a device, you have given it a name, you cannot change its name. If suppose you want to change a name, you have to create a new device with a new name. Now you can associate or disassociate a thing from a thing type. Disassociate your things from a thing type before debracketing or removing the thing type, right? So we can do that thing, but we cannot change the name of a thing type. So how do you change a thing type name in the AWS management? So there's a quiz we can have. So there are some options. So what could be the correct answer? So we can create a thing type with the correct name and disassociate the things that use the original type and associate them with a new thing type. The other question is, it's a true false. You can simply answer them. So the name of the thing type, it can naming the groups be universally unique, false and true. So obviously it could be false or true, it could be false. Their name must be unique only within the account. Then how many thing types that can be an AWS IoT thing be associated with? So how many things that we can associate? 1, 2, 3, or numerous. So obviously it is 1. Then comes on to device security. So about device security, so we can have this AWS IoT console, and we already know that the security could be handled by this IAM service of the AWS. So that AWS IoT service is used to, like, it roles allow AWS IoT to access other AWS resources in your account on your behalf. For example, if you want to have a device published, it's state to a DynamoDB table, which is like nothing but my database management. So IAM role allows AWS IoT to interact with Amazon DynamoDB. So again, it depends upon what kind of what we can say policies that you have defined. So all communication is encrypted with transport layer security, that's what we call it TLS version 1.2, to ensure that your application protocols remain secure and confidential. So not all devices support TLS 1.3 version 1.2. So when adding devices to your fleet, ensure that they are going to support this TLS version 1.2. So authentication and authorization performs different roles in securing the devices. So let's examine these device authentication and authorization in more detail. So we can have this authentication, that is client authentication, and the certificates that are used to be allowed in order to access the services through the AWS IoT Core. So certificates that are nothing but the enabled symmetric keys. Now it is using X509 certificates, which is a public key infrastructure that is standard to associate a public key with an identity contained in a certificate. So in addition, X509 certificates are issued by a third party called a certification authority. So what we have going to understand. So there are 3 main certificates: public key, private key, and the CA certificates that has to be utilized in order to get an identity and the access management to be controlled for a particular thing that has been registered in a AWS IoT Core. So X509 certificates chains are being used for both the server authentication by clients and the client authenticated by the service. So certificates are created within AWS IoT Core and downloaded to the device through TLS version 1.2. Before the device can authenticate it, the certificate must be activated. So in addition, certificates can be revoked if there is concern that the device has been compromised or is being decommissioned. So device authorization, again, we have some authorization concept over there. So for that, we have defined some policies. So how this AWS IoT IoT can provide security to the user as well as to device. For user, it has some AWS security credentials and some IAM policies. So this user can be secured from these two ways, whereas devices can be secured with the help of IoT certificates and the IoT policies. Now it is the user who is going to define the IoT policies, right? So whether it is being like to able to publish or to subscribe. So policies and roles. So IoT policies. So IoT policies primarily control identity access to the IoT data planes, right? So in AWS IoT, the data plane enables you to send data to and receive data from the AWS IoT. This means that the data plane defines whether you can connect to the message broker, send or receive MQTT messages, or publish or subscribe to a specific topic. So we have some IAM policies that has been defined, as well as the IAM roles that we have to define. Then policy formats. So again, we have the policy formats, which are nothing but the JSON document. JSON documents are nothing but the Java subscript documents. So the policies are then attached to the device user or role to give them the permission written in the policy. So the AWS IoT policy is a JSON document that contains one or more policy statement. So each statement contains effect, action, and the resource. So this is what we have. This is nothing but a policy format. It is nothing but a JSON document that has been attached with each and every thing. So policy actions. So IoT, if I given this nothing but an IoT, so it connect represents permission to connect to the AWS IoT message broker, IoT subscribe, IoT get things shadow. So we can again define our own policy actions. Next, we comes on to some quizzes. So why is it important to ensure your device that are TLS version 1.2 compliant? So I have to select any two. So not all devices support TLS version 1.2. TLS version 1.2 ensures that the application protocol remains secure and confidential. TLS version 1.2 helps filter data entering AWS. TLS version 1.2 defines the number of topics to which the device can publish and subscribe. TLS version 1.2 is an all device by default. So there are the two answers. So not all device supports TLS version 1.2, and TLS version 1.2 ensures that the application protocol remains secure and confidential. So this is what about TLS version 1.2. Now, what format in an AWS IoT policy written in? So as you already know, it is the JSON format. So my answer is Java script object notation. So these are my JSON format in which my policies are going to be written. So what does an AWS IoT policy define? So which devices you can use, what an authenticated identity can do, who can connect to AWS IoT? AWS IoT does not use policies. So my answer is what an authenticated identity can do, that will be defined by my AWS IoT policy. Now we comes on to AWS IoT message broker. So we have my device that can publish and subscribe, and we have this IoT core, and then how the device is going to communicate using this MQTT protocol that we will discuss in the upcoming section. That is what we call it, the message broker. So about message broker. So the AWS IoT message broker allows clients to communicate with AWS IoT core, and for AWS IoT core to communicate with clients, client sends data by publish. Means whenever we send the data, it will call the publish, a message on a topic, right? So clients receives message by subscribing to a topic. So when the message broker receives a message, it forwards the messages to all the clients that are being subscribed to a topic. So topic are 8-bit Unicode transformation format, encoded hierarchical strings that use a forward slash to separate the labels in the hierarchy. For example, this topic refers to a temperature sensor in room 1. So in a room 1, I can use different sensors where we can attach a topic to a particular sensor, right? So we have some supported protocols. So again, we have this MQTT protocols that have been supported by what we can say. It also used HTTPS protocol to publish. So both protocols are supported through IP version 4 and IP version 6. The message broker also supports MQTT over the WebSockets protocol. So the way you connect to the message broker depends on the protocol you are using, means either MQTT or whatever it is. So different protocols require different authentication mechanism. So what is MQTT? So it is widely adopted. It's like, so is it Amazon proprietary? No. So we are using how it works. So basically it is used to work with this like publish and subscribe module. Then why it is using AWS IoT core? Because it's a lightweight protocol. So it doesn't require that much of like infrastructure or the hardware is concerned. So it is very much bandwidth limited protocol. It is. So it is secure. So yeah, it is secure because it is using TLS version 1.2. So does it support browser-based application? So yeah, it is going to support WebSockets. So we can use to communicate with this MQTT using WebSockets. Now, IoT device registry. So about device registry, so AWS IoT provides a registry that helps you manage things and organizes the resources associated with each device in the AWS cloud. So this is my catalog of the device, what we can say metadata. So I can connect this my AWS IoT device in a catalog of static metadata and attributes about the devices such as serial numbers, manufacturer, firmware version, internal identifier or the batch number, and the device capabilities. So I can use the metadata in order to register my device. This is the way we can write the JSON format in order to make my device to be registered. So I can use different kind of metadata that has been associated with the device on the AWS IoT core and for devices that can be connected using MQTT or the WebSockets. So a device shadow is a JSON document that is used to store and retrieve current state information for a device and can be used to update a device that is offline or unreachable. Means that suppose that my device is going to be offline. So how my data is going to be transferred? It is going to be transferred to the device shadow. So it is going to store that particular data. And then again, it's going to use the different keys. So these are scalable and the certificate repository that we can use. So again, we have some quiz. So what is the role of MQTT within AWS IoT? So there are some options. So obviously it is used to publish and subscribe to topics. So next question, what are some of the features that can be used or what are some of the features of the AWS IoT registry? So we have to select any three. So these are the options. It is usually managed and scalable to more than 1 billion devices. Then we can have this. It is repository of device certificates. It enables you to test communication with devices by subscribing of specific topics. And there are some other options. So what could be my correct options? It is a fully managed and scalable to more than 1 billion devices. It is repository of device certificates, and it is a catalog of static metadata and attributes about the. So this is about the registry. Now, next question. MQTT over WebSockets supports browser-based application. True or false? Yes. It is true because it is used to support it through WebSockets. So far we have registered a device, applied a security role to the device, and customized the device policy, downloaded the private and public certificates to the device, and activated the certificates, then established communication. So now you can also view the data that the device is sending. So the objective is to visualize the data to the decision makers at any particular industry. Here I have taken an example of the ice cream industry. So we can use to communicate the device data into the industry itself. Now background for rule engines. So by definition, a sensor will sense as long as it has power. So accumulating every bit of data from a sensor means that you will have a large amount of received data that's not useful for your business objectives. Because of the amount of data collected, you can filter or direct data to different location in the cloud. So for that, we have different kind of rule engines. So you can use these particular rule engines. So writing data from a device to an Amazon DynamoDB database, then invoking an AWS Lambda function to extract specific data, and then we can saving a file or a set of data to Amazon Simple Storage Cloud, and that can be done with the help of different kind of what we can say APIs, or maybe we can say different kind of platforms. Maybe you have heard about some of the platform, what we call it, say Terraform, or maybe I can have different kind of Linux interface that we can use in order to, without actually logging into my AWS console, I can use that particular data and I can use that particular services from the AWS using different kind of what we can say local some sort of softwares that I can install on my devices locally, right? And Terraform is one of them. So rule engine languages, the rule listed in the example code inserts all messages sent to the IoT test topic and places them into the Amazon S3 bucket called my bucket. The SQL statement filters these messages, and the role ARN gives AWS IoT permission to write on the AWS Amazon S3 bucket. And what kind of language that it uses? The rule engine uses SQL-like statements, that is structured query language, that is SQL-like statement, and that are built within a structured development environment to filter and route MQTT messages. So again, some questions. The AWS IoT rule engines can interact with AWS Lambda without needing IAM permission. True or false? Obviously, it is false because we need some identity and access management permission in order to access this AWS IoT core. Then because the AWS IoT rule engine is a component of the AWS IoT core, it can interact with all AWS services without needing permission. Is it true or false? Obviously, it is false, because again, it is the IAM services that will design, what kind of services that can be used. Now, what type of language does the rule engine uses to configure its rule statements? So obviously, it is SQL-like languages. So we have this SQL-like languages. Now comes on to the last part, and I have how much time? It's like 10 minutes are left. So we are going to complete this AWS IoT analytics. So we have developed an IoT, like what we can cloud. We have connect the devices. We have got the data. Now how we can analyze? So for that, the AWS IoT is going to provide you the services like AWS IoT analytics. These are somewhat, we can say, the display kind of services, or we can say some sort of graphical output that we can obtain. So AWS IoT analytics automates the step required to analyze data from AWS IoT devices. You configure the services to collect only the data you need from the devices, apply transformations to process the data, and enrich the data with device-specific metadata such as device type and location before storing it. So then you can analyze your data by running queries using the simple built-in SQL energy query engines, or perform more complex analytics and machine learning interface. So we can use this kind of, like what we can say, analytical model. So as we have understand, if we like very much familiar with various kind of machine learning domains, then the analysis could be done very easily using machine learning algorithms. So we can just provide a framework over there in the cloud, so that it can recognize the data from the IoT device and then apply some sort of what we can say deep learning algorithm or any kind of machine learning algorithm in order to extract the information and then make an analysis out of the outcome that we have received, and then we can make a feedback mechanism, or we can compare that what actually we needed, or like for example, if we want to control the AC, or maybe we can control our motor, or maybe we can just use to have some sort of decision that we can take based on the sensor output. So we can do that. So analytics terminology, we have this channel, then pipeline, then we have data store, and then we have data set, and then we have data set contains. So these are some of the parts of what we can say IoT analytics terminology. So we have channel. So channel collects and archives raw unprocessed messages data before publishing this data to a pipeline. So after that channel, there's a pipeline. So a pipeline consumes messages from a channel and enables you to process and filter the messages before storing them into a data store. So after pipeline, there comes data store. So everything is linked all together, right? So we can connect all these, and once I create the data store, I can create a data set, and from the data set, I can run an SQL query, and then from using this query, I can get the data set contained or the results. So the results after you create data set contains, you can view and then from the console. Right? For example, what is the temperature of the room? So the temperature of this room is above a critical value, then the AC will get automatically started, and my AC is connected to the cloud. So we can control my AC by using the room temperature using the cloud, right? So this is the way we can communicate between the devices. Now Amazon QuickSight overview. Again, it is an analytical part of it. So Amazon QuickSight is an analytics services used to visualize data and perform analysis. With Amazon QuickSight, you can quickly set up your portal and visualize the data. If necessary, you can receive data from multiple resources. For example, regarding your ice cream truck company, we could potentially receive data from the IoT device origin, the entire fleet, and IoT device destination to develop a complete understanding of product being shipped and potential reasons for the ice cream spoiling. Recently, what we can have a project, one of the company that are used to store to manage their, what we can say, storage, what we can say, like for example, they have a store, for example, they have an area and they want to put the things all together into that space, and they want to optimize the store so that they can store more things, or like as more as things possible. So we can optimize the space based on the IoT also, right? So we can utilize that space more effectively by using these IoT devices and with computer vision library, right? So again, it is a different kind of application that we can apply. So closer analysis of the process. So we have collect, process, store, analyze, and then build. So detailed overview, we have collect, then process, then store, analyze, and build. So again, some questions. So we have to match the following. So what is channel? What is data store? What is data center? What's pipeline? So we can match the following, something like this. So with A, the channel, it belongs to 2, that is define the data that you want to collect. And data store is nothing but my option, that is 3. It saves the optimized data for analysis. Then we have data set, that is C, that is it's equals to 4. It analyze optimized data by applying an SQL action. And then we have the pipeline, that is process the data supporting transformation and enrichment. So we can have the process, we can have these terms that we can remember based upon their utility, and that after which particular term, which particular thing that we need to implement. So what are some of the benefits of Amazon QuickSight? You can select any 3. So you can quickly visualize data and perform the ad hoc analysis. You can create dashboards and portal to visualize your data. It can receive data from multiple resources. It automatically sends your data it thinks you need. It helps improve your personal eyesight, and it itself determines the data about that you are able to see. So what we can have the answers. So these are the 3 main correct choices that we have. Then what is the purpose of using AWS IoT Analytics? So we can have to automate the steps required to analyze data from IoT devices. So what could be the best answer? The best answer is to automate the steps required to analyze data from IoT devices. So again, we have some final quiz. So I'm not going into the quiz. I'm just moving on to the last part. So that quiz will be done later on, if suppose we got enough time. And now we comes on to the final part. Okay, so this is my AWS IoT as a whole. Do my screen is visible to everyone?
Yes, sir. Yes, sir. You are visible.
Okay, great, great. So this is AWS IoT as a whole. So we can have the device SDK. Device SDK means what is the client. Suppose that I'm using ESP32 Arduino library. So I have my Arduino as an input. So I can create my sketch and can upload that particular sketch into my ESP32 by using AWS IoT template. It's a different scenario that we may need whole one week FDP in order to understand all these kind of stuffs. But again, I'm going to cover it in a short. So this is my device SDK. Then I have to authorize or the authentic authorization. After that, we have a device gateway. Then we have this rule engines and the device shadow that has been created. However, everything is being governed through this device registry. And then we have these applications that we can run over either on my mobile phone, that is on Android application, or maybe I have my laptop that is being running that particular application. And we have this backend that we have the AWS services. Now, if I'm going to use these particular things, they can be work with different kind of hardwares. Maybe it's Arduino Nano, or maybe Arduino Nano Every, or maybe Nano 33, or maybe 10C, or maybe Tessel, or maybe ESP32, or maybe Arduino Uno, or maybe what we call it Node MCU. So it can work with different kind of devices. For example, I'm taking this ESP32 development kit that I'm using with this my particular operations. So I'm just ending within like 5-10 minutes. So just bear with me. So I hope that it's almost 4:30 is there. But again, I'll take 5 more minutes. So we are going to communicate with the IoT core with this ESP32 using publish and the subscribe, as we have understand. So we are going to publish topic, or we are going to subscribe topic, and we have this host, that is IP address, that is going to be defined with this AWS IoT endpoint hosting. So here we have this IP address that has been defined by the endpoint hosting, and the port number for MQTT. If I'm using MQTT, then a port number that have to define, that is 1883, and if I'm using MQTTS, then it's 8883. Then we have AWS IoT core. So what we have to do? So it is a 3-step process. First, we need to create thing in an AWS IoT core, save certificate and keys. Then second step is download the Amazon root certificates. And what could be my step 3? Then we have to prepare the credentials. What is my credentials? That is device certificate, private key, root certificate, thing names, AWS IoT endpoint host, and AWS IoT endpoint ports. So that is all. Thank you to all the researchers, faculties, scholars for whose data has been incorporated in the above slides. So here I am ending with my presentation, and I hope I have delivered a bit of myself.
Thank you, sir. Thank you so much, Bhatt sir, for providing us that much valuable knowledge. And this is time to queries. If any participant is having any query, they can ask to our expert.
Yeah, please.
Yes, participants.
Or maybe if you have, or maybe if you have any queries, you can just send it to Vikas Gupta sir, or you can have my mail ID from like COEP website. You can get my mail ID from COEP website. It is bhat.extc@coep.ac.in. So you can send me any query, and if you want to like make myself to be like one of the part of your project, if you want to do any project with me, I'm really open for that. And definitely we are going to do some good project. We can have a great association as such outcome of this particular FDP itself.
Sir, in near future also we will be benefited by your knowledge by these type of talks.
It's not like knowledge actually. Before like all the senior faculties who are been sitting over here, maybe it is Vikas sir, maybe it's Vibha ma'am, and maybe Nimade sir, who is like the genius of embedded systems. So in front of all of you, maybe I have just put a bit of my contribution, nothing else.
Yes, okay. Thank you, sir. And now this is the time to summarize all the things. And this is the end of our today's session. And all the participants, if any query you are having, you can ask to expert. If there is not any query, we are now going to.
Madam, am I audible?
Yes, sir.
Abhishek sir.
Yeah, please, sir.
Thanks a lot for your such a knowledgeable and valuable presentation. Sir. And in a very time-bound situation, it is very good. Thanks a lot. And now over to Madam. If anybody is having any query, they can ask to the expert, Dr. Abhishek Bhatt sir.
Hello.
So hopefully everything is a bit clear to everyone. But I am pretending. Right?
Okay. So now we are going to end today's session. And we will meet tomorrow at 10 o'clock sharp. So all the participants, we will meet tomorrow at 10 a.m. So please take care of time, join on the time. Okay, sir.
Okay, thank you, ma'am. So once again, say my thanks to Anurag Chaubey sir, especially because maybe I forget his name in the initial. So just say my thanks to Chaubey sir as well as Verma sir. Maybe I have also like forget to mention his name also, and especially Sashi Jain sir, under whom I have worked a lot.
Sir.
अरे योगदर sir, क्या हाल चाल है?
Sir, namaskar sir.
Namaskar. And Yogadar sir itself, like he is like one of the what we can say mentor for me as such.
Sir. Thank you, sir.
Right. Okay, thank you, sir. I'm leaving now.
Thank you, sir. Thank you so much.
Okay.
Thank you, sir.
Thank you, Abhishek, sir.
Thank you, sir.
And all the participants, kindly be aware that from tomorrow onwards, we cannot be able to share the link on the WhatsApp group. We have to take. You have to take the link from your chat box only. And thanks for all the participants to be patient and in that way, and allow all the speakers to cooperate with the session and everything. Thanks a lot. Abhishek sir, thank you.
Yes, sir.
Over to Divya madam.
Thank you, Abhishek sir. And thank you all the participants for patiently attending the session. Okay, so we will meet tomorrow. Now we are going to end the session.